Pro model, and it even comes with integrated charts. Learn more at agrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at agrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
AG Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
AG Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
everyone, and welcome back to the second day of the world's biggest React conference. Day one was filled with insightful talks, discussions, great speakers, and amazing networking opportunities. So we're excited to see what day two has in store for us. Let's make it even better than day one.
Yeah, I'm super excited and thrilled to be here. Hey again, everyone. Day two is going to be awesome, and it's so good to see you all. Hey again, Andronica. How's it going?
Hey, Josh. My name is Andronica Klaas, and I'm a QA engineering lead at the home of summit-qna. I currently specialize in compliance and privacy, and I'm thrilled to be a part of this day. So throughout the day, please make sure that you reach out to me on Twitter/X. My handle is Andronica_Klaas. Let's get to chatting.
And hey everyone, I'm Josh Goldberg. I'm a full-time independent open source maintainer in the TypeScript ecosystem. I'm also the author of the O'Reilly Learning TypeScript book and Microsoft MVP for developer technologies. You can find me on Twitter and basically every other social media network as Joshua K. Goldberg. Always happy to chat.
Nice to meet you again, Josh. We have people that are tuning in from everywhere. But in case you're wondering how many people are part of this conversation today, we are looking at 14,791, which is so exciting and amazing. And we want to say to each and every one of you, hi, welcome. Thank you for joining us. And we're excited to talk about React with you. Talking about everywhere, if you're interested in finding out where people are coming in from, we're talking about Asia, North America, South America, Europe, Australia. We have people tuning in from everywhere. We are international.
14,791. Amazing. We, of course, also want to thank our gold sponsors, without whom this event would not have been possible. So thank you, Sentry, Content AI, GraphBase, Focus Reactive, Clerk, and Cloudflare.
And also, let's not forget our media partners. A huge thank you to all of our media partners.
And also, shout out and thanks lastly to the program committee. Thanks, fellow PC members. I think we did a wonderful thing, and I'm really excited and was thrilled to work with y'all. Hey again. But also, audience members, hello, we want to see and hear from you. So please post/tweet on Twitter/X and LinkedIn with the hashtag ReactSummitUS. We want to see photos of what's going on at your end, where you're tuning in from, what your setup looks like. And we've got a raffle of multi-passes to Git Nation conferences and some pretty sweet t-shirts. So hit us up and you might win some. This is what's going on my end. It was nice holding Jerry for the 2 seconds while it lasted, but now he's next to me on the windowsill. Dronica, I believe this next photo is of you.
Well, Josh, no Jerry on my end, so not as fortunate as you, but I do have you guys, my amazing setup, and I am excited to connect.
Definitely. And in case you need any additional incentive, look at these freaking t-shirts. Amazing, beautiful. I want one, and I'm sad that we are not eligible. But it's going to be a great time. Please tweet at us.
Yeah, Josh, I'm with you on that one. I do wish that I could get a t-shirt, but it's for the amazing attendees, so no hard feelings. For the conference agenda and all information, please visit our website at reactsummit.us. Again, the website is reactsummit.us. And if you want to continue the conversation, make sure that you join our Discord server. Find the link in the timeline and the org email. To stay updated on announcements, connect with remote speakers and attendees. Do not miss out. You want to be sure that you are connected. And don't forget to ask questions to the speakers in the Q&A channels.
Yeah, we want to hear them. Here's a screenshot of what the navigation on the website looks like. The main screen has a video player that plays the live feed, and then on the bottom below it, we've got a timeline of events that are happening in the conference. Just zooming in, focusing a little bit, you can see the timeline has 2 tracks, the Summit track and the Basecamp track. You can see what's live at the moment, what came previously, and what's coming up next.
That is some pretty exciting stuff. Additionally, you can also join discussion rooms on spatial.chat, which we'll discuss shortly. But if you're lost at any point, please write to us in the hashtag troubleshooting channel on Discord. We're here to help and make sure that you have an amazing experience with us. Now, talking about spatial.chat, if you want to hang out with fellow attendees, speakers, watch the live stream together, and join discussion rooms, go to spatial.chat and find the button on the watch page.
Yeah, for those discussion rooms, we got 3 really exciting topics, some of my favorite things in tech. First, we got accessibility, how to convince your team to do it, how to implement it, and how to maintain it. Then we've got TypeScript, generally awesome to TypeScript and talk about it. And then we also have design systems, another very fun thing. So I'm looking forward to all of them. You can also check out job offers from our sponsors at reactsummit.us/reactjobs or by scanning the QR code on the screen. There are all sorts of jobs there, front end in general, and especially React jobs, so check them out. You've also got the perks from our sponsors at reactsummit.us/perks. Again, you can scan the QR code on the slide or visit the URL directly.
That sounds exciting. All right, so as always, we want everybody to feel safe and have a good time during our event. We have a code of conduct at getnation.org/COC. Please go and read it. If anytime you feel there's been a violation, please email coc@getnation.org and we'll take care of it right away. We don't want anybody to feel any sort of a way that isn't great about this experience. So we don't tolerate any form of harassment in any of the channels. That includes Twitter, Spatial Chat, and Discord. And also, your feedback is incredibly valuable to us. It allows us to continually improve the event. Please visit React Summit/feedback to share your thoughts and insights. Feel free to fill out the form at any point during the event. We want to hear from you. And also, did you know that there are free remote workshops after the main conference? Be sure to register for them at portal.getnation.org. One of the workshops is the Gateway to Backend, a front-end developer's guide to stack development by the Redwood JS team. I'm looking forward to hearing that.
Yeah, me too. We've also got another exciting one, Let AI Be Your Docs with Jesse Hall. It's going to help us unleash the power of AI in our documentation with a hands-on workshop. Jesse will guide us through the process of creating a dynamic doc site supercharged with AI, ChatGPT. Lastly, we've got a double workshop. We've got Building Reusable Server Components in Next.js with Will Bishop and Metin. In this workshop, attendees will learn what React server components are, how to effectively build and use them in Next.js, and focus on one of the advantages of both React and Next.js, which is reusability through components. So please check out the Get Nation portal to get more information about all of the remote workshops.
This is all really, really exciting stuff. I am looking forward to it. Okay, enough from Josh and I. We are ready to get started. So let's go ahead and kick this off. And a thank you goes out to AG Grid, our platinum sponsor. AG Grid is the world's leading JavaScript data grid with support for React, Angular, Vue, and Solid.js. AG Grid will make your applications look great. Let AG Grid do the work, and you take the credit. All right, so let's go ahead and introduce you to our first speaker, Kent, who's going to be talking to us about the Epic Stake. Kent is a world-renowned speaker, teacher, and trainer, and he's actively involved in the open source community as a contributor and a maintainer of hundreds of popular NPM packages. He is the creator of epicreact.dev and testingjavascript.com. He's an instructor on egghead.io and front-end masters. He's also a Google developer expert. Kent is happily married and is a father of 4 children. He likes his family, code, JavaScript, and Remix. Head over to our #summit-qna channel and show all of your appreciation by sharing applaud emojis. And don't forget to ask questions to Kent. He'll be there to field them for you. Kent, the stage is yours.
Hi everyone, my name is Kent C. Dodds and I'm so excited to talk with you about the Epic Stack. Before I do, I just want to give a shout out to Epic Web Dev. By the time you're watching this, Epic Web Dev will be available, and if you haven't seen it yet, you should definitely take a look. It's everything that you need to know about building full stack applications. It's awesome. Give it a look. All right, I'm going to start out with a content warning. There's sadness ahead. This is something that happened recently, not far from my house. Well, far enough. But yeah, it's really sad, actually. To be clear, nobody was harmed in this event. They knew that this was going to happen long before it did. But basically what happened is a company put a bunch of dirt up against the side of a hill, and it didn't quite work out. The dirt fell from under the house, and a house and a half fell down the hill, which is just so awful. I can only imagine how terrible this would have been. And what's kind of ironic or sad about this is the name of the company that built the home. Designed for life, huh? Yeah. Yeah, the short life, I guess. But this talk is about the fact that we are terrified of making a mistake like this, a mistake where the likelihood is really low. It's not every day that houses fall over like this, but the risk is really high. If this sort of thing happens, then we've got a serious problem. And so I want to talk with you about paralyzing decisions or these sorts of decisions where, like I said, likelihood is low, but risk is really high. So let's talk about modern web development, how awesome it is. It's fantastic. There's so many great tools available for us to build awesome things. Unfortunately, it's also exhausting. I don't know how many of you still remember back in like 2015 when everybody was talking about JavaScript fatigue and everything. Yeah. It's exhausting. There are lots of great tools available, but exhausting. This was exhausting, putting this slide together. There are just so many tools, and some of these tools you wouldn't use together. Like some of these tools there are like competitors to each other or whatever. You might use them together if you're migrating from one to another. But the fact is, these logos represent something that people are building, that they put at least enough time in to make the logo in the first place. And there's a lot that we have to do as web developers. Now, I think we're missing one. I just realized. Oh, no, that's right. There it is. Haha. My favorite. Remix is amazing. Super huge fan of Remix. But even still, all of these tools to build a web application, it's exhausting. It really is. So here's the real talk. Almost whatever you choose will probably be fine. You could put all these tools up on a dartboard and throw a dart at it blindfolded, and whatever it landed on, you go with that tool, you'll probably be fine using that tool. And you know it. We all know it. We like to think that our project is the snowflake that needs to be like exactly with the perfect set of tools, otherwise it will never succeed. But for most of us, it really doesn't matter that much which tool we use. And yet we are indecisive. We can't decide on which of these tools to use, even though it actually doesn't matter all that much. So on the one hand, we know that it'll probably be fine, but on the other hand, we have to live with this, and we have to worry about this type of an experience where what if I do make the wrong decision, and now I'm left with this situation where I have to rebuild my app, or I have to migrate my app, and it's just an enormous amount of pain. So we're terrified of making the wrong choice, even though we know that the right choice, there isn't really a right choice. We have so many options, but choosing any of them will probably be fine. Still, we have to live with it. We're worried about it. And then once you do decide, now you have to get everybody aligned. Like we say, okay, we're going to do it this way. And then somebody decides, oh, I'm going to do it this way. And now you've got 3 combo box implementations in your app. This has literally happened to me in the past. That's where Downshift came from. And so it can be a real challenge to keep everybody on the same page once you have made the decisions. And then you make the decisions, you have to wire things together. There's not a single tool that does everything. And so, yeah, wiring things together doesn't always work out perfectly well. All of this is just a big distraction from our desire to just ship, to engage. We want to ship our software, and all of this is distracting us from doing that. So here's the deal. Some more real talk for you. I've been around long enough where I see a problem and I feel like I've got it handled. I know exactly what to do. I can execute, and things will go well. This all it comes from the opinions that I have developed over time, and not everybody appreciates or likes my opinions. I'm not gonna be like necessarily win a popularity contest on all of my opinions, but the fact is that like whatever you choose will probably be fine. And my opinions, I feel like, are pretty well based in fact. I've worked at small companies and shipped apps to just a couple of people, and I've worked at huge companies and shipped apps to millions of people. So I feel like I have a pretty good sense for what makes a great set of tools to use for an app. And so that's why I'm excited to introduce to you a opinionated project starter and reference called the Epic Stack. I've been working on this for a couple months and it's been awesome. People are actually using the Epic Stack to build applications that they're being paid to work on. So it is a project starter. Right now it's a Remix stack, but in the future, it uses the Remix CLI. In the future, I'll put together my own CLI for this, but it works really great. You just run this and poof, you've got the Epic Stack. But it's also a reference implementation. So you go to the GitHub repo, and it's a full stack application built with all these different tools with really, really great docs. In fact, Epic Web Dev that I talked about at the beginning of the talk is basically where the documentation for the Epic Stack is going to be, both in the free version as well as in paid version of the docs or of the Epic Web workshop series. So I think most people are going to get most value out of the Epic Stack as a reference implementation, because most of us aren't building new apps every day. And we're trying to evolve our existing apps. And so you can think, okay, so how did Kent do server rendered time zones? Or how did Kent do, two-factor authentication? Whatever it is that you're trying to work on. You can go reference the Epic Stack and see what's a good way to do this and follow that in your own project. Another thing that I've put together is decision documents. So while we have a lot of decisions to make and everything that can be, there's analysis paralysis and all of that, the decision documents are super helpful in helping you understand the things that I considered when I made big decisions, like why are we using this particular email service provider, or why are we going with this format for our native ESM modules, and various other things. You can take a look in the decision documents, which I think is really, really quite helpful, because it helps you get a pretty good understanding of the why behind decisions that are being made. So another awesome thing about the Epic Stack is the guiding principles. And so these are the things that kind of guide the direction of the project. To be clear, I am the benevolent dictator of this project. And so the guiding principles are pretty much how I lead the project. But hopefully if you align on these guiding principles, then we'll align pretty well on what the ultimate decisions of the stack are. So first, limit services. I think that it's important for us to own our destiny, and that can be really difficult if we're using a lot of different services. And this isn't just third-party services, which of course that definitely factors in, but this is even our own services. Every single service that you add to your application increases complexity. Now, sometimes that is going to reduce or solve other problems, and so it's worth that complexity. But especially if you're just getting started on a new project, or for the vast majority of projects that we all work on, you can have everything running in a single box and it will work just fine. And as long as that box is managed for you, because I don't want to manage a box, a virtual machine or anything. So as long as that VM is managed for you, then just say, here's my thing, and run it, and it's all together in one. You don't have as much trickery when it comes to deployments and different things like that. And costs are a lot cheaper as well. So that's one of the guiding principles, is to limit services. There has to be a real justifiable reason when you introduce a service. Now, of course, we do have some services that you have to use. I'm not hosting this thing in a NAS in my closet or something, but yeah, we want to limit that as kind of the guiding principle. The next thing is to include only the most common use cases. So the Epic Stack is a reference implementation. So we do have features in the Epic Stack that you probably won't have in your own application. But those features are necessary to demonstrate like user authentication and permissions and stuff like that. And so we do have to include some things, but we don't have to include everything. And so the idea is we want to limit the number of things that are included when you bootstrap the app, so you reduce the number of things you remove. Along with that, if you are just getting up and going, you don't want to spend the first hour of your time signing up for a bunch of different services and setting keys and all that stuff. So we want to minimize the setup friction. So though we are using services for some things, I want to make sure that you don't have to set up those services just to get things deployed. You can set those things up later. And so that's another guiding principle. We want to optimize for adaptability. So the only consistent thing in this industry is the fact that nothing's consistent and that it changes a lot. And so we want to make it so that you can pivot around the different decisions that need to be made and product changes and all of that stuff. And so while I do feel very confident in the opinions that I have, I want to make it so that it's easy for you to swap out different things. If you do want to use a service for this thing or whatever, make that as easy as possible. And then only one way to do something. So we want to reduce that bifurcation of approaches for things. And so, yeah, if somebody wants to bring in some tool, then we either need to replace the tool that's already solving that problem, or we just say, no, we are not going to bring that tool in. So that's another guiding principle. And then finally, offline development. I feel like being able to develop offline is awesome. It's being able to go up into the mountains and have no connection at all and still be able to work on my project. That's cool, but that's not why this is important to me. This is important to me because I think that it makes you more resilient to your dependencies either going down, being unavailable, being incomplete, all of that. So the idea behind the Epic Stack is that you can develop offline, and that's another guiding principle. So at this point, you're probably like, yeah, that all sounds great, Kent, but what are the decisions you made? What are those opinions? Please tell me, what are these opinions that you've made? I want to see if we line up on our opinions. So here's what the Epic Stack looks like today. First of all, it's using Remix, the best framework in the world. A huge super fan of Remix. And of course, Remix uses React, so we're using React as well. Super fan of React. We are using some services. We need to use services to like host it and different things like that. So we're using fly.io. Fly actually comes with Grafana and Sentry. And so we're using those services as well for production monitoring and everything. Using GitHub Actions to deploy. We will deploy to both a production environment and staging environment. And then we're using Resend for sending emails. I would love to just send an email right from your box, but that just is not a thing that you can do if you want your emails to get to their destination. It's a really sad state of affairs, but you can actually take a look at the decision document to get an idea of like, why are we using an email service provider? And in fact, I started with a different email service provider and changed to Resend, and I have a decision document about that change as well. And then Docker, I know that some of you were kind of like shaking in your boots a little bit when you saw the Docker logo, but to be clear, you probably won't need to touch this. This is a generated file for you. And if you ever do need to change it, you'll be really glad that you can change it. It's really, really powerful. So those are some of the things we're using. Also using Node.js and Express. Node.js is just awesome, super big fan. Bun is exciting and things, and maybe eventually I'll move over to Bun. But Node is really, really battle tested and it's awesome. Express, also one of those that I'm definitely willing to look into another alternative, but it's still a really battle tested framework and stuff. And honestly, we actually don't use Express a whole lot. There's a single file that uses Express, and then everything else is Remix, so it doesn't make a huge difference. And migrating to something else would be pretty like an afternoon sort of thing, probably. Then, of course, we're using Tailwind and also Post CSS for those situations where you don't want to use Tailwind or you just want to write regular CSS. But Tailwind is fabulous. It's awesome, all built in. We're using SQLite for the database and Prisma for accessing it. It's awesome. This comes with a permission schema, user schema, password hashing, and images, like all sorts of things. SQLite is actually really, really powerful. And I know it kind of has this baggage of oh, that's just for mobile apps, or oh, that's just for toys, or oh, that's just for testing. No, I've been using it in production for years. It is awesome. So SQLite also allows us to reduce the number of services that we're using, and so your reliability of your database is going to be awesome. And because it's on disk, there's zero latency, and so it's really, really fast. What's it called? The N-query problem, it's not really a problem with SQLite. It can store petabytes of data. It's amazing. It's just ridiculous what SQLite is capable of. We're using Zod and Conform. That combination gives us progressively enhanced type-safe forms. That is just so amazing. So huge fan of Zod and Conform. Using Radix for components and ShadCN for really nicely styled components. It's awesome. Put those together. And then we have all the testing tools you might imagine: testing library, vtest, Playwright, Faker.js, MSW, all of that stuff, table stake stuff. And then all the typical tools you'd expect. Prettier, TypeScript, NPM, and ESLint. So awesome set of tools, and there's a lot more to this. So just a silly number of things. Feel free to pause the video and read all of this stuff. And there's more coming too. We also have examples, lots of examples of using the Epic Stack with various other technologies and stuff. So give these examples a look. There's a ton of stuff that we can do. And on top of that, definitely looking for other examples. So if you work at a company that sells stuff to developers or something, put together an example of the Epic Stack with your thing. That'd be cool. So one thing that's unlikely to happen is more than one way to do the same thing. So that's what examples are for. You can do a lot of, show a lot of different ways to use the Epic Stack or adapt the Epic Stack to different things. So if you don't like the opinions of the Epic Stack, that's totally fine. You can fork it and build your own version of the Epic Stack and then create new projects based on that. So one thing that you can do to help with the Epic Stack is go to GitHub right now and go star it. And that actually does help. I know that it seems like a vanity metric, but actually stars do matter. People do look at those stars, and they are interested in seeing repos that have a lot of stars. So stars are helpful. Help is always welcome, especially examples. That's something that's relatively easy for people to throw together. And then if it's a really, really great idea, then and you can demonstrate that in an example, then potentially we could bring it into core. So we're also active on discussions and Discord, so come and chat over there. It's awesome. And yeah, I just want to wrap up with the last 2 minutes I've got talking about something. I was really struggling with something, making some decisions, and the decision I was struggling to make was what to do with Epic Web Dev. And because I just realized that people don't know that they're a customer of Epic Web Dev. They see Epic Web Dev and they're like, well, yeah, I'm a web dev, but am I, does this apply to me? Because the web is just so broad. With testing JavaScript, it was obvious. I want to test JavaScript. Boom, testingjavascript.com. With Epic React, yeah, I want to be a React developer. Let me go do that. Epic Web was just too broad. And so, I realized that what Epic Web Dev offers people is a pathway out of this, out of the, oh man, this is a huge risk, but low likelihood decision. But I'm paralyzed by how challenging this decision is. And so what Epic Web is it's the documentation for the Epic Stack. The Epic Stack solves that analysis paralysis problem, and Epic Web is how I teach you how to use the Epic Stack. This is how I keep the Epic Stack sustainable for myself. And so Epic Web is comprised of a lot of free material teaching about the Epic Stack and how to build Epic Web applications, full stack apps. And it's also comprised of a series of workshops that you can go at. And this first volume that I've just released is basically how to build the Epic Stack. So you really get a solid understanding. And even if you're not using the Epic Stack, you will have a much better grasp of the underlying technologies that you will probably use in your own web applications by building the Epic Stack. And so I hope that you give Epic Web a look. The Epic Stack is where we can give you a firm foundation. That's my goal for the Epic Stack. So I actually just have one more thing and then I'm all done. And this is that one more thing. You are awesome. Thank you so much. See ya.
Thank you for that amazing talk. Don't forget to address your questions to our speaker in the Discord channel. Next up, let's introduce you to Daniel, who's going to be talking to us about a nerdy guide to the web trending concepts. Daniel is a developer advocate at the OLX Group. His current interests are in React and JavaScript, and he is an advocate for better testing principles using the testing library. He has a full stack background, having worked with different languages and different frameworks on various projects from IoT to fraud detection. In his free time, when he's not learning new technologies or writing about them, he's probably reading comics or watching superhero movies and shows. Let's go ahead and drop some questions for Daniel as he gets ready to take on the stage.
Hello, React Summit. Thank you so much for having me here. It's a pleasure to be here with all of you today to share this new talk that I'm trying out. So hopefully you'll have as fun watching this as I have writing it. So let's start. Well, this all started when I was attending a couple of conferences, and attending conferences can be a bit overwhelming. I don't know if you understand what I mean, but there are so many words showing up back and forward, which, well, if you are like me, not very often you're going to understand what all of them mean. The issue that kind of prompted me to do this is because I didn't have the right mental models formed for these things. Now, I don't know if you are aware of what a mental model is. Mental models are the terms, images, words, or whatever that you associate with a certain subject. For instance, as picture sleeping. Whenever you hear the word sleep, you immediately understand all the steps associated to it in your mind. This is because you have the right mental models formed for them. Now, hitting pause on that for a bit, let me tell you something about myself. I'm a huge comic book nerd. I have more comic books than I can read, and you might regularly find me making comic book or pop culture jokes. So one day I thought, what if I could get the characters that I love, the tech concepts that I miss the right mental models, and I built a nerdy guide to the web trending concepts. So this is the essence of the talk that we're going to be seeing. For anything else, let me start by introducing myself. My name is Daniel Afonso. I'm working as a developer advocate at OLX. I'm an Aged.io instructor. I'm an Altiero ambassador. And you can find me on X and pretty much any social network at the handle Daniel JC Afonso. Also, something about me. I just recently published a book about React Query. The title of the book is State Management with React Query. So I'm up to chat with all the things related with React Query. So feel free to reach out to me on social networks. Now, before we start the talk, I just want to make a small disclaimer, which is this talk will include some fan-made stories using characters that are owned either by Marvel or DC Comics. I'm just putting this out of there so you're aware of the characters that you see. I do not own them, but I'm just using them to help build the right mental models on all of you. Another thing that's important to say is I want to share some love. I want to thank these amazing people, Attila and Mateus, because without them, this talk wouldn't be what it is today. They gave me the right feedback and the feedback on the mental models. So I just want to share some love and thank them for building this talk, helping me build this talk. Now, before we start, how will this talk work? Well, ideally, if we were in person, you would be deciding. You see, this talk is going to be consisted by a couple of things. First, what happens is I present you with a topic and two characters. For each character, ideally, the audience would pick which character we'd be seeing. And then afterwards, for the selected character, I would tell you a comic book story. And after we wrap up that story, I would show you the technical explanations behind. So we would start with the story and then go to the technical concept of it. Because today we are doing this online and it's not in person, I'll be picking only Marvel characters. So we'll go with the characters from Marvel. In this talk today, we'll be seeing two topics. We'll be seeing hydration and we'll be seeing resumability. So I hope you're ready to start because it's time for hydration. So for hydration, like I said, if we would be picking, would be able to choose between Iron Man or Lex Luthor. Both of them would help us the see story for hydration. For this scenario, considering, like I said, once again, we're remote, I'll picking Iron Man, so let me just pick the character. And now I'll take the role of a narrator and I'll tell you a story. And after the story ends, we'll see the technical aspects of it. So I hope you're ready. I'm ready. So after building Mark 1, Mark 2, and Mark 3 by hand, Tony Stark didn't want to repeat the process of building a new armor by himself. You see, doing this is quite a slow process, and Tony wanted it to be faster. So he thought, maybe I can reprogram Friday, his custom AI, to know all the steps for building a new armor. And once he did so, all that was left was to ask Friday to build him that armor. And they did. So Friday plugged into the manufactory and started to work. After a bit, the armor was ready. Great success. We are ready to eat flight, right? So Tony said, okay, let's get into the armor. And he tried to do so. So he tried to get into the armor, but apparently something didn't quite work out. The suit didn't even open. And this kind of left Tony to think. Because sitting there with a non-interactive suit, Tony thought for a bit until, well, an idea popped into his mind. What if I downloaded Friday to the armor and then Friday could power up the armor from the inside? That would be interesting, right? So he did. And we waited for a bit. And after the download process was completed, the new armor had Friday running on it. So once Friday started up, it started powering up each part of the armor as it did a system check on it. As you can see on this very poor did GIF, you can see that the light is powering up on each part individually. So this was symbolizing the process of Friday going over each part of the armor and powering it on. And now that the armor is powered up, Tony was able to wear the suit and go for a test run. So he powered up the thrusters. And well, not everything works out on the first dry run, but this was hydration with the help of Iron Man, Tony Stark. So hopefully if you already knew hydration, you'll pick up on some of the steps. If you didn't, now let's recap what the heck we just saw. So let's start with the problem. Hydration is there to solve one problem, which is server-side rendered code is not interactive. And ideally, what we need is a page that is interactive. So how it works typically is on the server, on the server-side code, using the framework, we generate our static HTML. But now, once we get the page is not interactive because, well, it's just static HTML and CSS. So what we need to do is download JavaScript, in this case, the framework, then run the framework and run what it's called the reconciliation process. And after the reconciliation process runs, that's when the framework, the JavaScript we just downloaded, goes over each part of the HTML and interacts and attaches event handlers and all the interactivity that we need. And after this bit, that's when we get the interactive page. And this is kind of how hydration works. So let's recap how this thing is set up on the story. So we started with this part where Tony said that building a new armor should be faster. The issue that we were setting up here is that client-side rendering is slow. So what if we taught the framework how to build a page? Because, well, ideally the framework knows how to do it. On the server side, by using the framework, the server builds the new static HTML. And then what is going to happen is that the client is going to get the static HTML. Now we set up another problem in the next part of the story, which is now the server-side rendered code is not interactive because we got the armor, but the armor doesn't work. It's just there to show up. And this is what happens before hydration runs. So then what we need to do is we're going to have the framework turn the static HTML into interactive HTML. So we need the framework to be downloaded into the page. So the client needs to wait for that to happen. After a bit, after the client gets the framework will go over the HTML and attach event handlers and all the logic needed to run every matching node. And after a bit, congratulations, the page is now fully interactive. And we just saw iteration with the help of Iron Man. So let's just recap all the steps that we saw in this story and make sure we have the right mental model. So iteration is there to solve one problem, which is SSR code, server-side rendered code, needs some sort of interactivity. The first step associated with this is usually when a client requests a page, using the framework, the server builds new static HTML and sends it to the client. And then the client gets this static HTML. But now there's one issue, which is the page is not interactive. So the client needs to wait for the framework to download. Once the framework downloads, the framework runs what it's called a reconciliation process. So the framework will go over the HTML and attach event handlers and the logic needed to run every matching node. And after a while, the page is now fully interactive. And this was hydration. We just saw hydration with the help of Iron Man. I hope you all enjoyed this story because now we're going to jump for the next one, which is going to be resumability. And resumability is a different story, a different character. In this case, we're going to use the same characters because we're going to pick up a bit after where we just left off. So we could pick from Iron Man or from Lex Luthor, but like I said, we're going the Marvel way for this talk. So let's go once again with Iron Man. Now, let's understand what Iron Man has to tell us about resumability. And now, once again, I'll put the narrator at, and let's start this thing. So let's go. After last saving the world and against the fight against Kang the Conqueror, Tony took a big hit. You see, he completely ran out of armors. They all got destroyed in this fight. Now, back home, as he was headed to bed, Tony asked Friday, "Friday, please remind me to build new suits tomorrow." And he fell asleep. You see, saving the world is a hard thing, and Tony really deserved this sleep so much. But suddenly, an explosion happened. What? You might be wondering. Well, you see, the Mandarin cannot let this slide. You see, it's a vulnerable Tony Stark after all. And Tony woke up, startled obviously, and he shouts, "Okay, I need a new suit." But Tony also knew something. He knew he wouldn't survive the old process. The current process, it's currently not that good. He could get the manufacturing running and have Friday building the armor, but very much probably the time to download Friday to the suit would probably mean death or that he wouldn't survive. And this left Tony to think, okay, Tony, think. And during this time, you could see some Hydra goons show up and chasing him. And this forced Tony to think, well, I need an armor that's ready to work. So probably Friday, do this thing, initiate resumable protocol, build me a suit now. And Friday started building the suit. But now the process changed. You see, for each specific part of the suit that would be interactive, Friday would encode this information there. Friday would also encode a pointer that would indicate itself where to find instructions to operate this specific part of the armor when the time arrives. Now, back to Tony, while he was running, he found himself surrounded by the Mandarin and his goons. And that, as you're usually used to in this type of movies or films or whatever, the Mandarin started this bad guy monologue. "Yeah, Stark, don't think you'll make it out alive." And at the end, he points his hand to Tony and ready to fire his disintegration beam. And as he does this, Tony jumps to his new Billy suit, and the suit catches him and saves him from a sure blast that would probably take him out. Now, this made the Mandarin mad. You see, he knew about the weaknesses that the previous process has. He knew that there was no way that Tony would get an armor that fast and that ready to go. What happened? How? How did this work? Well, you see, in the resumable protocol, when Friday created the armor, it already uploaded a very small version of itself to the suit. This small version of Friday was able to intercept any command from Tony, and by using it and the encoded instructions, figure out on the fly how to execute each specific instruction. This would allow the armor to skip the boot/system check phase. Now back to Tony. Friday, fire the rockets, he asked. Well, inside of the helmet, as he asked this question, he heard Friday saying, "Powering the rockets, Tony." Once the rockets were ready, and Friday let Tony know, Tony fired them up. Boom! And once he did so, the rocket collapsed Tony's house and everyone in the way. And this ensured that, well, Tony could escape and call for backup. What happened next, you might be thinking? Well, for that, you can wait for the next issue. Welcome to the world of comic books. Not everything gets solved in 1 week. So, this was resumability with the help of Tony Stark Iron Man. Now, let's just recap what we just saw. Resumability is there to solve one problem, which is the page is not immediately interactive. And during hydration, that what we just saw previously, we have to redo the work we did on the server. Ideally, we could not have any hydration. No hydration is always better than having hydration. Ideally, what we would do is once we're building this HTML on the server side, we would encode some information, extra information there that will allow us to resume our execution from the server on the client. This would mean that once we got the page on the client, the page would be immediately interactive. Now, you might be thinking, okay, but if we don't download all the JavaScript and all the thing that we need, how do we have the JavaScript to execute once we click on that button? Well, what we would do here is we would download only the specific JavaScript to do this, and only the JavaScript that would be responsible for this part of the code. Now, one of the frameworks that got very popular of using resumability, it's called Quick, and there's a reason why I'm telling you this, because there's actually another part at Movie. So once we got the page or the HTML, we would also get something called Quick Loader, and this Quick Loader would be responsible for intercepting this quick event and would be responsible for downloading this specific JavaScript for that specific part. So it would just be a very, very small bit of JavaScript that would be able to allow us to do this thing. So now let's see how resumability fitted in our story. Well, first we had an issue, which was hydration is slow. So once the client requests a new page, using the framework, the server builds this new HTML, but it also serializes in all the information it needs to resume its execution in the new environment. Afterwards, once the client gets the page, it's immediately interactive. Now, there's also something here, which is the client gets the quick loader. Remember, I mentioned this thing called the quick loader. The quick loader will set up a global listener to all the events. So when an event happens, what the quick loader will do is intercept it, get the JavaScript needing for executing that part, and runs it. And congratulations, we all just learned resumability again, again with the help of our friend Iron Man. So let's recap what we just saw. Resumability is there to fix one problem, which is the page is not immediately interactive, and ideally there would be no hydration. So let's see the mental model steps. The first one is, once the client requests the page, using the framework, the server builds the new HTML page and serializes in all the information that the page is going to need to resume its execution in the new environment. Once the client gets the page, it's immediately interactive. The client also gets this thing called the quick loader, which is a very small bit of JavaScript. This quick loader will set a global listener to all the events, and because of what we just set up, once an event happens, the quick loader will intercept it and get the JavaScript needed for executing this event and run it. And well, this was pretty much resumability. So let's go to the last slide here. So we just saw two topics. We just saw hydration, we just saw resumability, and you might be thinking, okay, what is the next topic? Well, I would leave that out to you. That's my call for action for everyone listening and watching this back at home. If you enjoyed this concept of this talk, please suggest me topics. I would love to build more nerdy guides for all of you, because I had so much fun doing this thing, and I had so much fun presenting it, and hopefully all of you will enjoy it as well. So, without any further ado, thank you so much for watching this talk. Stay tuned for the next one, because I'm pretty sure there's going to be developments from this, especially if you help me and contribute with new topics. And yeah, this was a nerdy guide to the web trending concepts. Thank you so much for having me, React Summit. See you next time. Bye.
Thank you for that amazing talk. Again, don't forget to leave your questions for our speaker in the Discord channel. Now let's go ahead and introduce you to our next speaker, Philippa. Server components to the rescue. Turbocharging and empowering your React apps with style is what Philippa is going to be talking about. Philippa is a dedicated software developer and avid React enthusiast. Fueled by her innate curiosity and zeal for learning, Hailing from a small town and growing up in a large family, she embraced the virtues of persistence and determination from a young age. Felipa's keen focus on innovation and the practical application of new knowledge drives her exploration of diverse features in web development. So let's go ahead and go to our hashtag summit-qna channel and leave some round of applause, but also ask your questions to Felipa there as well. She'll surely reply to all of them. Felipa, the stage is yours.
Welcome to the Server Components to the Rescue, turbocharging and empowering your React application with style. Who I am? I am Felipa Perez-Pons. I am software engineer and front-end, love cats and volume sharing. And today I will like to speak about React Server Components. For that, we almost 3 years ago, especially in December 21 and the 2020, the React team first introduced us to the React Server Components. Before that, we knew the interaction between server and client. As we have the data in the server, we have the UI interactions and in the client. So we started to use client-side rendering. And the client-side rendering is like this. We have a server, we have a device, and we ask to the server about the page. And we return the HTML, we ask for the bundle, JavaScript, CSS, return the bundle, and we saw the bundle, we do all the things, and we ask the data. And return the data and finishing rendering the page. This looked like our first paint, our page interactive. It's okay. Our full contentful painted is not so good. It's a little really expensive. Our metrics are not good. Our users doesn't have a good experience. They suffer. We suffer. Our points increase. So we try different tools, different architectures, different rendering. For what? To avoid this waterfall, to try to have better metric, to try to have better experience. Better user experience. So that day, React Server Components bring us with idea. 3 ideas. Easy to maintain, quick to build, improve metrics, improve user experience, and you can use it in your favorite rendering. What are the benefits? Why are you using that? For these 3 ideas only? No, we are using this because has better advantage. Server bundle side. As we are using the server, there is no code that you need to download to the client at the start time. So also you can apply a formatting in the data. You can do a format to the data, string, date. What is next? Full access to the backend. As you are in the server, you can use microservice, you can use the file system, you can use the database without cost to the startup time. Automatic cost price splitting. This is because previously we used the lazy import, we use the dynamic import, and right now you only need to do is import Lala from Lala, and you have voila. You do automatically and without much code, even with less code. And non-client server waterfall. This is because we eliminate the round trip. So you have this, that is okay. You have the HTML, you have the bundle, go to the bundle and go with the data. So the next time is build the things and build the page. So you don't have this, okay, I need the bundle, I need the data. You have all in one request. Avoid attraction tasks. This is because server components reduce the cost of attractions. You can put all the logic, the product logic in the server, and you can have several layers of the attractions. And this only brings to the client all this rendered element for the client is ready. So the view is more look and feel and nice to have in a way that you have only that pure rendering. And distinct challenge unified solution. You have the same code for solution. You have the same code for in the server, you have the same code in the client. So you don't need to have a different language for the server and for the client. You can have all in one place. First, we spoke about our React Server components. We spoke about the benefits. And right now, how is React Server components? We have client components that lives in the client, live in the browser. And we have the server component which lives in the servers. This is our first part of the situation in the React Server component, our React components and client components. And this is a note. Your parent define you. That means that in using React Server components, a server component can have childs that are server components or client components. And one client component can have only client components. We can see in the next example. We have in blue the server component. We have in orange the client components. And here we have a icon, we have a switch, we have an input, and we have a words. So first we will cover the server components, and after that we will cover the client components. The client components if we go to the page, we can see here that we have server component that you can use server to define that. In every server component, you will see the use server, like you are expressing that is a server component. This is the way that you put and say that is a server component. And here is a server component also, and image. Image is a server component also. Here the switch is a use client. So for server component, we'll use server, and for client component, we'll use user client. So if we return to the page, input is a client also, use client. And the server components is use server. So this is a use server also. So in that case, what is the difference between server components and client components? It's not only that you are using this use server, use client. In use servers, you can interact with the other API, other server, other microservices, database, and for our clients, we have a use state, we have a user first, maybe. We can interact with the all interactive way that the page. We can see the events. We can see, for example, in other exercise that we have in Switch is we can interact with the document. So the main difference, if you are using a user state, user fetch, user reducer, or you can interact with the browser API, you need to use the use client. You need to put that this as a client component because you are interacting with the API from the browser. Our server components are different. Our server components are wrappers. In that case, for example, the word definition is only a parser of the information and brings with a isolate component to the server, to the client. This is the first step. We have a COM that is a server component that can have child, client components, and server components. But if you have a parent that is a client component, you can have only child's client components. Here is the sample. We have our switch. We have our word definition. We have our input. We continue. So here we are in our sample. This way that we use the React Server component, we are using React Server component impact in our metrics. First, content painted. It's the same code. It's the same value. It's one bundle. You have in the first content paint the same metric. In time to interrupt, you have that is the same time because you spend the same time to build all the components and build all the UI. And our large content painted that it was so excessive, 3 seconds approximately, we do a decrease, huge, 1 second, 8. That is so much. And this is because we don't have this round trip, that because we are asking for the information in the server, we parse the information and we bring the information, the UI to the client ready. This avoid the round trip, this avoid the waterfall. We have limitation with the React Server component. We have local storage because we can use the local storage. We can use the Bluetooth in the server component because we are in the server. We can use the web USB. We can use state, use fetch, use reducer because we can use several things. We can use the browser API. We can use the interactive. What is the future for React Server components? Well, as it says in the post on March 2023, the expansion of interaction capabilities between the server and client, this is one of the things. This is one thing that include improving the synchronization of the state between the server and the client, sending client data to the server to execute data mutation maybe, and some improvement in formularies, in forms. The other thing is allow to the server component to do a re-render in response to the state changes. Maybe maintain the client side interactive and allowing fluid UI update without refreshing the entire page. These are some features. If you want to see and you feel more curious about the code, you can do an inspect in that repository. And if you have some doubts, you can contact me in Twitter or as Twitter. Thank you.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. Okay, so we want to see your Twitter, X, LinkedIn photos. Go ahead and make sure that you take a photo of how, where, and what devices you're joining the conference from. Tweet or post them on LinkedIn with the hashtag #ReactSummitUS. We'll be looking out for your tweets and your posts. We'll also have a raffle of multi-passes to Git Nation conferences and t-shirts. Just use the hashtag like crazy today. We look forward to seeing all of your pictures. Next up, we're going to go ahead and introduce you to our speaker, Alexandra, who's going to be talking to us about lightning fast e-comics. Remix your shop with Shopify Hydrogen. Alexandra is a DevRel engineer at Storyblock. She specializes in Jamstack and headless architecture and helps developers bring their vision to life. With a diverse background as a freelancer entrepreneur, Alexandra offers a fresh perspective on building successful projects. Go to summit-qna again and have all of the questions in that channel. Let's also leave a round of applause as Alexandra goes and takes on the stage.
Hello, I'm Alessandra Sfalato. I'm a developer relation engineer at Storyblock. I'm French, as you can hear by my accent, and I live in Madrid. So today, my topics, it's how you can remix your shop with Shopify Hydrogen in order to build a lightning fast e-commerce. So, well, I have not the public in front. I'm used to the public in front, so I cannot ask you who is using already Hydrogen or know about it, but I hope you will learn and like it with my talk. So in the first part of the talk, we will cover the basic of headless commerce, its importance. In the second part, we will introduce Shopify Hydrogen and its features. And finally, the big part of the talk, we will explore the code of a custom storefront built with Hydrogen. So headless commerce means the separation of the front end and the back end. And this is achieved thanks to an API-driven architecture, which allows for a flexible and customizable front-end experience. When compared to monolithic, headless offers many advantages: omnichannel selling, faster time to market, better performance, which leads to better SEO, personalization and customization, and certainly much more. However, it may come with an increased development complexity. So imagine an e-commerce platform that offers all the benefits of headless commerce while minimizing the development complexity. This is where Shopify Hydrogen comes in. So Shopify Hydrogen is a new framework designed to simplify the development of headless Shopify stores. It incorporates built-in best practice and it's built on top of Remix. So again, I cannot ask you who knows Remix, but for the one who don't know Remix, it's a full stack React frameworks, which is based on web standards, and it creates a really great developer experience because you work with web standards, so it makes everything simpler, and also it can make really scalable and fast website. I didn't know it before learning Hydrogen. And by learning Hydrogen, I fall in love with Remix, and now it's really my go-to framework. So it offers, Hydrogen, not Remix, a component-based architecture that leverages Remix for improved performance. And it also provides a seamless integration with Shopify APIs. So now it's time to take a deep dive into the code of a Shopify Hydrogen project. So first we will create the project, then we will see how to fetch and mutate data in Hydrogen, how to build the collection and products, how to handle SEO, and how to build a cart. So first, we use the Shopify CLI to create the project with npm create at Shopify Hydrogen latest. And this will create for you in 2 minutes a full featured e-commerce website. For this session, we will use the template hello world command, which provides a Barbon repo, and so we can really explore what we are building. But let's see what we obtain with this command in just 2 minutes. So this is a website you get with that. So we have, oh, what happened? Oh yes, I have to launch the development. So npm run dev. Okay, so now we should be good. Okay, so we have mock data, so we have this home page, we have all the products, we have the single products with options, we can add them to the cart, we can apply discounts, we can check out, we can sign in, we can search. So we have really everything, and we can see it in the code of the storefront here. We have all the possible routes, login, logout, recover, register, reset, addresses, orders, collections, products, search. So you can use that and customize it to make your shop or explore it to learn. But I have used the Hello World template to build this little nice website about surf. So this is the homepage. The homepage is built with Shopify and Storyblock, my favorite headless CMS. We have here a banner that comes from the CMS. And here we have a product grid that comes from Shopify. And here single products where the image is pulled from Shopify, and this little text which is pulled from the CMS. So we can mix and match Storyblock and the CMS data and make storytelling. I will show you after how this is built. And now if I click on the board link, I have access to my collection entries. So we have performance board and original board collection. So again, if I click on a collection here in the performance board, I have access to the collection details with a banner here and all the products in this collection. And then I can go to my single product. The shop pay button is a buy now button. And then I can add to cart. And here I can see the items in my cart. And I can go to my cart. I can remove items from the cart and I can check out. And here everything is working. Then if I go back to my website and to my homepage, I can see that my banner has changed. Now it's featuring performance board and is also displaying only performance board in this product grid. This is because I have implemented some personalization. So depending of the behavior of my user, and here I have navigated to the performance board, I will serve a different homepage. And as I have navigated to the performance board, I assume that my user is interested in performance board. So I serve that. And here I go directly to the performance board. Okay, so let's explore the code of my of this little website. So I have a server.js file, which is the entry point. And I have created some routes. So this is for the pages. This is the cart route, a collection index route that shows my collection entries, the collection handles that shows the collection details dynamically, the product.handle that shows the product details dynamically too. The route file is the parent route. And here I have my components. So header, footer, layout, the common components. And here I have all the cart components. And in blocks, it's the components that come from Storyblock. And these the ones that come from Storyblock and Shopify. Let's go back to our slides. So, okay. Okay. Okay, so now let's see how to fetch and mutate data in Hydrogen. So Hydrogen provides a storefront client to send queries and mutation from Remix loaders and actions. So Remix loaders are functions that get the data from the server, and Remix actions are functions that make mutations and send data to the server. So for that, we are going to create and inject the storefront client in server.js. So let's see that in the code. So here is server.js. So we have this create storefront client. So this is when you create your storefront with the CLI, all that is provided, except this content security policy that I had to customize, but you will have access to the code too. So we have this create storefront client function, and we use it to create our storefront, and it passes all our tokens here. And then we pass this storefront to get load context. So our storefront will be available in our global context in our loaders and actions. And by the way, you have here the repo if you want to grab it. And here you will have all the details to reproduce this website. Okay, so we pass the storefront to the context. And from there, we can call the storefront client in loaders and actions. So we will use storefront.query to send queries to our storefront and load data. So we will use that to get the data from our products and collection, and also from our cart. And we will use storefront.mutate to perform GraphQL mutation in remix action. So we will use that for all our cart operations. So now let's see how we can create the products and collection. As I was showing you in the repo, we have created this file route, the collection index to display the collection entries, the collection handle to display the title, description, and paginated products from a collection, and the products $handle to display the product details. So this is how it works. This is for the collection details. We have our GraphQL query, and we request here the ID, the title, the handle, and the image that we need to display in our collection entries. And then in our loader function, we pass this query to context storefront.query. And then we can, so this happens on the server. This is in the same file. And here in our component, we can retrieve our data, so our collections, with the hook. It's a remix hook, use loader data. And then we have just to map around our collections to display them. So same principle for the collection details and the product details. We make the query, we pass it to storefront.query, and we retrieve it with use loader data. We also have Hydrogen React, which is a library of React components, hooks, and utilities that can be used with any React framework or application. So, for example, if you have a Next.js website, you can totally use this React component. So here's some examples. The image component, get the product image, well, the Shopify image very easily. The money component will display the price and currency very easily too. And the Shop Pay button will display a Buy Now button just bypassing the store domain. There is also many components for the cart. In our case, we are going to build a server-side cart, so we will not use them because the server-side is more efficient. But if you want to use them, go to the documentation, and then you can implement Hydrogen on any React framework. So now let's see how we can handle SEO in an Hydrogen shop. So Hydrogen provides an SEO component that collects the data defined in the handle export. And we can pass a function that will receive the data from our loader as prop. And here we choose the shop name as title and the shop description as description. Then we place our SEO component into the head in our root file, which is the parent root. Then in other routes, we can overwrite this here. So here I want the title to be the product title and the description to be the product description. And this is the result. We can see that we retrieve our title in our head and our description as meta description. So it's really, really easy to handle SEO in Hydrogen. And now it's time to build a cart. So, oops, I'm losing my AirPods. So cart operation could be done on the client side, but this would cause performance degradation because of the additional code delivered to the browser. And it will also affect the customer experience as critical flows won't be actionable until JavaScript has finished loading. But Remix has a powerful mutation API that use web standards like form element and HTTP, so we can implement a traditional server-side form workflow while keeping the benefit of client-side user experience. And it also allows progressive enhancement because our cart can totally work without JavaScript. So let's build a performant server-side cart. So first we need to initialize the cart with create cart handler. So this is in our server.js file. Within the fetch handler, we create a cart instance using the create cart handler. And this utility is super handy because it lets us interact smoothly with the storefront API. So we create our cart with essential configuration like the storefront and methods to get and set the cart ID. Next, we pass our cart instance to get load context. So this ensures our cart is accessible and can be manipulated as needed. So with this step, our hydrogen cart is all set up and ready to roll. Now we have a cart, we need to add products to our cart. So for that, we are going to create a add to cart button. So first, we import the cart form component that abstracts away a lot of complexity. And let me tell you that I have done this talk several times a few months ago, and this cart form component was not existing. So I was doing all that manually. So the cart form makes things really easier. Well, not for me, because I discovered that 1 week ago, and I have to make this talk again a few days after, and I had to rebuild my slides, my project, to practice all that. So it was not easy, but that shows how fast and good hydrogen is evolving and bringing stuff to make the developer life easier. So we define what to add to the cart with the lines, specifying the item with the merchandise ID, passing the variant ID and the quantity. And we have a root attribute where we define where the form will be processed. So here in the cart root. And in the action attribute, we define the action. Here it's lines add. And in the inputs attribute, we pass our lines. So the products we want to add. Our button is nested inside the cart form. So this ensures that the clicks translate to adding items to the cart thanks to the lines add action. And all this action is directed to our cart root. Then we place our add to cart button into our product page under the shop pay button. Then we also make a remove from cart button that will work the same, but here the lines are the lines IDs representing the products to remove, and the action is lines remove. Here we add an icon inside our button, and this button will be placed in our cart item and offers the possibility to remove the product from the cart. Okay, so now we have to set up this in the cart root, so cart.jsx. And here we get the cart from the context, then we get the form data from the request, and we pass it to cart form get form input to grab our action and input. From there, we set up a switch statement to manage these cart actions. So depending on the action, we trigger the different cart function, add, remove, or update lines. And then a small but crucial detail is the cart ID. It can change, so we always make sure that is updated. Okay, so now we have a cart, we have a button to have items to our cart, so we need to grab the data from the cart to read it and display it. And we need it in two places because you remember that we have this little icon in the header that displays the number of items in the cart. And of course, we have our cart page where we want to display everything. So we need this data to be globally accessible, and that's why we are going to write our loader. So the loader gets the data from the server in the root file, which is the parent root. Okay, so here we are in our root file, in our loader, and we get the card from the context, and we get the data with the function card get. But here we don't want to wait for this promise to be resolved, because we have other critical data to load. The data from the shop to get that we need for our SEO, to get the shop name and the shop description that we have seen before. So for that, we use Defer, which is a Remix utility for creating streaming deferred responses, and it will transport the promises to our UI components. So here, this is how we create our cart icon. So we use the hook use loader data to get the data from the root, because the cart icon is a child from the root file. So we can get the data at the component level with use loader data. We have access to the parent's root. And then here we resolve the cart promise with await along with suspense. Then we get the data, and from this data we get the total quantity, so we can display it in our icon. Then we can create all our cart components. So the line item render each product from the cart, and we render also here our remove from cart button. The cart lines items component is using the flatten connection, another Hydrogen React component that flattens the node and edges object to a simple array of lines which represent each of our products. So here we display all the products. The cart summary component renders the total using the money component, and the checkout button links to the checkout URL. Finally, the cart component displays everything, all our products, the cart lines items, the total with the cart summary, and the checkout button to check out. Now we need to display all that in our cart root, and the cart root is not a child of the root file. So here we use another hook, the use matches hook, that give us access to the root file. And from there, we can get the data from the cart. And then again, we use await to resolve the cart. With suspense, we get our data. If we have items in our cart, we display the cart content component. Otherwise, we display the cart empty component. Et voila, we have a nice small e-commerce website, headless, really easy to build. So I hope you like this talk. And here you can grab this QR code and have access to the slide, where you will have access to the repository, to also the Storyblok documentation, and to the Hydrogen documentation. I really recommend you go there. It's really well done. I have learned everything from there, and I'm not a documentation person. I'm a video learner, so it's really, really good. And the remix documentation, which is really well done too. And finally, I invite you to scan this QR code in order to perhaps win a subscription to Egghead, because Storyblok organized a raffle. And for that, you scan the QR code, you fill out the form by December 31, and you can win an Egghead subscription. So thank you, have a nice day, and see you around.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. Next up, I'm going to introduce you to my co-MC, Josh, who's going to be talking about type-safe style systems, the future of CSS. Josh is an independent full-time open source developer. He works on projects in TypeScript ecosystems, most notably TypeScript ESL Lint, the tooling that enables ESL Lint and Prettier to run on TypeScript code. He's also the author of O'Reilly Learning TypeScript book, a Microsoft MVP for developer technologies, and an active conference speaker. His personal projects range from static analysis to meta languages to recreating retro games in the browser. Also, let's not forget cats. So let's go ahead and introduce Josh, bring him to the stage, and ask all of your questions to him in the Discord channel.
Hey folks, I'm Josh Goldberg, and this is Type Safe Styled Systems, the future of CSS. A little bit about me first. Hello, I'm a full-time open source developer and maintainer. I work in the JavaScript TypeScript ecosystem, most notably on TypeScript ESLint, the tooling that lets you run ESLint and Prettier and other standard JavaScript tools on your TypeScript code. So I'm probably running on your dev machine in some way. I'm also the author of the Learning TypeScript book through O'Reilly and a Microsoft MVP for developer technologies. So hit me up online, person, wherever, if you want to talk about any of those things. Moving on to the talk, I will give you a caveat that it is a gross oversimplification. There are all sorts of things like Foundation and Joomla and Material UI that are relevant and I don't cover. But we only got 20 minutes. So let's begin. Before Joomla and Drupal and PHP and WordPress and all this stuff, there's HTML. HTML was great. HTML was straightforward. This is an H1, a heading 1 with a hello world. It was plain. At the beginning, there was no way to style your document. This is your document. In modern browsers, black text, white background. Beautiful, simple. But developers wanted more. Developers wanted styling. So again, oversimplifying, we added CSS, cascading style sheets. Now you could describe, aha, my H1 is fancy, and I have this color and this background. So you could make your H1 look like this, with the centered text. Amazing! But still pretty weak and not very powerful. Now, early CSS was great for what it had at the time coming before it, but it was still pretty weak and pretty not well featured. And a lot of people made jokes about it. And one of my favorite memes, if you look up old bad CSS jokes, is this Peter Griffin one with the curtains. So in order to get around this lack of power in CSS, we added frameworks. Frameworks helped with both HTML and CSS. Bootstrap, for example, was a really popular one back in the day. Anyone who was doing web dev probably has some memory at the time of content or container fluid. And people who used the intranet long ago probably remember half the websites out there kind of looked like this because they all used Bootstrap. And Bootstrap made everything look pretty similar. Bootstrap was also one of the framework times when we used a lot of preprocessors, which we still do to this day. Taking a look at this file from back in the day, this is using less, which is an old CSS preprocessor. You could do things like create custom properties or variables with this @ or another's $ syntax. And you had these built-in functions like darken, which would modify your colors or your variables for you. And that was actually really nice because, again, CSS at the time was kind of weak. There's an interesting lineage, I think, with the CSS preprocessors. There's CSS-qna. Then on top of that, we had syntactically awesome style sheets, or Sass, which were often compared to Ruby because they had similar syntax to that in CoffeeScript. Then we had less, which is leaner style sheets. It looks a little bit more like CSS. People like that. So then we also jumped on to that pattern with SCSS, which stands for, you guessed it, Sassy CSS. It's a sequel, a predecessor to some of the things we have today. Now, this actually kind of mirrors the preprocessors that we saw in the JavaScript landscape. CoffeeScript came out with very Ruby-like syntax. And then we have Babel and TypeScript come after that, which are kind of like less in that they were closer to the core. Anyway, At the same time, people were working on and thinking about future additions to CSS, and eventually we had CSS 3 come out. And it's still coming out to this day. We're constantly adding to new CSS areas. One of the things you can do in CSS that you couldn't as easily before was center. Amazing. You can use this awesome new flex thing, and you can say, for example, that my container height is 100%, and it's flex with centered, horizontal, and vertical. So I don't like hearing people say anymore, oh, it's impossible to center in CSS. It used to be kind of difficult, but they worked on it. And this whole cycle that we've seen here of primitives and frameworks and all this is repeated continuously in our industry and others. And I call it the cycle of primitives innovation. First, we get a bunch of primitives like CSS, which are better than what we had before. Then we ideate on the common difficulties. We figure out some way in user land to make some competing solutions for them, say frameworks or meta processors. And then we build that into the language. While CSS and LS and SAS and SCSS are all jumbling around, people are working on future CSS. And as an example to that in particular, we now have CSS variables. You can do those @ or $ things from LS and SAS, just in CSS pure. And this is supported in all Evergreen browsers. Which leads us to our first conclusion of the talk. You probably don't need SCSS anymore. I can't say definitely. There are features it adds on top of CSS, but across my time in consulting, full-time open source, and so on, most websites that I've seen that use SCSS or an equivalent really just use it for the features that now exist in CSS. Most, but not all. So you probably don't need SCSS anymore, but not definitely. Up to you. Anyway, we also innovated on the front-end space with JavaScript. It used to be you just made your website in HTML or some server language like PHP. But now we have JavaScript first front ends. First, we started messing around with jQuery. Again, this talk is an oversimplification. Then we added a round of iteration like Backbone and Knockout that made things really dynamic. Then we got to the component-driven architectures with Angular and Ember and React. Then we innovated on that with more Angular and Solid and Svelte and React and Vue and all these. And in order to support this explosion of front ends being dynamic, we added ways to have dynamic CSS. One common and popular to this day option is CSS modules, where you define your CSS in some file. In this example, I've been using SCSS for variables. That was popular back in the day. And then in your JavaScript or React, say, file, you import the styles and use them as variables. Here we have similar to what was done before, where we have our colors and padding stored in a SCSS variable, and then our CSS refers to them. And if you want your JavaScript side to be dynamic in which class gets pulled in, you can say, use a utility like CX or class names that takes in a bunch of things that are strings or falsy things, or objects or arrays or so on, and then mashes them all together into one class name. In this example, the button adds in the styles.pressed class if it was clicked, if it was pressed. And this works. Honestly, a lot of my sites that I write to this day use CSS modules. For straightforward websites or for ones that don't change much, this is fine. But we need more. There are always more fancy websites coming out there. So let's take a look at another approach, styled components, or CSS and JS. I personally used Emotion, which was a competitor to Styled, a bit more, but they're around the same. Here we have a container and an h1, this pair of elements that are created with styled dot and then the tag name. And then you define your CSS in your JS. So instead of using CSS variables, you could just use JavaScript variables or TypeScript code. Here we have color background, which gets interpolated into the h1 string. This is actually pretty nifty. I think it's kind of clever. And if you want dynamicism, well, you can add in these component props like $pressed, where it becomes, at runtime, whatever you need it to be. So this works, and I still see websites doing this. But it can be hard to scale because we added some really beautiful, really snazzy, fancy JavaScript front ends. Look at this beautiful website over here for this conference. We have this dynamic homepage with this header footer thingy situation nav on the bottom. And then inside the website, we have all these dynamic components with like modals and similar fonts, but different colors sometimes. And you know what? They're complicated, these websites people are making.
Developers today have competing interconnected needs for styling, and I'd say that they would be categorized in kind of these four-ish needs. The styling needs to be convenient. It needs to be easy or at least straightforward to write new styles. You don't have to jump through 3 boxes and a new file. It should be assistable. The IDE should give you auto-completions and let you know when you mess up. It should be refactorable. If you want to, let's say, change a color or switch the nav bar from top to bottom, it should be relatively straightforward to do that. And it should be themable. People these days are always looking at light mode versus dark mode, and high color contrast, and all sorts of other ways of changing the colors around. Now, these 4 do miss one very important concern: performance, which I think is important. Folks generally agree is important, but oftentimes it's hard to budget for. But I digress. Our style components, cart/cart P, they're not great in my opinion. It can be hard to mess with those raw strings, even if your IDE has an extension to syntax highlight them like CSS. Another approach I actually strongly preferred back in the day was a family of libraries epitomized, I think, by Glamour, which was a utility that would allow you to pass in an object of styles to the CSS function, which would then spit out classes for you. I thought that was really clever. I liked how it blended CSS, as in these are just CSS properties at the end of the day, with good JavaScript, TypeScript primitives that you're still working in your JSTS code. And if you want dynamic things, you could, well, instead of using a plain object, have a function that returns that CSS plain object that takes in props. Fun fact, actually, this was made by Sunil Pai, who ended up doing a lot of work in React, and now works on PartyKit. Congrats again to PartyKit for getting started. Really exciting. And unfortunately, Glamour hasn't had a commit in years. Such is open source. But another approach that a lot of folks these days like is Tailwind. And don't worry, I'm not finishing with Tailwind. I know this is a hot take, controversial thing to talk about. Hot take, Tailwind's actually pretty great. I don't personally prefer it, but I recognize it's real straightforward. It is convenient as all heck. I mean, all you got to do is declare your classes in these strings, and they're applied. And then the Tailwind builder processor thing can optimize your performance. It's pretty great. If you want to be dynamic, well, they're strings, so you can concatenate them together. If you have this button pressed state, you can use that to concatenate different strings. Now, there are extensions to Tailwind that make this a little prettier, but this is the most common way I've seen folks do it in the wild. Another advantage of Tailwind is that its docs are fantastic. Like, seriously, shout out, congrats to the Tailwind docs team. Y'all do a good job. It makes it a lot easier to work in CSS or styling in general when you have fantastic docs. So yeah, I would say Tailwind is a pretty good cart solution. It's convenient, it's assistable, it's refactorable, it's themable, it has built-in support. Tailwind is actually a pretty good style system. It generally supports what we need, and most websites today, I think, are totally fine to be built on Tailwind. But I do have some gripes. Tailwind is not TypeScript first class, which is why I'm going to talk about some more things after this that are. Tailwind is an extension on top of CSS, fundamentally. It lets you define a bunch of classes with its primitives and then work with them. But that means that things like this are very hard to spot as errors or not errors. How does Tailwind know if what is a built-in class or a class you defined or non-existent? So I want to move past Tailwind. I want to talk about a few libraries that are a little bit more fancy than it. And I call these component libraries. Take a look at a popular one, Chakra UI. This is how you would do something similar to what we saw in the Tailwind slide with Chakra. Chakra provides a bunch of components, such as a box, which is a general purpose one, and then slightly more specific ones, such as heading. And instead of defining your styles as class strings, you actually define them as props on the components themselves. Box, flex, align items equals center. Which I think is a really nice approach. It's super assistable in the IDE, it's well documented. If you want dynamicism, well, again, they're just props, just CSS and JS. So you can do that. And with Tailwind also, you can theme them. Tailwind and Chakra and similar all support the ideas of color themes, which is, I think, a really good idea that if you have, let's say, a brand color, you use that in your components instead of hard coding it to a specific hex code. And I want to hone in a little bit on this because personally, I think this is the epitome of what a lot of style systems could look like. You have your components, you can say what DOM tag they render as, And then you can specify your props, which should adhere to your design system tokens as components, as component props. Chakra actually does something kind of clever inside to get auto-completion on these props. It defines a lot of string values as the union, or all the different possible strings, those literals. And then it also adds string and empty object there in that TypeScript type, which allows you to say get auto-completion on the props, but then unfortunately also allow any possible value. So it's a little unfortunate that you can use that nice little TypeScript trick and then lose a little type safety. It's convenient because it means you can specify whatever values you want, but the token types here aren't strict, which is a bit of a feature request that I have as a TypeScript user to a lot of these styled systems. Now, I will say the Chakra UI team is great. This is not a dig at Chakra. They are actually working on this problem. It's quite difficult. So seriously, love to the Chakra team and folks who've been working on this. But it is a little bit away from being the primary way that you use Chakra in production. I couldn't find it on the Chakra site. So even though I know there's progress being made, at its core, Chakra UI is a component library that also exposes a style system, which means that it does tend to get bogged down a little bit by trying to do all those things. Looking at it visually, Bootstrap was a style system that also exposed a few small components like badges and buttons. Tailwind at its core is just the style system. It just provides you the raw colors and the way to customize and use them on your own, colors and other primitives. Chakra UI provides a lot, which is awesome. A lot of websites are totally fine just using Chakra UI. If you need a component library on top of Tailwind, there is Tailwind UI. But I want to focus on where I think the really interesting innovations are happening. I want to focus on the style systems, because the foundations upon which we build our component libraries are really interesting. And one really exciting innovation that I want to espouse about now is vanilla extract. This is a kind of new approach to libraries over the last 3 to 5 years that I started to see get more popular, which is you define your tokens in JavaScript land the way one would build a design system. Let's say you've got your color primitives or your space. And then you use those to create classes for your components using the framework. In vanilla extract land, the right side of the screen would be in your .css.ts file. And then similar to Glamour before, you can use those class names in your components. And behind the scenes, it becomes all these nice, fancy, well-optimized idiomatic CSS classes, where they even use CSS variables for theming. And one really nice advantage of these that I'm very excited about is if you mess up, if you type in the wrong name, because it's all JavaScript-y and TypeScript on the inside, Property Wet can give you a type error. Amazing! Love TypeScript. What a treat. So this doesn't do as much for you. This is just the style system, but it's a really innovative way of looking at things. And I'm excited about it. I hope that we continue to work on things like vanilla extract and then build component libraries on top of them. But I want more. There's always more that can be done. So one last cool thing is a rather experimental library by Wayfair on top of vanilla extract called Rainbow Sprinkles. Rainbow Sprinkles allows you to set up vanilla extract the same way. This is the same code from the previous slide. But then you can also create this box abstraction on top of it, this Rainbow Sprinkles concept, where you're describing which of your properties, say, align to the DOM, the native attributes, align items is just raw CSS, or have vars.color or another variable, such as with background here. And then that allows you to build boxes, kind of like Chakra UI's boxes, where you have box, align items equals center, display equals vex, but then box on the inside says background equals background. And similar to Chakra, if you want dynamic values, refer to them in JavaScript land. Yes! Awesome! I think this is really cool. And we can even catch WAT, right? Nope, it's not type safe. I couldn't figure out a way to get it to be type safe. So it's very new and experimental, and it's not the only thing that does this. For example, Style Components has this really awesome builder called Style System. This talk is an oversimplification. Type safe systems for style are coming, but it will be a little bit before they're super ready. So get excited, start playing around. At the end, I'll show some resources, but beware, some of this stuff is new. Now, because I've got a minute and we're talking about CSS and stuff, I feel weirdly obligated to mention my opinions on here because I have them. So these are just my opinions. Please don't think of me as like the thought police or trying to be the thought police or whatever. This is just my perspective. Personally, I think basically all, not all, but most small or larger than small projects should probably use a design system. At the very least, try to separate tokens out from your app logic. It'll save you a lot of time if you use your brand variables, your colors at the very least, instead of defining raw values in line. If you ever have to change them, it's a lot easier. I also think that all three major systems I showed, just using CSS on its own, Tailwind, style systems, or CSS and JS in general, they each have their strengths and weaknesses. It's really hard to make a claim that any are universally good or bad, because honestly, we're all still iterating, we're all getting better. What's considered great today is going to be considered probably mediocre at best in 10 years. So if you see someone make a statement that like Tailwind bad or Chakra good or whatever, I would recommend, if you don't know or at least believe it to be true, or more specifically, if you haven't put in good faith effort to validate that it's true, please don't amplify the opinion. Again, this is just my perspective on online discourse, but things like Tailwind bad, Tailwind the only acceptable choice, real devs insert thing here. I don't like this. I think it's a little shallow. I would personally lean towards nuanced opinions. Like I prefer thing over or under other thing for reasons. There are advantages and disadvantages always. Those are just my opinions. So let's close out. Let's have some thoughts. I have nice links on these slides here, which are also linked on my website, to Vanilla Extracts docs, the Wayfarer docs for Rainbow Sprinkles. I got code examples for all the code slides I showed. And then also Gamut is Codecademy's design system that uses a lot of the Glamour or Vanilla Extract style features, which I'm really excited about. If you want to talk to me about open source, again, I'm always happy to chat. But thanks, y'all. This has been fun.
Thank you for that amazing talk. Don't forget to address your questions to Josh in the Discord channel. All right, let me go ahead and introduce you to our gold sponsor, Sentry. Sentry is the application monitoring platform for development teams to holistically monitor their code health from the front end to the back end to see clearer, solve quicker, and learn continuously. Get started today. And next up, I'm going to introduce to you Mike, who's going to be talking to us about breaking the use effect habit. Mike is a passionate software engineer with an intense focus on community. His expertise have been spent organizing multiple meetup groups. We're talking about React Uda.js, Free Code Camp, and he improves training and content for local boot camps and universities, running open source projects and becoming a tech conference organizer and speaker. Let's go ahead and head over to our Summit Q&A channel and leave some questions and round of applause for Mike as he gets ready to take on the stage.
Hey everyone, I'm Mike North, Senior Software Engineer and owner and organizer of React Rally, another React conference. So if you're enjoying your time here, there's lots of community conferences. I'm involved in a lot of meetups, have been running those for a few years. Anything to stay involved with the community is kind of what gets me excited. So jumping right into it. Okay, my talk's going to go over breaking the use effect habit. So use effect, probably most common, most go-to hook in all of React. We're going to look at maybe some different ways to think about use effect and some other ways to approach use effect that's going to give us some more maintainability, a little bit more flexibility, and just some simpler code in general. If you're not familiar with use effect, don't worry, we'll go over a little bit of a breakdown. Nothing's too groundbreaking. And if you are familiar with UseEffect, even better, because we're going to go over probably code that you've written and maybe some other ways that we can look at that and improve. So UseEffect, end of the day, pretty simple. We've got three main parts, okay? We've got our setup, that's in blue, our takedown in yellow, and some dependencies in purple. So our setup, it's the code we want to run, whatever it's going to do. And then our takedown is, hey, when this component's going to leave, when it's unmounting, run this cleanup code. And then in purple, dependencies, when do I want this to run? Do I want it to run on changes of different pieces of data or anything like that? So that's the main idea of UseEffect. It's a tool to give you the ability to run code at specific times. So if we dive straight into what do I see UseEffect used for, and what do people tend to think about when they think of UseEffect, I see a lot of handling setup, calculations, initial state, caching, that sort of thing, updating that state. So when something changes and I want to make an update, for those that are back in more of the OG days of React with our lifecycle methods, you might be familiar with component did mount, did update, unmount, etc. And then overall, just like the way to think about React. When I think about hooks in React, UseEffect is typically one of the first things that pop in my mind because it just kind of seems like the React thing. And if that's how you've thought about React, then it's not surprising, right? Because the docs explicitly said that, where, hey, if you're thinking about using UseEffect, a good way to look at it is these component methods. Did mount, did update, did unmount, all of those sort of things. And some of you might say, oh, sweet, I'm on track. That all makes sense. And other of you might be starting to think, wait a second, that doesn't sound right. I've heard something a little bit different. And if you did hear something different, it's because the docs now say the exact opposite, right? Say, hey, UseEffect is a lifecycle methods are a great way to think about components, but not about effects, right? It says that really effects are just used to synchronize external systems, but not to think about the life cycle of your components. So that's great. A little bit of a difference there in the documentation. I'm not really sure where the mind shift came from. I think part of it comes from switching from lifecycle methods. Change is hard. And so to get people to buy into using hooks and this new paradigm of React, it's a lot easier to transition when you say, hey, how you're doing things, the things that you know and love, you can bring those over. We'll give you an easy way to port that over and work in React still. Then once we're all here, it's like a little bit of a backtrack. Like, okay, now that you're here, let's actually talk about how these things should be used. So maybe those initial use cases are not the right way to think about UseEffect. So that leads me to look at the docs even more on, all right, maybe I can find some more considerations that I should take into account when I'm using UseEffect. So while looking at the docs, I come across things like this, right? Hey, try to just synchronize with external systems. If you're not, then you probably don't need an effect. Also, your code could suffer from race conditions within a UseEffect, so be aware of that. Another consideration, there's a risk that you're going to rerun your code more than it needs to. We've all probably experienced the deathly counter of forgetting a dependency in our UseEffect, and that causes this behavior to pop up in our React applications all the time. This is the piece of the docs that really made me dive in to this whole talk and this whole concept. It says effects are an escape hatch. You need them when you need to step outside of React and when there is no better built-in solution. And to me, that was mind-blowing. Like, wait a second, this thing that in my mind has been the go-to, like de facto way to do things in React is actually an escape hatch and a way to get out of React. So I was like, okay, let's see some more considerations. It's like, hey, if you're doing data fetching, probably use like a framework or another tool like React Query and things like that. If you're going to use it just for caching, again, there's other tools to look at. And then also strive to put all of your logic of, hey, something changed, I need to do something, in an event handler. And as it says, as a last resort, you can use useEffect. So that kind of like shook me a little bit. I'm like, okay, I'm trying to see how to use useEffect, and you're telling me all of these like warning signs. So let's look at some code. And in their code examples, you get a lot of these red flags in their code examples. Like, hey, if you're going to define an object, that object actually might not be a good dependency because of referential equality. So it's actually going to not render like you want. Also, if you don't specify that dependency, again, you get this behavior. Or if you use a piece of state as a dependency and then update that state within your effect, it's actually going to cause more issues itself. Warning signs, and what have you. So the docs kind of put a twist in my plan. So I said, okay, let me go to the actual source of truth, right? Tech Twitter, because that's where everything is accurate, right? And I came across this tweet saying, I'll never understand why the default behavior with useEffect is an infinite loop. And Dan actually comes into this conversation. He's like, well, not necessarily. We just didn't really teach people how to use it correctly, and that you shouldn't be using it to set state or do anything like that. And he goes on to describing how over 30% of the useEffect calls at Meta were just not needed, and that useEffect is really only a last resort and should be used to synchronize external things that React doesn't know about. He's got another tweet where he went over 128 useEffect calls, and about half of them were not needed. So with all of that rapid firing information, I always look at this as like a, if your code works at the end of the day. And that's all we're trying to get at usually. And if you're feeling like, oh, have I been doing this wrong, or how did I have this wrong notion? Like, don't worry, because half of Facebook also didn't know how to use this. And like, they're the ones that are also creating this tool. So you're not alone in this misunderstanding of what is useEffect, when should I be using it, and that sort of thing. So let's dive into some actual reasons to use useEffect, right? And we're going to make it really simple, right? Number one, am I synchronizing something external? If I am, then that's probably when I want to reach for useEffect. If React already knows about what I'm doing, knows about this data, this state, whatever it is, I probably don't need it. So that's going to be like our internal check. Am I synchronizing something that React doesn't know about, or am I dealing with something React knows about? If so, that'll point me in the right direction. The second thing, there isn't a second thing. It really is that simple. So it's just synchronizing external state. So to really drive that point home, I want to look at some real examples of where you may have reached for useEffect in the past, and maybe what that alternative approach could be now. So the number one reason I see people reaching for a useEffect is to update state, right? They're merging state together, calculating value, something like that. So I've got a simple form component here that's taking an amount due and an extra payment. It's combining them into a total payment amount. So you might think, oh, perfect. useEffect is a way for me to run code at a specific time. I want to run code when either of these values change so that I can add them together and I've got a new total. So what's wrong with this? What could we do? Well, it's more just that it's not necessarily wrong, but just unnecessary, right? We could approach the same code, rewrite it in just this one line, right? Total is just the due amount plus the extra payment. Okay, because React already knows about the due amount and the extra payment, it's going to re-render anytime those values change. So this value is going to be calculated every render, easy peasy. I go from this to that. So great. Second use case that I see people reaching for use effect is I want to store some sort of calculated value. I want to filter a list, something like that. So I've got a to-do list. I'm passing in a list of to-dos. I'm passing in a filter so I know what I want to take out of that list. And at the end of the day, I want to be left with what's visible, the actual to-dos that I want to show. So again, okay, well, I'm getting in to-dos. I'm getting a filter. If any of those are changing, I want to update what's visible. Very similar to the last one, and that it's actually just unnecessary. We don't need this extra piece of state. We don't need this extra piece of logic with use effect. We can just write it in a function to say, hey, go get the filter. Anytime to-dos or filter change, this component's going to re-render anyway, so I can calculate it. So this is great. It's a lot simpler, but what are the downsides, right? And if I look at our previous example, this code's only going to run when to-dos and filters change, right? In this new version, if other things are changing, visible to-dos are always going to re-render. So if this is a very expensive call, it's logic intensive or whatever, this might not actually be the most performant way. So React gives you another tool where you can just memoize it and say, hey, if to-dos and filters haven't changed, return to me the same value every single time. This still is only going to run during renders. I'm not adding use effect. I'm not adding an extra piece of state to store that value in, and I'm only running it when I care. So next place that use effect comes into play a lot is when I see people trying to reset state. This is a really fun one for me. So we'll look at this. I've got comments that a user is posting, and when the user changes, the user ID gets passed in. I obviously don't want to show the old comments of another user, so I'm just wiping it, clearing it out. Pretty simple, straightforward. But am I synchronizing something external, or does React know about it? I'm using a prop. It's already in React. So that's my pointer to, I probably don't need use effect in this situation. And instead, I can probably just look at using a key. So usually when you think about keys, you think about the warning message you get from React when you iterate through a list of objects or a list of whatever. And it says, hey, warning, you got to put a key so I know what we're doing. So what keys tell React is, all right, I've got a profile component, but if I've got multiple profile components on the same screen, it's kind of the same shape, React struggles to know which one is which, right? Using a key gives it a unique identifier so that we know which one's what. So instead of just using a key in an array to display a list of things, we can also use it as a way to force React to know that a component has changed. So by passing a key of the user ID to profile, anytime the user ID changes, profile is going to completely re-render and be like a new component, wiping the state for us, going back to its initial value. So we no longer have to have a use effect, pay attention to what's being passed down. We can just use that key, internal built-in way of React to tell it to start over. And I guess before I go into the next one, these kind of examples have led into a different way of thinking about writing React code and how I approach React. And I've now kind of come to my approach when writing React is I actively try to write as little React as possible, which sounds a little bit weird. But what I mean by that is exactly something like this, right? If I can just do it in vanilla JavaScript, it's going to be a lot simpler. It's going to be more maintainable. It's going to be easier for someone new coming in to say, what's happening here? And it's less buggy. So it's an interesting approach that these tools that they're giving us are to help, and they all have their use cases, but we don't have to reach for them every single time. So next example, partial reset. So using a key is great if I want to reset everything, but if I don't want to reset all my data, then what? I can't pass a key in because it's going to wipe everything. So I've got two pieces of state. I've got, is this reversed? And I've got a selection. And I want to clear my selections when items change. So if items come in, wipe out what my selection is. So key doesn't work in this situation. So what can I do? Well, my litmus test, does React know about this? It does. So I probably don't need use effect. So you could do something like this where you're like storing the previous value and like comparing them, and it works. To me, this is really hard to like follow. And so again, let's take it a step further outside of React and just make a variable. All right, when items come in, I do a check, and if I find something, I can use that as my selection. Okay, sharing logic in an event. We see use effect used all the time for something like this, where I've got a product page. I want to show this notification, hey, an item was added to your cart anytime that somebody does an instant buy now, or when they add something to their cart. It's like, well, this makes sense. I've got two different pieces of code that are updating the product, and that product, when it changes, I need to show a notification. So people rightly look at use effect to solve this scenario, but we can actually, again, make it simpler. I can just make that use effect a function call and have both of those event handlers call that function, show my notification. I don't have any use effect anymore. In fact, I don't have anything in state. This is a really simple kind of dumb component that's not really React specific at all. Sending a post request, another instance that we see use effect used a lot. So I've got this use effect. I'm going to say, hey, if someone lands on this page, I want to, send a request so that we're tracking some analytics. So what's wrong with this? Nothing's wrong with it. All right, it's actually fantastic because we're making an external call. I'm going outside of React. So that points to, is use effect a good option for something like this? It is. But sometimes we take that a little bit too far. I've got a form that's going to submit when the user submits the form. I'm going to submit a name, and then I'm going to post it to the API. Instead of doing this in an use effect that's looking for this state to change, let's just do it the JavaScript way, I guess, right? Instead of doing logic inside of an effect that's coming from an event, do the logic in the event itself. I can just rewrite that whole code into, hey, on submit, make a post request. I don't need to set this value in state if I'm not using it later. I can just post it. So last example here is initialization. This one's a little bit more obscure. It's code that only needs to run once. So we might be thinking, hey, if I just pass an empty dependency, it's going to run once and that's it. That doesn't really work in React 18 anymore. They threw a wrench in that plan with double re-renders. It's less composable. It's harder to rip out, put and render this component somewhere else without this also running again. You can do some like fancy, hey, did this run, check, and have that live outside the component. I'm much more of a fan of just, it's okay to have logic outside of your components entirely. You can just put a function or an if statement outside of your component. It'll run once when that bundle is shipped out to the browser, and it's great. There's some downsides, right? You don't want to do this a ton, but it's an effective way to run things one time. So that's the rapid fire use effect breakdown of maybe we should be rethinking about how we use effect. And it all boils down to, am I syncing something external or not? If not, I probably don't need use effect, and your code's going to re-render a whole lot less and be a whole lot less buggy, which is actually what I care about. So that's it. Hopefully you gain some new ways to think about use effect. If you want to reach out on Twitter, there's that. If you love tech conferences like this amazing one, React Rally is in August in Salt Lake. You should check that out as well. You'll see a lot of the same faces, and great way to learn and grow. So thank you.
Thank you for that amazing talk. Do not forget to address your questions to our speaker on Discord. Next up in our program is a breakout discussion room on accessibility, how to convince team, implement, and maintain it. These amazing speakers and more will be there with you. The location for this conversation is Spatial Chat, so just click the button on the timeline to join in on the conversation. And if you're not feeling like heading over to the discussion room, go ahead and take a 10-minute break and join us after that, hopefully with renewed energy to learn some more from our speakers.
AG Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Welcome back. I'm going to go ahead and introduce you to our next speaker, Ruby Jane, who's going to be talking to us about using the React ecosystem with the world's first O1 JavaScript framework. Ruby Jane is a full-stack.NET and React.js developer based in Oslo, Norway, who published a book about writing enterprise React applications. Let's go ahead and welcome Ruby Jane to the stage.
Resumability in the next generation of front-end framework with O of 1 loading time. So yeah, I spice up a little of my TED talk, and it's called Resumability in the next generation of front-end frameworks with O of 1 loading time. Hi, my name is Ruby Jane Cabagnot. I'm originally from the Philippines, but I have been working in Oslo, Norway for the past few years now. And I think some people are already familiar with the term resumability. This was coined by the creators of Quick, including the so-called father of AngularJS, Vishko Hevery, who said this idea of resumability is a mental shift or a paradigm shift from the way the current generation of front-end framework works, which is the hydration process. And so to explain resumability, we need to understand the so-called hydration process of the current generation of frameworks. Because the fundamental problem in this hydration thing in front-end frameworks is that our application or app needs to hydrate at least once in the server and then do the same thing in the browser. But you may ask, so what? Well, basically, it just means that the so-called TTI or time to interactive of the application becomes slower. And this can be very especially frustrating or felt by your end users, especially if you got a big application or your users are using a slower network connection or just older devices, right? And of course, no one wants a frame website that takes forever to download, right? And why the need to hydrate? So to explain this further, the hydration in JavaScript frameworks is like turning your static painting into an interactive touchscreen. So basically, the server provides the initial painting or HTML, and then we need to add the touch controls or the event handlers, right? And the features, which is the application state, to make everything interactive or your application interactive. But the thing is, this step can slow down the initial loading time of your application. So making your painting look touch ready when it's not, which is really frustrating for your users. Like what is that? Simply put, the hydration step in the client side is to make our application interactive. So what about Quick? So Quick is a new web framework that makes your web apps or our web application loads instantly, no matter how big or complex they are. Basically, it just uses, they said 1 kilobyte or 1 KB of JavaScript to start, so ensuring a fast performance at any scale. Now, unlike other frameworks, Quick doesn't require hydration, so your apps are interactive right away. So this is achieved by a feature what they say resumability. Basically, Quick focuses on super fast load times, and even if we're using mobile, or because it's just serving HTML as needed. It just loads the HTML needed and just loaded the JavaScript incrementally. So overall, Quick aims to deliver the fastest possible user experience by optimizing your server-side HTML and rendering, HTML rendering and lazy loading the JavaScript. So what is this resumability? So because Quick is different because it does not require hydration or eager execution of your code on the client side. It uses resumability. So meaning not requiring hydration is what makes the Quick application start up almost instantaneous. So the browser or your client does not need to do anything because it already has all the information that it needs it has information that it needs in the so-called stateful HTML to basically determine where the things are in your application, which includes these three important things: your event listeners, the framework code, and the application code. So Quick. So the way Quick operates is that the page can become interactive without downloading and executing the JavaScript on the client. So this means that the page boot up is almost instantaneous or of one loading time. So this is the primary premise of the Quick framework, is that to serve HTML with minimal JavaScript with only increasing interaction as needed. So here's an image of the hydration for the typical current frameworks of front-end frameworks, and this is reachability for Quick. So how is Quick doing this reachability? In a nutshell, Quick knows how to serialize your closures. And this is the thing that other kind of frameworks are not able to do. So what are closures? So closures are, if you remember, JavaScript closures are a function that has a state or data. So basically, Quick can take that closure and serialize it. This is essentially how Quick is able to just resume or bring your app into life right away from the server to the client without having to do the hydration process. So this is the thing that what makes Quick resumable or replayable, is because the client doesn't need to execute all the components to figure out where the listeners are. So Quick is progressive. So this means that the user starts to interact with the page because Quick will start downloading, executing all the necessary code for that interaction. So in this way, Quick applications act more like streamable apps rather than downloading everything upfront before interaction. So presumability is supposedly simple in concept. You save the server side state and then move it to the client and then continue or resume where the server left off. But it may be simple in concept, but it's hard to implement until Quick. So because Quick can take that closure and serialize it, which is essentially how Quick is able to just resume or bring your app into life right away from the server to the client without having to do the hydration process or eagerly executing your code. So this is the thing about what makes Quick resumable or replayable, is that because the client doesn't need to execute all the components to figure out where the listeners are. So getting started. So you can choose your preferred package manager. So you can run the following command. You can do the npm create quick at latest, pnpm, yarn, and then we have this thing now, Bond, which is the latest runtime now JavaScript that is competing for our attention. So I know it's powered by Zig, so it aims to be an all-in-one JavaScript runtime and toolkit. Yeah, so anyway, back to Quick. So the CLI will just guide you through the interactive menu to set the project name, and then select one of the starters and ask you if you want to install the dependencies. And then, yeah, so let's see Quick in action. So I have here the homepage or the landing page of a simple Quick app. And if you open a DevTools here, we can see that there's no JavaScript delivered to the browser because this is just a simple static page and no interactivity required. And we have here a counter component. So I have here 2 buttons and there's still no JavaScript, right? Until the alert button prints an alert message. And the increment button adds to the wanted counter. But you don't see any JavaScript here until until we click the alert button. So the click alert button only adds the particular piece of code and that contains the alert message that gets downloaded. Not the increment button, not even the framework code gets downloaded or the whole application. So Now let's click the alert increment button and let's see how this particular piece of code gets downloaded and of course a framework code. So what's amazing about that is that because how the code was implemented. Let's take a look at it. So we have here a simple standard counter component. And if you're familiar with React, you notice that the syntax looks pretty much like React with its use of JavaScript, or JSX. So we have our buttons, the increment and the alert button in one single TSS file. And yet Quick only downloaded the JavaScript that it needed. So Quick was able to break apart the function of the alert message and extract it out. So when we click the alert button, remember, just the alert message that gets downloaded and nothing else. You didn't even download to the cloud, to the client, the framework code nor the increment button because it doesn't need to do it at that time. Only when we click the increment button did the framework code gets downloaded gets downloaded to update the UI. So how does Quick do it? So yeah, if you'll notice here, there's this $sign, and there's a component $sign. So whenever you see this $sign in your function or your component or event listeners, that should tell you that this is function or component is being lazy loaded. And you as a developer, but what's amazing about that is that you as a developer doesn't need to do anything or special in your code to make this fine-grained lazy loading to happen. With Quick, it just works out of the box. So Quick has this thing called Quick Optimizer that will run in the build whenever you're building the Quick application, and you will search for all the $signs to create separate files for each function or component or event listeners that it will find. So the question is, how does Quick do it? So let's take a look here at the alert button here, and it has this on-click property. And it has a URL or QRL in Quick that contains all the information that Quick needs to lazy load and then execute. So QRLs is a particular form of URL that Quick uses to lazy load their content. So they're specially formatted URLs that are left as attributes in the HTML to tell Quick where the handlers are for the code should be loaded from. And it points a JavaScript chunk to be lazy loaded. And also, Quick has this thing called Quick Loader. So Quick Loader basically does the job of registering global events. And if event occurs, search the DOM pointing to the QRL that should be lazy loaded. It is about 1 kilobyte, 1 millibyte. So basically, Quick Loader is the one that allows knows how to download the rest of your application on as needed basis. And also we have this Quick JSON. So this is how Quick is doing serialization of your application, including your application code, your framework code, and more significantly, how it can serialize your event listeners. So the app state is stored in Quick JSON, making the HTML CDN cacheable. So what about Quick React? So Quick React allows you to use React within Quick. So basically the advantage of using Quick React is that you can use existing React components and libraries within Quick. Because another thing about Quick React is with React is that it has a huge community with built tools that make your life easy for us as developers. So Quick is newer and promising, but it's not yet at a point where it can pull off people away from the React's bustling ecosystem. So that's a good thing, right? Before you can use Quick React, you can need to configure the Quick project to use the Quick React. So if you don't have a Quick application yet, then you need to create one first, then follow the instructions and run the command add React to your application. Then the above command will then install the required dependencies in your package JSON. So Like React, so Quick uses JSX syntax to define the HTML output. So Quick React allows you to use React within Quick. So the advantage, like what I said, is of using Quick React is that you can use your existing React components and libraries within Quick. So let's have a quick demo on Quick React with Material UI. So here we can make your interactive React apps without React ever loading in the user's browsers. So in this case, we have the Material UI to load React components using the Quick framework. So if you as interact with this application, you see that the React never loads. You can see in the DevTools that the React does not appear. But we can still add this attribute client visible to make it so that certain components hydrate when visible on load or whatever. So here in the DevTools, we'll see that the React loaded, but only for this. You can see in the DevTools but only for this particular one component. So this is using the Quickify utility in Quick to essentially turn React components into pure, simple HTML that only runs on the server. And then you can optionally make them reactive using signals in Quick that loads extremely little amount of client-side code to add interactivity. So this can help make your application that use React components basically, lightning fast. So Quick React. So here's a quick React. So in a nutshell, the rules are the following. So you just don't mix React and Quick components in the same file. And then there's a recommended folder that you can put your React or React components or folder. Then you can also like Quickify to convert the React components into Quick components. So Quick and Quick City. So Quick basically is a reusability framework at its core. So Quick City is a meta framework built around Quick. So it offers directory-based routing, nested layouts, file-based menus, and data endpoints. So basically, Quick City is to Quick what is Next.js to React, and then Nox is to Vue, and then Svelte is to Svelte with Kit to Svelte. So to recap, Quick and its reusability. So there's no hydration, which means performance scales well of all one notation. So the developer experience is good and very performant, and basically Quick gives us this fine-grained lazy loading feature out of the box. It will automatically split up your application to smallest possible chunks of JavaScript code. So Quick is a big mental shift from where things are in the front framework. But I believe it's a very exciting times for that front end world. And so again, thank you React Summit, and have a good day.
Thank you for that amazing talk. Don't forget to address your questions to our speakers on Discord. Next up, we're going to highlight one of our gold sponsors, Content.ai. Content.ai is the headless CMS that helps all roles focus on their job and deliver standout experiences. Let's go ahead and give a warm welcome to our next speaker, Jessie, who's going to be talking to us about OpenAI in React, integrating GPT-4 with your React application. Jessie, aka Code Stacker, is an accomplished full-stack developer with a dedication to teaching others about web development. By leveraging his self-taught experience, he creates engaging and informative content through articles, videos, live streaming, and interactive presentations. His areas of focus include JavaScript, TypeScript, React, Node.js, Next.js, Tailwind CSS, and MongoDB. In his pursuit of knowledge sharing, Jesse continuously updates his skills and techniques to provide cutting-edge insights and tutorials for web developers of all levels. Let's go ahead and head over to the Summit Q&A channel and leave some congratulations to Jesse as we go ahead and welcome Jesse up on stage.
Artificial intelligence. It's just a fad, right? It's going to blow over like a blockchain. Well, actually, I don't think so. In fact, AI is far from a fad. It's a revolutionary change. It's helping businesses solve real problems and making employees and individuals more productive. So let's talk about why AI matters now more than ever and how AI can take your React applications to the next level. I'm Jesse Hall, a senior developer advocate at MongoDB. You might also know me from my YouTube channel, CodeStacker. So throughout this talk, we're going to explore the demand for intelligent apps, practical use cases, limitations of LLMs, how to overcome these limitations, the tech stack that we're going to use to build a smart React app, and how to integrate GPT, make it smart, and optimize the user experience. So if you're new to the AI space, maybe you don't know all of these terms and technologies that we're going to talk about. Or maybe you're scared that you're going to miss out on what all the new kids on the block are talking about. But don't worry, because we're going to define and demystify a lot of these concepts. And then we're going to go deeper and discuss some of the considerations that you need to make whenever you're building AI into your applications. There is a huge demand for building intelligence into our applications in order to make these modern, highly engaging applications and to make differentiating experiences for each of our users. You could use it for fraud detection, chatbots, personalized recommendations, and beyond. Now, to compete and win, we need to make our applications smarter and surface insights faster. Smarter apps use AI-powered models to take action autonomously for the user, and the results are twofold. First, your apps drive competitive advantage by deepening user engagement and satisfaction as they interact with your application. And secondly, your apps unlock higher efficiency and profitability by making intelligent decisions faster on fresher, more accurate data. Almost every application going forward is going to use AI in some capacity. AI is going to wait for no one. So in order to stay competitive, we need to build intelligence into our applications in order to gain rich insights from your data. AI is being used to both power the user-facing aspect, and the fresh data and insights that you get from these interactions is going to power a more efficient business decision model. Now, there are so many use cases, but here are just a few: retail, healthcare, finance, manufacturing. Now, although these are very different use cases, they're all unified by their critical need to work with the freshest data in order to achieve their objectives in real time. They all consist of AI-powered apps that drive the user-facing experience, and predictive insights make use of fresh data and automation to drive more efficient business processes. But how did we get to this stage of AI? Well, in the early days of computing, applications primarily relied on analytics to make sense of the data. This involved analyzing large data sets and extracting insights that could inform business decisions. As computing power increased, it became easier to analyze larger data sets in less time. Now, as computing power continued to increase, the focus shifted towards machine learning. Traditional batch machine learning involves training models on historic data and using them to make predictions or inferences about future events, about how your user might interact in the future. The more data over time that you feed your model, the better it gets, the more you can tune it, and the more accurate the future predictions become. So as you can imagine, this is really powerful because if you can predict what's going to happen tomorrow, you can make really great business decisions today. So batch AI, as the name implies, is usually run offline and on a schedule. So it's analyzing historical data to make predictions about the future. But therein lies the problem with batch AI. It's working on historic data. It can't react to events that happen quickly in real time. Now, although it's really great for industries such as finance and healthcare, we need data on things that are happening now. And so this is where real-time AI comes in. Real-time AI represents a significant step forward from traditional AI. This approach involves training models on live data and using them to make predictions or inferences in real time. This is particularly useful for fraud detection, for instance, where decisions need to be made quickly based on what's happening in real time. What good is fraud detection if the person defrauding you has already gotten away with it? And then finally, that brings us to generative AI, which represents the cutting edge. This approach involves training models to generate new content. Now, this could be images, text, music, video. It's not simply making predictions anymore, it's creating the future. Now, fun fact, the images here were all created using DALL-E. So over the years, we've seen AI evolve from analytics to real-time machine learning, and now to generative AI. And these are not incremental changes. They're transformative. They shape how we interact with technology every single day. So let's zoom in a bit. We have something called generative pre-trained transformers, or GPT. These large language models perform a variety of tasks from natural language processing to content generation and even some elements of common sense reasoning. And they are the brains that are making our applications smarter. But there is a catch. GPTs are incredible, but they aren't perfect. One of their key limitations is their static knowledge base. They only know what they've been trained on. There are integrations with some models now that can search the internet for newer information, but how do we know that that information that they're finding on the internet is accurate? They can hallucinate, very confidently, I might add. So how can we minimize this? Now, they can't access or learn from real-time proprietary data, your data. And that's a big limitation, don't you think? The need for real-time, proprietary, and domain-specific data is why we can't rely on the LLMs as they are. This is especially true in the business context where up-to-date information can be a game changer. So what's the solution? How do we make these models adaptable, real-time, and more aligned with our specific needs? Well, this brings us to the focus of our talk today. It's not merely about leveraging the power of GPT in React. It's about taking your React applications to the next level by making them intelligent and context-aware. We're going to explore how to augment React apps with smarter capabilities using large language models and boost those capabilities even further with retrieval augmented generation, or RAG. And so we're not just integrating AI into React, we're optimizing it to be as smart and context aware as possible. Now, what's involved in retrieval augmented generation? First up, vectors. What are vectors? These are the building blocks that allow us to represent complex, multidimensional data in a format that's easy to manipulate and understand. Now, the simplest explanation is a vector is a numerical representation of data, an array of numbers. Now, these numbers are coordinates in an n-dimensional space, where n is the array length. So however many numbers we have in the array is how many dimensions we have. Now, you'll also hear vectors referred to as vector embeddings or just embeddings. So here's a real-life example of vectors in use. When you go to a store and you ask a worker where to find something, many times they're going to say, go to aisle 30, bay 15. And so that is a two-dimensional vector. And we also notice at stores that similar items will be placed near each other for ease of searching and finding. Like the light bulbs aren't just scattered all over the store, they're strategically placed to be found easily. And video games use 2D and 3D coordinates to know where objects are in the game's world. With these coordinates, we can compute the proximity between objects to detect collisions, for instance. And the same kind of math is used to compute the similarity between vectors during vector search. And now, if you're a Stargate fan, the gate addresses are made of at least 7 dimensions that are like vectors. And so to locate stargates in other galaxies, you can add an 8th or 9th dimension, just like you would a phone number's area code and country code. So this shows how adding dimensions significantly increases the size of the virtual space in which our data is organized. And so again, what makes vectors so special? They enable semantic search. In simpler terms, they let us find information that is contextually relevant, not just a keyword search. And the data source is not just limited to text. It can also be images, video, or audio. These can all be converted to vectors. So how do we go about creating these vectors? Well, this is done through an encoder. The encoder defines how the information is organized in the virtual space. And there are different types of encoders that can organize the vectors in different ways depending on the use case. There are encoders for text, for audio, images, and so on. And many of the most popular encoders can be accessed through Hugging Face, OpenAI, and many others. So now let's tie all of this back to retrieval augmented generation. RAG leverages vectors to pull in real-time context-relevant data to augment the capabilities of an LLM. Vector search capabilities can augment the performance and accuracy of GPT models by providing a memory or a ground truth to reduce hallucinations, provide up-to-date information, and allow access to private data. So first we take our private data or custom data, whatever it may be, and generate our embeddings using an embedding model, and then store those embeddings in a vector database. Now again, this data could be documents from our site, could be blog articles, videos, images, PDFs, etc. Now you don't have to use LangChain to facilitate all of this, but it's very helpful, and we're going to talk more about that later. And once we have our embeddings for our custom data, we can now accept user queries to find relevant information within our custom data. Now to do this, we send the user's natural language query to an LLM, which vectorizes the query. And then we use vector search to find information that is closely related, semantically related to the user's query, and then we return those results. And we can do anything that we want with these results. We could summarize the answer to their question based on the custom data. We could respond with links to specific documentation pages and so on. So imagine your React app has an intelligent chatbot. With RAG and vector embeddings, this chatbot could pull in real-time data, maybe the latest product inventory, and offer it during a customer service interaction. With RAG and vector embeddings, your React app isn't just smart, it's adaptable, real-time, and incredibly context-aware. Now, talk is cheap. How do we actually do these things, and what technologies can help us? Well, the first tool that we're going to use in our tech stack is Next.js, and we're going to, of course, use version 13.5 with the app router. Next.js and Vercel just make building apps with AI technologies so easy. And then OpenAI has been spearheading advancements in language models with models like GPT 3.5 Turbo and GPT-4. And while there are many other language models out there, today we're going to focus on OpenAI, and we're going to use them for embedding and for generating responses. And then LangChain is another crucial part of our tech stack. It helps us in data preprocessing, routing data to the proper storage, and making the AI part of our app more efficient. And then there's the Vercel AI SDK. It's an open source library designed to build conversational streaming UIs. It abstracts so much boilerplate code that you would have had to write otherwise. And then last but not least, where are we going to store our vector embeddings? MongoDB. We're also going to leverage the MongoDB Atlas vector search. It's a game changer for AI applications, enabling us to provide a more contextual and meaningful user experience by storing our vector embeddings directly in our application database, instead of bolting on yet another external service. And it's not just vector search. MongoDB Atlas itself brings a new level of power to our generative AI capabilities. Each technology in the stack is chosen for a specific reason, and when combined, they enable us to build a smarter, more powerful React application. So let's take a look at how to build a React application with these technologies. And this is what we're going to build, an AI-powered documentation site. Now, this site will not only answer questions, but also provide contextually relevant information, summarize answers, and provide links to relevant pages to dig deeper. What will we need? An OpenAI API key, Node.js 18+, and a MongoDB Atlas account. Now, first thing that we need to do is create embeddings for our custom data. Now, since this chatbot is going to reference our custom documentation, we'll assume it's written in Markdown files. And so this embedding function is just a Node app, a single file with less than 60 lines of code. And we're going to run this when we build our Next.js app. So we'll need to make sure that we have .env, LangChain, and MongoDB installed, and then we'll import everything that we need. We have the LangChain text splitter, the MongoDB Atlas vector store, OpenAI embeddings, MongoDB client, and then .env. Below that, we'll prepare our MongoDB connection using our connection string and get the collection that we want to use. And then we need to process our documentation files. We have to split them into chunks that the encoder can use. So we'll create a splitter using the recursive character text splitter from LangChain to split the Markdown files that we're fetching. Now notice that you can choose the chunk size and overlap, which is helpful to make sure that we have enough context in each chunk. And then we'll create our output, awaiting the splitter create documents function, passing it our documents. And lastly, we'll use LangChain to store these embeddings in our MongoDB collection. We're passing to MongoDB Atlas vector search the output, creating a new AI embeddings, and then giving it the metadata for the collection, index name, text key, and embedding key. These keys are the fields that contain the original text and the embedding vectors. And then we close the MongoDB connection. And this is an example of what ends up in our database. We have our original text in Markdown format, our vector embeddings, and metadata that identifies the portion of the document that this text came from. Now, one last thing that we have to do to prepare the data for searching is to set up a search index on our collection in MongoDB. You can do that through the Atlas UI using this JSON configuration. So here we're specifying the dimensions of the encoder model that we're using. In this case, it's 1536. And then you can also define the similarity and type to use. Okay, so now the fun part. Let's set up the Next.js app. Now, if you'd like, you can use the Next.js LangChain starter, which already has everything set up except for the MongoDB driver. So you'll also need to npm install MongoDB. Next, add your OpenAI API key to the environment variable file. And then for good measure, you can test the app by running npm run dev. You should now be able to chat with OpenAI. But this is just a standard chat with the ordinary models that we all know and love. So now let's make our GPT model smarter by giving it our custom information. Now this is the default chat route provided with the Next.js LangChain template. And we can see that it utilizes the Vercel AI SDK, along with LangChain, OpenAI chat models, and some LangChain. This is also utilizing the Vercel Edge runtime to lower latency and help with streaming our responses back to the user. Now further down this route handler, we are creating an OpenAI chat. And here we can specify which model we'd like to use, GPT-4, GPT 3.5 Turbo, etc. We're also setting streaming to true because we want the response to start populating in the UI as fast as possible and stream to the user. This is a much better experience than just throwing up a loading spinner and having the user wait 1 to 30 seconds to have a response come back. And then it returns the streaming response. And so in this route is where we need to inject our own custom data. To do that, we're going to use the LangChain MongoDB vector search method. And in this route, we're going to connect to MongoDB just like we did before, and we're going to pass to this the question that the user asked. And then we'll use the MongoDB Atlas vector search LangChain method to create vector embeddings for the user's question. We have to also create vector embeddings for the user interaction so that we can then compare it with the other vector embeddings that we have stored in MongoDB for our custom data. And then we'll tell it which collection, index, text key, and embedding key to use. And then when we do the search, we're using something called maximal marginal reference to find the related documents. We can specify the number of results to fetch and how many of the top results to return. This allows us to refine how accurate we want to be. And finally, we close the connection and return the retriever output. Now back in our chat route, we're going to get the last message from the user and pass it to the new vector search route that we just created. Now we can include the results of that search and pass everything to the standard LLM. We'll include some context, the vector search results, and the user's question. So the prompt we're using here is, you are a very enthusiastic MongoDB representative who loves to help people. Given the following sections from the MongoDB documentation, answer the question using only that information. Output it in Markdown format. If you are unsure and the answer is not explicitly written in the documentation, say, sorry, I don't know how to help with that. And finally, we replace the last user's message with our updated message that includes our custom information and context. That then gets passed to the LLM and we receive our response back. And these are the results. The question is, how do I get started with MongoDB and Node.js? It answers with a summary and links to specific pages in the documentation for further help. Now, if you want to build something like this from start to finish, be sure to attend my workshop. You can get more details on how to sign up for that on the conference website. And we covered a lot of ground today, from understanding the role of AI in modern applications to its seamless integration with React using GPT models and RAG architecture. We explored the limitations of large language models, how you can overcome them using real-time and custom data. We looked at a great tech stack that seamlessly integrates AI into your application using Next.js, OpenAI, LangChain, the Vercel AI SDK, and MongoDB Vector Search. And these are not just buzzwords. These are tools that can revolutionize how we think about building smart applications. Now, remember, the future is not just about smarter AI, but also about how well it's integrated into user-centric platforms like your next React-based project. So be sure to give MongoDB Vector Search a try in your next AI application. Thank you, and I hope this was helpful.
Thank you for that amazing talk, and don't forget to address your questions to our speakers on Discord. We're going to go ahead and introduce you to our next speaker, Facundo, who's going to be talking about pushing boundaries to the edge. Among the different things that Facundo enjoys, some of them are meeting and connecting with new people, web development, and talking a lot. After more than 12 years working as a developer, creating products and projects for different organizations and clients, he thought it would be great to combine these three interests in some way. And that's how he came across the world of developer relations. Nowadays, Facundo works as a DevRel engineer at Storyblok, and he spends his time engaging with the dev community, speaking at events and conferences, creating and sharing content, writing articles for different websites and platforms, leading workshops, and you guessed it, talking a lot. He is one of the organizers of the React Buenos Aires, the biggest React community in Argentina. Well, let's go ahead and introduce Facundo. The stage is yours.
Hello everyone, my name is Facundo and today we will talk about the edge. First of all, I want to introduce myself. As I said, my name is Facundo Giuliani. I'm from Buenos Aires, Argentina. I'm a developer relations manager. I'm the manager of a developer relations team at Storyblok. I'm also one of the organizers of React Buenos Aires. React Buenos Aires is the biggest React community in Argentina, and we organize monthly meetups. And I'm also one of the organizers of Dev Summit Argentina, another community of developers in the country. So for today, I wanted to start a little bit with some 90s vibe. I wanted to discuss on how the websites were created when they look like this one, the Space Jam website. If you go to the internet, you can see that it's still up and running and it's looking like this. But at this time in the 90s, the websites worked, and they still work in this way. You have a web browser or a mobile in your mobile device or your computer. You send a request to a web server. That web server executes the request, generate the content, and then it sends the content to you after processing your request and generating all the data and the content that you need to see the page that you are requesting. Actually, this web server is an actual computer living somewhere on the world. Well, this is an image from the past, from the 90s, but it used to be like this. I mean, a computer that if you turn off that computer, your website is not up and running anymore. So you need to be careful with the wires and things like that. But yeah, I mean, that's the basic way of working of a web server and the websites. This way of working has an issue, although, and the issue is that we have our web server in one unique location where the people is sending the request and expecting that web server to process the request and send the data. What it means is that if we have multiple people, let's say thousands of people requesting the content or sending requests at the same time, we may be overloading this web server. And not only that, another thing that we have to consider is that these requests that we are sending from any part of the world, we have to travel to this unique location where the web server is located, and then all that time that it takes to get from your location to the web server, it will affect the performance and the load time of your web page. So those are some issues that a basic server-side rendering logic has. The multiple people accessing to the same web server, and also the different parts of the world where that people is requesting the page. So in order to solve this scenario, or in order to see a solution for this particular use case, after the years, a new concept was defined, the concept of content delivery network. This is a group of geographically distributed servers that helps you to speed up the delivery of web content, bringing that content closer to where the users are. So basically what we have with these CDNs, as they are called, is we have different servers, like the web servers that we were mentioning before. We have different web servers in different parts of the world, and these web servers are improved to deliver static content to the users. So basically what we will have in these different nodes, as they are called in this network, are static assets like images, videos, but also HTML files, CSS files, and JavaScript files. They are going to be hosted and cached in these different nodes of our network. And when a user wants to request one of these resources, the request that they are sending will travel to the closest node of the network. So let's say that I live in Argentina and I have one of the nodes of this network in Brazil. Instead of sending my request and having to go to a web server located in the UK, let's say, my request will travel to the Brazil node of the network, and then I will get all the resources from that node. This helps to reduce the bandwidth consumption because we won't be accessing all the users or all the visitors to the same web server. And we will have a better performance because of this and because of the request having to travel less, let's say, going to the closest node of the network. I mean, depending on your location, depending where the network has these nodes. And there will be more security because instead of accessing to the origin of the data or the content, your request will travel to different nodes without having to know which is the actual web server that is hosting your website. Because one thing that I mentioned, and you have to consider, is that these CDNs, they work with static assets. That means that if we need to generate dynamic content or dynamic assets, or we need to generate these assets dynamically somehow based on a logic that depends on the user, we will still need the origin server to do that. So as I was mentioning, these CDNs work with static content. That's why a new term was developed with the years, the static site generation. You may be familiar with frameworks like Gatsby or Next.js, where you can generate static assets at build time, JavaScript files, CSS files, and HTML files. The idea of this is that you are able to create a website that can be hosted in these CDNs, so you don't depend on an origin server. And having this same idea in mind, the concept of the Jamstack was developed, where the idea was to focus most of the logic of your websites on the static assets and managing the dynamic data with different approaches, like APIs, serverless function, or small pieces of code that is running server side, but not your whole website living on the web server or having to wait for each request to be processed to return or deliver this content. But as you can see, there's another issue now, and the issue is that we can only manage static content with the CDNs. So as I was mentioning before, if we need some dynamic data or we need to generate a certain asset that is not living or is not cached on the nodes of the CDN, we will have to send the request to the origin server, and there's where the performance issues start to appear again. We are lacking the security and the performance that we have with a CDN. So having this issue in mind and other ideas and approaches, and always trying to improve the situation, of course, the IT industry came up with a new concept, the concept of the edge. The edge is basically a distributed network architecture where the client data is processed as close to the originating source as possible. So that means that if we will use some data coming from our users or some context from our users, we can grab that context as close as possible from them and execute the server-side logic closer to them, instead of having to send the request and all that information to an origin server and wait for the processing. So in this case, what we will have is basically using the same distribution that we had for a CDN, we will have different origin servers in the different locations. So if I need to process data coming from the users, and I have a user from Argentina wanting to request a certain resource or sending a request, that request will be processed in the closest node of my edge network, which in this case could be, again, Brazil, let's say, instead of having to send that request to one unique origin server that is living in a particular location of the world. So in this case, we will have our origin server replicated in different parts of the world, processing all the requests that are coming from the different users. One thing that you have to keep in mind is that when we are talking about the edge, it's not the same the edge as a serverless function, because even though that we will have some of the benefits that we have with the serverless functions, like we won't need DevOps because the servers are going to be managed by the provider, and we are only going to pay for what we use. I mean, instead of having to pay for a dedicated web server, we will have our processing time defining how much we are going to pay for that. So that means that we won't have underutility of the web servers, because the only processing that we will have is when the requests are coming and are being processed and executed. I mean, all of these are aspects that we can identify and consider on serverless functions. The thing is that the edge is not only this, because a serverless function can be deployed to a centralized web server. And if that's the case, we are going to have the same issue that we had before with the origin server, I mean the unique origin server. So the edge is going to solve even issues that we may have with the serverless functions. I mean, the edge would be a combination between what is a serverless function and the CDNs. We will have the possibility of executing server-side logic without having to configure or maintain these web servers. And on the other hand, we will have that logic living on different nodes of a certain network of web servers, executing the different requests that are coming from the users from different parts of the world. So as you can see, with the edge, we will have some of the benefits that we already had with the CDNs, which are better performance and more security, but we will also have real-time insights or easy scalability, because in this case, we won't have only static assets, we will also have the possibility of running server-side logic and process the requests that are coming from the different users. So you may be asking, what are some of the use cases that we can apply the edge or use the edge for? Okay, so as you can see, we can use edge functions, well, or that will depend on the provider, but we can use this edge logic or edge computing for personalization, for instance, based on the different user or type of users that are visiting our website. We can deliver customized content for them. We can use geolocation, show particular content on our website based on the location of the user that is visiting this website. We can also apply logics for A/B testing, test different versions of our content or our pages based on certain aspects of the visitors. And we also can implement security logic. We can verify that the users that are visiting our website or that are accessing to a particular content that we are offering are who they claim to be, using authentication or authorization that we can implement in this logic that is going to live on the edge network. So as this is a React conference, we will talk about the edge, but based on some React-based frameworks. I mean, you are a React developer, how you can use or get the advantage of the edge when you are creating your projects using React or a React-based framework. Cool. So talking about that, we will start with Next.js. Next.js offers the feature edge functions, which are basically serverless scripts that are running or being executed. I mean, they are executing server-side rendering, and they are distributed into different regions. As we mentioned before, we have this logic that is very similar to the serverless functions, but distributed in different regions of the world. The edge functions that are offered by Vercel, in this case, or Next.js, they run on top of the edge runtime. That means that you will have some standard web standard APIs that you can use on the code that you are creating and that is going to be executed server-side, but it's not a full Node.js runtime, so you won't have access to all the features and all the capabilities that you have on a Node web server, right? So that's something that you have to keep in mind. But on the other hand, this edge runtime that was built on top of the V8 engine was created to be more performant when executed on the edge, and that's the reason why we are using the edge runtime for the edge functions. An example of an edge function that you can see is, for instance, catching the request that is coming from a user, and based on what's the page that they are visiting us from, we can return a certain message. As you can see, we can set a particular runtime depending on the configuration that we set or the runtime that we select. Is Vercel is going to identify if we can use this piece of code as an edge function or if it needs to be a serverless function that is located in one particular location, based on the different servers that they offer and the infrastructure that Vercel is offering to us. Another example is, for instance, catching the requests that are coming from the users, and based on the user ID that is that has the person that is visiting our web page, we can retrieve data related to that user and use that for any processing that we want to do on our website. These are examples of edge functions that you can create using Next.js and Vercel. Vercel and Next.js also offer the middleware, which is an intermediate tier that executes custom logic before a request is processed. So with the middleware, you can define also an edge function that is executed whenever a request is coming to the server and before that request is processed. So in this case, this is an example of an authorization function. I mean, that is basically verifying that the user that is visiting our website or that is calling to this endpoint is has the proper security to see the content. Basically, what we do with the middleware is execute all the requests that are coming from the different users. The same here, we are using a feature flag to show searching content or a different content. We can implement an A/B testing campaign with a middleware, because we are going to catch all the requests that are coming to the web server, and based on that, we are executing this server-side logic and sending the proper content or the proper web pages to our visitors. Another React-based framework is Remix. Remix, if you're familiar with the framework, you can create a main rendering function, which, you will use code React, basically. You are going to create React components, and you can use that to render the content of your page. But also, Remix is offering the possibility of executing server-side logic. As you can see on the second line of this example, we are getting data from a loader, and this loader is basically a function that is being executed on the server side to request data from a certain source. Remix offers a possibility of creating action functions and loader functions, which are executed server side. So we can retrieve data, we can read data, create data, execute different type of actions, and these action and loader functions are going to run on the edge. So Remix has what they call the next generation edge, which is basically defining different levels of dynamism on the different routes of our website, and with a per route basis. You can say that one route of your website is going to run on the edge using the node runtime. You can define that a different route is going to run on the edge runtime or GNode, depending on the provider that you are using. Actually, you can define that configuration. You can run Remix code on the Vercel web servers and defining the runtime that you want to use for the server-side logic that you are executing. This is an example of using Vercel as a provider with a Remix project. There are different providers that offer the possibility of working on the edge. Another provider is Netlify. Netlify offers the possibility of creating and managing edge functions. These edge functions work very similar to the ones that are offered by Vercel and Next.js, but running on top of a GNode runtime. And that's an open source runtime that offers different functionality. Another provider is Cloudflare. Cloudflare offers the workers, which are basically what Vercel and Netlify used as an origin or as an idea to create their own edge functions. And on the other hand, we also have Fly.io, which is a new provider where we have the possibility of running a full stack application on the edge, also with the databases. So instead of delivering or distributing edge functions or small pieces of server-side logic, we can deploy a full stack application with its own database to execute that on the edge. As you can see, there are differences between the different providers, and basically that's what is going to define the capabilities for your website and your project on what type of code or logic you can execute server-side, because what you are going to create with the code of your project will have to work with the definitions and capabilities of the provider that you are using for your website. So as you can see, the edge is here and it's the future. You can use the edge on your project. You can define a logic that runs on the edge on your project. But I also think that this is the starting point for new things that are going to be developed in the future with this same approach of having decentralized server-side logic that is running on different parts of the world and geographically distributed to be more performant, more efficient, and more secure. So I encourage you to try edge functions and different approaches to use the edge network and see what you can create and what you can offer to your visitors and users. Thank you very much. Enjoy the conference and see you soon.
Thank you for that amazing talk. Do not forget to ask all of your questions to our speakers on Discord. Let's go ahead and talk about our party sponsor, Clerk. Clerk is proud to be a sponsor. If you haven't heard of them, Clerk provides drop-in authentication for React. And next up, we're going to go ahead and introduce Aiden, who's going to be talking about virtual DOM back in Block. Aiden is a front-end performance engineer with a passion for efficient developer tools. He's the creator of Million.js and is the resident performance nerd at Dimension. Let's go ahead and head over to our Summit Q&A chat and leave some warm round of applause as we bring Aiden up onto the stage. Aiden, the stage is yours.
Hi, my name is Aiden Bai. I'm the author and creator of Million.js, a fast virtual DOM replacement for React. I'm also a student at the University of Washington for CS. Actually, this is my dorm right here. So today I'll be talking to you guys about virtual DOM, but this time back in Block. A little over 4 years ago, Rich Harris released Virtual DOM is Pure Overhead. Rich most notably said, "You've probably heard the phrase, the virtual DOM is fast, often meant to say that it's faster than the real DOM. In fact, it's a surprisingly resilient meme." In his article, Rich Harris argues that the virtual DOM, a widely praised feature of frameworks like React, is not as efficient as many of us believe. He goes on to critique the way it works and presents Svelte. But what followed years after was the emergence of a new meme, that the virtual DOM is pure overhead. The meme became so resilient that it turned the no virtual DOM framework movement from an iconoclastic subgroup to a fully fledged crusade. Thus, the virtual DOM was relegated to the annoying cousin nobody likes but has to invite to family gathering status. It became a necessary evil, a performance tax that we had to pay for the convenience of declarative UIs. Until now. So the natural question everyone, or you guys, are probably asking is, why is the virtual DOM slow? But I think a better question to ask is, when can the virtual DOM be slow? And it's all because of this guy. You've probably heard his music video. I don't actually mean this guy, but rather the component that powers him. Let's take a look. One branch is it could return unless you're AngularJS, if math.random is over 0.5. It could also return, the Rickroll GIF. So you can see here naturally that there could be an update between the Rickroll and the AngularJS. So how does this work? Well, here's where the virtual DOM comes in. So the virtual DOM is essentially a tree or data representation of the user interface, or in this case, the DOM. You can see here that there are 5 nodes in the old virtual DOM tree, and there's 3 nodes in the new one. So how do we update the user interface based on these trees? Well, we run a diff. So we traverse both trees at once. First, we check the first node. Has the first node changed? I don't think so. How about the second one? Yes. 2 has been changed to 5. And so what we can do here is do a DOM update. It's just like doing .intertext or replacing a node or whatever. Let's go on. If we check the third one, we can see that the third node has been removed. And so we can remove it in the DOM. So on and so forth. You can see here that the virtual DOM is really nice because it doesn't matter what the shape of the UI looks like. It doesn't matter how much nodes we have. Eventually, we can process all of them and do the minimal amount of DOM updates to the page. So this is great, right? Essentially, you can change old UIs to new UIs using this virtual tree structure. But what happens when you have more nodes? You're doing 5 diffs, right? It's nice when you have 5 diffs because it's like you're going to have to change 5 nodes anyway. But what happens when you only change 1 node? Well, you still have to do 5 diffs here, right? You have to check if foo is the same, and in this case, you only update 1. So this can get really inefficient. So imagine it as O of n. As your UI gets bigger, the more you have to diff, and the slower your app gets. And here's a visualization of that. Once you have 200 nodes in your page, it gets really slow. So today I'm going to introduce something new, a new approach to, doing the virtual DOM. instead of diffing the tree structures and doing all this stuff, what if we just diff the data and not the DOM? Well, this all starts with the compiler. The compiler can look at the virtual DOM ahead of time. So we still have this tree structure here. It's just not in the runtime. So here we know the relationship between the data and the kind of UI here. So you can imagine in React, you have like a use state with a count and whatever. This could be a count, or this could be a node in our case. We don't necessarily know the values beforehand, and so we put a placeholder node inside of these. So essentially we have this tree, and the dynamic values that are put in the nodes are marked as potentially could be a value there. And so what we do now is just traverse the tree like as usual. We check the first one as a placeholder, so on and so forth. And when we hit a placeholder, we can create something called an edit map. This is the secret sauce to the block virtual DOM. Essentially, what we say is when node 1 changes or this data changes, we change this node. Essentially, we have this relational mapping between the data and the UI. And we can do this for every single placeholder node on the tree. And during runtime, the edit map really shines. You can see here, when we're trying to update node 1 and node 2's value to 3 and 4 respectively, you can see that we only have to do 2 diffs. So we check if the data is the same, 1, 3, yes, it has changed. Check it again, it has changed, and we can make updates to the virtual DOM. You notice here that the virtual DOM would take 5 diffs, but with the block virtual DOM, it only takes 2. And this scales infinitely. This is essentially an O of 1 optimization to the virtual DOM. And this is really cool because, we have the same example of 200 nodes on the page. Now you can see that the change is O of 1. There's every single time you update, there's an O of 1 change. And it's really fast. So I work on a project called Million.js. It implements the block virtual DOM as a drop-in replacement for React. Using that, it is 30% faster than Preact, which is a lightweight React alternative, and over 70% faster than React on synthetic benchmarks. And so this is really indicative of better performance using the block virtual DOM, particularly on benchmarks compared to traditional virtual DOM alternatives. And so essentially, Million.js and the block VDOM are faster than React. And if you don't believe me, we can take a look at this example. I have a really bad computer, so bear with. When I click on this button, it's really red, and that's indicative of bad performance. But when I switch to Million, when it loads, if it doesn't beach ball me, you can see that when I click here, it's way better. Before, it was just a plain red. It was a bloody red like circle. But now, it's in the greens and the yellows. And so Million is way better at rendering lots and lots of data heavy and UI heavy applications. Thank you so much for listening. This is just a brief lightning talk of my work on Million.js and the block virtual DOM. There is so much research to be done in this field. The block virtual DOM was originally introduced maybe 2 years ago by a project called BlockDOM. There's so much more to be figured out, researched, and introduced. Just like Signals, the block virtual DOM is a potential solution to existing virtual DOM libraries, like React particularly. And this is my mission with Million.dev. What if we were able to write our React applications with this faster virtual DOM and not have to pay any of the consequences for it? And so if you're interested, check me out on Twitter at AidenYBy, or check out my project, Million.dev, on the interwebs. Thank you so much for listening. Have a great day.
Thank you for that amazing talk. Don't forget to address your questions to our speakers on Discord. And next up, we have our speaker, Lucky, who's going to be talking about accessibility beyond the theory, integrating accessibility testing into your workflow. Lucky is a software engineer at BBD with experience in building enterprise software solutions in the banking, insurance, entertainment, education, and telecommunications sectors. Lucky, the stage is yours.
Hello, everyone. My name is Ntlantla Kingosi. I am a software developer, among many other things. I am giving this talk from the beautiful city of Johannesburg, where I was born, raised, and live till today. Now, if you have no idea where Johannesburg is, it is a big city, not the capital, but definitely the economic hub of the beautiful country known as South Africa. And if you're not entirely sure where South Africa is, well, it's simple. It's in the name. You just need to look at it. We are at the southern tip of beautiful continent of Africa. Now, this should be showing you that when they said that some of the most difficult things in computer science is naming things, they definitely didn't think about South Africans, because clearly we're really good at this. As I said, I am a software engineer and I work for a company called BBD. And again, because we're good at naming things, BBD stands for the last names of our founders. Now, BBD started about 39 years ago, right here in South Africa, by 3 engineers, and we've now grown to be a global bespoke software development firm with probably about 1,200 professionals spread across 7 cities all over the world. We deliver bespoke software solutions into a number of sectors. But my job is slightly different from everyone else at BBD. That's because I work in a unit we call ATC. In paper, we're responsible for a number of things, such as what we call specialized consulting. We are responsible for training BBD's 1,000 plus employees. We're responsible for also doing community engagements and a whole bunch of other things that are quite interesting. I love community, and to fuel this passion, I also am involved with a number of meetups around Johannesburg. None of this matters. The most important thing for you to know about me is that my Twitter handle, or X, is at @nlike_ngosi. Please feel free to follow me and let me know what you think of this talk. Let me dive straight into it. I turned 30 2 days before the recording of this video. Now, with this new age, I've realized that I need to start looking after myself a bit better. I need to get back into fitness and try and look after my health and what I eat. So a friend of mine strongly suggested that I try the gym. Now, there's a couple of problems with the gym. That's because it can be quite intimidating. When you walk in and you see all of the heavy equipment and some of the things that people are doing, it can just be daunting. So I decided to go back to things that I actually enjoy, which is sport. 2 sports in particular, rather, namely football and soccer. And no, I don't mean it like this. I mean it more like this, because I seem to be really, really prone to injuries. I play 2 sports, one where the players are known for faking their injuries, and the other way the riders are really known for trying to avoid their injuries and getting back onto their horse. So take a wild guess as to which one of these 2 sports ended up or resulted in me having this knee brace on my knee for over 3 months. It's soccer. I had a minor incident and I ended up damaging my knee. Now, something interesting started happening after this injury. I started being very, very grumpy. My friends said it was just old age creeping in, but I realized that something else was happening. I was starting to experience the world like never before. I was experiencing it as someone who couldn't walk as long as I normally do, and I realized that I was actually experiencing a temporary disability, and that this was making inaccessible designs around me much clearer. And all of those things were now starting to affect and frustrate me. And the first thing that really, really, really made me angry was the shopping mall. I live about a block away from one, and I've always thought that it had parking all around it and it was a great experience to go to. I hated it because when people think accessibility, all they think about is ramps. And I found these ramps everywhere. Now, I don't know if you've ever tried, but walking with crutches on a ramp is really, really difficult. And I struggled a lot. I was so furious, and I did what every normal person would do: try and figure out whose responsibility is it. And now that I was faced with my own physical limitations and trying to figure out who to blame, it dawned on me. I started reflecting about whose responsibility it is to ensure that the solutions we build are as accessible to as many people as possible. And to answer this, I think we just need a quick, common working definition of what we mean by accessibility. Well, firstly, A11Y is a numeronym where the 11 stands for, it represents the 11 letters in the word accessibility. And the major dictionaries really gravitate towards this general definition where they define accessibility to being the quality of being easily reached, entered, or used by people who have a disability. If we bring our focus much closer to home, we see that web accessibility means that websites, tools, and technologies are designed and developed so that people with disabilities can use them. More specifically, that they follow the PAW principles, which means that people can perceive them, understand, navigate, and interact with the web that we build. So to simply answer the question, the answer is that it's everyone's responsibility. Everyone that is involved in the software development lifecycle. We have long agreed that it works on my machine is simply not enough. So I've always wondered why we're so comfortable with shipping solutions that work for some people and not necessarily others. And every time I've been engaged in conversations around accessibility, it's often treated as a nice to have. But what we don't realize is that it actually affects the bottom line. Inaccessibility costs businesses significant amounts of money. And I mean, we're also seeing it becoming a legal requirement all over the world. So the W3C has put together something they called the Web Content Accessibility Guidelines, or WCAG for short. Now, this is a set of technical guidelines that are aimed at making web content more accessible to people with disabilities. It effectively has 13 guidelines as of 2.1, and the guidelines fall under 4 core principles, meaning that they are aimed at making sure that things are perceivable, operable, understandable, and of course, robust. Having guidelines and principles is one thing. We also need to be able to measure the success. We need to be able to describe just how well we conform to these guidelines. And for this, we've got really, really simple 3 levels of conformance, namely A, AA, and AAA, which range from simple and very common things such as missing alternative text, keyboard accessibility, all the way to the other end of the complex spectrum, where those issues are more concerned about the content and comprehension of our users. The interesting thing is that if you take a look at some of the most common challenges, they're often the easiest to fix. So things like the lack of alternative text, inaccessible forms, and things like poor color contrast can actually be looked at quite programmatically. Even the lack of keyboard accessibility is still one of the most common accessibility issues that are found on the web. And I mean, we've long seen that keyboard shortcuts or the use of those shortcuts can improve productivity quite significantly. I recently had a conversation with one of my senior colleagues, and he told me about how we once had a client, and part of our service offering was that we guaranteed this public service client that we would be able to have someone test the solution to make sure that it's accessible. He told me a story about how, because they had this one person who was blind, use the system, a lot of the time when it failed, the client would actually be quite upset about the amount of time that we were adding to the process. And I realized something crucial about what he said. For such a massive software solution, they had a single person and just said to them, tell us if you can use this. They often released a lot of these solutions without passing quality assurance measures because they were chasing deadlines. I then realized that we actually need to equip people that are involved with the tools that are there with the tools that can educate them rather, or of what needs to be done and how to go about implementing these things. But where do we even start with this? I'm a practical person, so I don't believe in simply sending people off to a training session or a workshop. I think we need to do more, and it needs to be in practice. And for this, practicality is key. So I started digging around for a couple of solutions, and effectively, this mission was to find accessibility testing tools for everyone that I work with. I'll start off with some of my favorite people as a developer. QA engineers, test analysts, they come in many forms, shape, and names, but we all know that they are a developer's worst nightmare. Now, when I talk about QA engineers, I'm talking about manual testers, for instance. What I found is that there's something called the Web Accessibility Evaluation Tool List. I absolutely love this website because on the left-hand pane, it also gives you an ability to filter as to what type of tools they are based on either the guidelines that you want to follow, the legal requirement, or the type of accessibility concern that you're trying to address. Now, this tools list has more than 100 tools because we are still in the web and we get a tool every minute, but the filters are really awesome. So effectively, the rest of this talk is going to be me telling you about a list of some of my favorite accessibility testing tools. But to do this, we need a website. Now, I thought of using the React US website, but then I realized that I really want them to invite me back to this conference next time. So I found this test website. It's called the Medical Mysteries Club. It's built by the Chrome DevTools team, and they built it with a disclaimer saying that this page was deliberately made inaccessible for purposes of the demo, which is quite cool. You can check out the site. There's a code pen for it, and here I'm running it in debug mode. Speaking of the Chrome team, my first tool is Lighthouse. Lighthouse is a really, really great tool, and it comes shipped with our Chrome browser. And this tool is quite common. You simply need to do a click analyze test in your DevTools, and it should be able to give you a good breakdown of some of the accessibility issues. Now, Lighthouse is often used for other things as well, such as SEO and performance. And so I won't dive into it a lot because I understand that a lot of people would have seen it. I'll show you similar tools instead. The first one is called WAVE, which stands for the Web Accessibility Evaluation Tool. Now, this is a browser extension, and once you've added it, it actually annotates the screen that you have in front of you. So it will put all of these tiny icons to actually show you what these issues are. What I like about this is that when you go into detail about what actually is wrong in there, it's able to show you things like such as the low color contrast and even help you figure out what color is best at that point. Another tool that's quite similar to Lighthouse is called XDevTools. Now, XDevTools also is added in your developer tools as a tab. And you also just click analyze, and it will give you a breakdown of all of the issues that are there. One thing to note, though, is that this is paid. And by the time I started building up this talk, I had already run out of my trials license. The important thing for me here is that I wanted something that I can use for everyone that I work with. And so I looked around and I found something for the project managers. When you're managing a project, you're not necessarily interested in the very minute details, but rather overviews of things that are happening. For this, I found one of my favorite tools called Peli, your automated accessibility testing pal. Now, Peli is an open source tool. It helps developers and testers identify these accessibility issues on web pages and applications. It can be found on NPM, of course. And when we take a look at this, we see that it can run in the command line or can be used in your own solution in a Node application. What that looks like is that you would simply import it and you would provide it with the URL. It would go and crawl that web page and return those results to you. And you can then do as you wish. So here, if we go and replace our testing website with the code pen for the Medical Mysteries Club, we see that if we go and print out those results, this is what they start looking like. And what I like about this is that it tells you which principle or which WCAG guideline you are violating. It's able to show you a human readable message. It gives you the context of where the issue actually came from and even the HTML selector. Now, this is really, really interesting. And I realized that I'm onto something here. But I'm a web developer. As soon as I start thinking that I'm building something very useful, I know that I need to stop because chances are someone else has probably built something similar to me. And for this, I found Peli Dashboard. Now, this Peli Dashboard, you can configure the URLs that you want to go and take a look at so that you can see your transitions over time. This is absolutely great if you are making an already existing application more accessible because you can track your progress and the progress of your team over time. But of course, if the only time you identify accessibility issues is in production, then it's really, really too late. you generally want to intercept these problems at the developer level. You want to guide your developers to solve these problems while they are building. But how do we do this? Well, we automate this. We automate the testing portion of this. And of course, developers are new to testing. We all write code that we've tested thoroughly. As a developer myself, it's not that I don't trust the engineers that work on my project, but rather because I'm an engineer, I know that sometimes you just happen to forget to build and run your tests. So I've learned that the best way to get developers to conform to these standards is to simply block pull requests if the right thing isn't in there. So effectively, we need to automate this accessibility testing and then blocks the pull request if they fail. So if your work cycle looks something like this, where you make some code changes, you push them to some sort of server, and you create a request to merge changes into your main branch, and then you merge them. What this would mean is that we would have to insert one more step to simply check if the component you've added or the code you've added is accessible. What that looks like is quite similar to the manual portion, is that we would need to start up a server, launch a browser, go to localhost. I have no idea why that's a chicken in there. We'd have to wait for it to load. And then once it's loaded, we would then have to run our Peli tool. So to do this, because now this needs to happen in the command line, I found Peli CI, which is an accessibility test runner that's built with Peli under the hood. But this one is particularly focused on running in continuous integration environments. This is particularly important because we don't just want to get results of what's broken. We also want to break the build itself so that we don't allow it to be merged. So putting this into action, I chose to go with GitHub Actions because that is probably one of the most commonly used CI/CD pipelines. And GitHub Action automates tasks in the development workflow, which means that we can customize how we do this thing. So everything that I've just described, we have to put into our CI pipeline configuration. But now if we talk about testing, a typical testing setup would look like this. You would need a test runner. Examples of this are Mocha and Jasmine. You need an assertion library, which defines your testing logic. So this says, I expect A to come out as B under these conditions. And then because we're talking about things that actually need to be rendered, we also need a browser. Now, one of my favorite tools, because I use it on all sorts of projects, is Jest. Jest sits right across those two. It's both a test runner and an assertion library, and they describe it as being a delightful JavaScript testing framework that focuses on simplicity. What that looks like is that if you have a function called sum, you would simply write a test that says, we expect the sum of these things to be 2 or to be this result. And if it fails, as you see here, I said I expect the sum of 1 and 2 to be 6, which we know it's incorrect. This is what the error would look like. And it tells you that one of your tests fails, which means that you can block the build using this. I then realized that we can actually use Jest with something called JestX. So X is the core, is another core rules engine that helps you figure out accessibility issues. And once we start using it like this, we're able to replace that function with a render of a simple component that we want to test, because we cannot always be testing entire pages. Sometimes we want to test a small component of what it is that we're building. And we see that once we pass it in there and we ask the JestX runner to test it for us, it's able to tell us which rules we've violated. But if you take a look at this one, it says that all page content should be contained by landmarks. This is great and true for full pages, but not necessarily always the case in smaller components that will always exist in bigger pages, which means that we need a way to configure these things, which is really, really great. So you'll see that it also tells you what to fix, and it gives you a link to DQ University's guidelines as to how this actually works. To configure it, it's nice and simple. We can enable the different rules for isolated components or for our different test cases, because we know that we can never just have one solution for everyone. But again, this is a guideline, or this is a guard that we put when developers are building. What we really want to do is get even closer to the developer and help them and help guide them and coach them while they're actually working. For this, there's the X Accessibility Center. It provides tooltips on why issues are being marked, why they're considered to be issues, and even how to go and fix them. To go one step further at annoying my team, I also came across Husky, which is a beautiful Git hook that allows you to run these tests on commit. So not only are we stopping developers from merging, but if I really want to annoy the team, I would configure this to stop their commits so that they don't even commit anything until they make sure that it's accessible. What it looks like is that once you try to commit, it would tell you that there's a problem here, and this is why things are failing. Now, we've discussed quite a bit. We've spoken about tools that we can use for monitoring, and we used Peli with Node. We did this to build a dashboard until we found that Peli had its own dashboard. We looked at some manual-ish testing tools, such as Lighthouse, Xtools, and Wave. And then we started looking at the automated testing portion of it, where we are able to use Peli CI as a gatekeeper for our main branches. We looked at how we could use JustX in order to run them locally and on a component level. We also then looked at Husky on how to use Git hooks to make sure that we can run those tests every time we do specific Git commands. But all of this so far excluded one very, very important portion of our team, which is the designers. They choose the colors more often than not, and a lot of their decisions have a big impact on accessibility. For this, they also have a number of tools that are built by the incredible DQ universities. They've got the same X engine that drives the tooling in that space as well. With this, it means that every single person that is involved in your software development lifecycles, be it the developers, the designers, the business analysts, everyone has the tools that speak the same language. But I'd be wrong if I didn't mention or caution everyone of this, and that's the fact that automated testing has its limitations. Only about 30 to 40% of accessibility issues can be picked up programmatically. I think DQ at the moment estimates over 67%, which shows that things are improving. It is prone to false negatives and false positives. And for me, the biggest thing is that it lacks context, which means that you need to be able to configure it yourself to make it valuable for your space. And of course, this has a big inability to test for user experience. So it does not replace that. I'll close off by quoting a modern philosopher, ChatGPT, who said, "It's important to remember that automated testing should be used in conjunction with manual testing and user testing in particular to ensure the highest level of accessibility." I'll leave you with that. My name is summit-qna. Thank you very much. Please feel free to let me know what you think of this talk. Thank you. Goodbye.
Thank you for that amazing talk, and don't forget to address your questions to our speaker on Discord. Okay, so remember earlier on I talked to you guys about photos. Well, I'm here to ask you again. Please take a photo of how, where, and what device you're joining the conference with. After you take your picture, go ahead and tweet it or post it on LinkedIn with the hashtag #ReactSummitUS, and we'll be looking out for your tweets and your posts. We'll have a raffle of multi-passes to Git Nation conferences and t-shirts, so you don't want to miss out on that. And just use the hashtag like crazy. We just want to see what your experience is like. And now let's go ahead and talk about our gold sponsor, Focus Reactive. Focus Reactive is a Next.js headless CMS and e-commerce expert agency. They partner with Vercel, Shopify, Storyblog, and Sanity.io to deliver quality software with a focus on scalability, performance, and a great user experience. Let's go ahead and introduce our next speaker, Karen, who's going to be talking to us about measuring coverage of React design systems. Karen is working as an SDE2 at Fabric, currently dabbling with design systems, micro front-end, and front-end infrastructure. Karen, the stage is yours.
Hello everyone, my name is Karan. Uh, Welcome all to the React Summit. Today I'm going to talk about measuring coverage of design system. To give you an introduction about myself, I'm currently working as a ST2 front-end at Fabric Inc., which is a US-based e-commerce startup. I have previously worked with startups like Razorpay and Deliveroo Foods in India. So let's some context before defining the problem statement. I'll talk about what I usually deal with at Fabric in my day-to-day work. So we have our own dashboard, SaaS dashboard, where retailers can manage their products, inventories, customers, coupon, subscription. So it's a micro front-end based architecture. We use single spa, React, TypeScript, and style components. So we were in a journey of building uh, our design system in TypeScript, which was design system 4.0. We had our older design system, which was in DS3. It was built using JavaScript. It was like very flexible kind of a not a design system but a component library or a UI kit. Like it was very flexible, so people ended up creating a lot of customization and lot of variations of the same component in turn, which lacked consistency across our applications. So all our applications started to look like it belonged to a different platform altogether. To resolve all the issues that we had with design system 3.0, we decided to build a design system 4.0 using TypeScript. Uh, it was flexible, but it had design constant uh, with respect to our design system. It's very consistent. It has all the support, all the latest uh, features like tokens, spacing, color, theme that you can use. Let's define the problem statement where we in the journey of migrating from design system 3.0 to design system 4.0. We as a platform team wanted to measure our component usage and to get some data to take data-driven decisions around our component strategies. So a few data points that we wanted to capture was design system 3.0 usage, design system 4.0 usage, any native HTML elements that the domain teams were using, any style components they were using built on top of native HTML elements, or any existing design system 3.0 components. We also wanted to have a tree structure of any page or any layout so we can visualize how our different components are getting used in combination with other components. And we also wanted to highlight some anti-patterns that we can like gather using the data. So let's get started. So first thing first, if you are an engineer, you get assigned any task, you try to Google the hell out of it. You see if there are any existing solutions are there that you can use readily. But if you are a Gen Z developer, you would go to ChatGPT, type your question, and hope it produces the output. But it didn't. But after struggling for a few days, asking for people help on Twitter, various platforms, I was able to find this NPM package called React Scanner. Uh, so what is React Scanner? So React Scanner is basically a tool which statically analyzes your given code and it extracts the React component and prop usage. So React Scanner supports following options that you can give. So basically, when you run this React Scanner on a given code base, you have few options. So first one is root directory. You can define from where your root directory is. So it will start uh, uh, scanning from that root directory. You can also define where you want to start crawling from. You can exclude any of the files that you don't want to run a scan on. You can define the glob pattern as well to include specific or exclude specific files. You can also include subcomponents. Like if you don't want to report all the components, then you can also define using components. Similarly for subcomponents as well. If you want to generate the data for only specific libraries, say you want to get the information from a library, like let's say what all components you're using from Material AI, then you can define your particular libraries as well. So it will generate only the data for that particular library that you find. Also, there are some custom functions that you can pass on. So a few of them are like get component name, get prop value, and processors. So processors are basically functions that runs on top of raw data, and it will generate uh, consolidated information for you. So let's talk about some of the processors that are provided by React Scanner. So as the name suggests, first one is count components. So basically, it will give you the only the count of component, like all the components that are getting used in the particular code base. Next one is count component and props. So basically, it will count component as well the number of like the count of props as well. So here you can see text components. It was identified 17 times, and in that 17 instances, the margin prop was used 6 times, color 4 times, and text style 1 time. So on and so forth. So the base processor is a raw report. Basically, it will generate the raw information of your report, of your all the instances of text or all the components basically. So here you can see the text instance. It's instances array. It will have the information like the first object is the props object. Another is location. So where your particular particular component was identified, and it will have the prop spread information as well. If you are doing prop spread syntax, then it will give you that information as well. So this is the raw report format. So how does React Scanner work? So basically, it reads your file and then passes your code into abstract syntax tree, AST. Then it traverses the AST, gathers the information like component name, import information that we saw, prop information. Then based on the processor that you passed in the configuration, it will generate the data and it will return the JSON. So you can write it in a separate file or you can take it as output as well. So let's talk a little bit about AST. I am no expert in AST. This was my first encounter with AST, but it's a cool tool to learn a few things about your code. So basically, tree representation of your program source code is what AST is. So I have taken a very minimal or a basic example here. You can see I have declared two variables a and b, 45, 5, and I have one function declaration which returns a plus t. So on the right hand side, I have created a AST. You can see here, this has three nodes, like we have three statements, variable declaration, couple of variable declaration, and one function declaration. Here you can see. And in function declaration, we have block statement on this brackets, and then we have a print statement and this operator and to its argument 2. So this is basic AST. If you want to learn more about AST, I would strongly suggest you to go to astexplorer.net and explore it. It can generate the AST for the code in any of the languages, and it will give you a nice view and you can learn a thing or two about ASTs. So let's say React Scanner in action. So using React Scanner, we were able to display this kind of information about DS3 and DS4 component usage. Here you can see in DS3, we had these many components and its usage like tooltip, icon, modal, and in DS4 like grid, row, skylight, and box icon. And in the pie chart, we are showing the status of DS3 component versus DS4 usage in this particular project called Copilot MFA Admin. We still needed to figure out few things like native HTML elements, style components, component tree structure, and anti-patterns. So let's see how we can do each one of them. So first thing first, all of this like were not supported using React Scanner. So we forked the React Scanner repo because it's not actively maintained anymore and it did not have all the use cases that we wanted to solve for. So we are now maintaining a copy of React Scanner at Fabric. And let's start talking about HTML elements, how they differ from JSX elements. So there are two unique features or two unique differences between a JSX element and HTML elements. Is that native element HTML element is always lowercase, and it doesn't contain any dots. So dot syntax is generally used for subcomponents, and lower like the capitalized letters are used for JSX elements. So using this information, using this filter, we were able to show all the HTML elements that the domain teams were using, and in which particular file also they were using. We were able to show that on the dashboard, as you can see here in the snapshot. So let's talk about style components. So style components is basically your CSS in JS solutions. You might have seen the syntax if you have used it before, but if not, I'll briefly talk about that as well. So you may have used this tag template literal syntax. We generally use this when defining our styles in conjunction with style components. So here you can see there are two ways you can define your style component. One is a normal dot notation, style dot button, where I have defined base button using that syntax, and a primary button using a function called syntax style, and in brackets I am defining base component. So let's talk about the style components using how it looks like in AST. So let's go to the first one. You can see here in the dot notation, it's getting the identifier, and in the tag template expression, you can see there is a tag and there is a quasi and template element. You can see here all the values like that background grid and everything that you have defined here in the syntax. We can see here, and you can see the where it was derived from, like what's its expression name, and we will be able to see like it was built on top of button. And for similarly for the style base component, you can see it here that we have this call expression because we are calling the function style, and in here we'll have the argument called base button. You can see the value here, base button. So we can identify using that information that this primary button was built on top of base button. So this was the code that I wrote. So I'm gathering all the information where it was styled from using property name and the raw value as well. So after gathering the information, we were able to identify some anti-patterns. So let's talk about anti-patterns. So anti-pattern is a term that describes how you should not be solving your recurring problems. So what could be some of the anti-patterns in our use case is that using a hard-coded color instead of using a design system token, or like using HTML elements like anchor and input button instead of using it from the design system. So we wanted to highlight that in our dashboard so the teams can like take corrective actions. So here is the dashboard. You can see here we have identified few of the anti-patterns, and we have given the suggestion as well as the source of it, where it arose from, where the user was like following these anti-patterns. And we also we are also showing the color like style component as well. So the last thing I wanted to talk about is component tree structure. So we wanted to like create a component tree structure for any page or any component, so we can visualize how our components are used alongside other components or with each other. So then visually we can see how they are arranged and how we can optimize them further, or we can take any major decisions with that. So let's take a sample example. So here I have a user management form from our one of the microfinance applications. So this user management form has two components. You can see one is user form and another is the user listing table. So here you can see this user form has 3 input and 1 drop down and 1 button as well. And this form has like all the rows, and each one of them can take action like change the role of the user. So let's talk about that. Here you can see this tree, like it gives us the information, this manage users page is built using buttons, 3 snack bars actually, button with icon, this user form, and this user list. So here you can see we can identify one anti-pattern here on the first glance is that we are using 3 instances of snack bar that we shouldn't be using on this page, because we can do the same thing with one snack bar as well. Here the user form is built using different components, so that's why it's cleared out. You can expand it further. It's not edge node. So you can see that user form is built of drop down input, and button with icon button actually. So you can see your whole page in a single view, what all components it's getting used. So it's a bare bone version that I built, but we are planning to add more features into it, like searching for particular component and like displaying them with different colors from where they belongs to or where they are imported from, and also the props information. If we can highlight that, it would be a great tool to have. So in summary, like we were able to like get the overall idea of how our design system was getting consumed. Using the data that we generated, we were able to take major what like the data driven decisions around what all props should be make backward compatible, what all props we can deprecate, what all components should be combined, or like what all component we should do atomically also. All these kinds of decisions we were able to take using data, and we were also able to highlight the anti-patterns and improve the code quality. Yeah, I have one bonus for you all guys. So it's a tool that I have found recently, which is omelette.dev, which does the same thing that React-qna does, but it's a all-in-one solution, so that you can use. It's a component analytic tool, which was developed by Zeppelin. So here is the simple demo of Omelette. You can see here it has the CLI tool that you can use, and it has a dashboard where you can see all your data once you run your scan on. So it's much more advanced than what we have built, and it supports React and React Native, and it plans to add in future they are planning to add Angular and Vue as well. So thank you. So here are the references that you can use if you want to learn more about that. And here are my socials if you want to connect. Thank you guys, and thank you to the team behind React Summit for giving me the chance to speak at this conference. Thank you guys.
Thank you for that amazing talk. Don't forget to address your question to our speaker on Discord. Next in our program is another break and another discussion room, TypeScript this time. These amazing speakers and more will be there with you. The location is still the same. Head over to Spatial Chat, just click the button on the timeline and join in on the conversation. All right, so time to go ahead and grab your break. Get back to us with a lot more energies, and don't forget to tweet and post your pictures in the meantime.
AG Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Next up, I'm going to introduce you to another one of our gold sponsors, GraphBase. GraphBase provides a real-time API with data positioned close to users, ensuring swift performance and minimal latency. Now let's go ahead and introduce Brian, who's going to be talking to us about taming the state management dragon. Brian is a staff front-end engineer at Patreon, longtime member of Node.js and Node-Bot communities, and a tech activist. Brian is the creator of Raspberry.io, which provides Raspberry Pi support for Johnny 5 JavaScript robotics library. Brian also created RVL, a distributed wireless LED system designed for festivals. Reduxology, a library that makes React and Redux easier to use, and Aquarium Control, a Raspberry Pi-based system for controlling lights and monitoring the temperature of his aquarium. Outside of tech, Brian is an active member of the LGBTQ community, a photographer, pianist, and a wine aficionado. All right, let's go ahead and head over to our Summit Q&A channel and leave some congratulations and ask questions as well. Brian will be there to reply to all of them. Brian, the stage is yours.
Hi everyone, my name is Brian Hughes and I am a staff front-end engineer at Patreon. At Patreon, I'm on a team called Front-End Platform, and our team is tasked with managing basically all of the foundations for our front-end code base. And this includes architecture and state management. And today I want to talk about some things I've learned over the years of how to build successful state management solutions inside of applications. Because I think this is a really critical part to having a successful front-end code base. It's also one that tends to be underinvested in. Let's start off with the definition. What is state? So I define state as data and all of its related mechanisms. Right? We know that intrinsically, I think that state isn't just data, right? Data is just a blob of, well, data. It's how are we accessing that data? How are we reading that data? How are we updating it? How are we synchronizing it? So state is really its data and all of those mechanisms associated with it. But mechanisms are more than just libraries. I think a lot of times when we think of state, we're like, well, we've got this API schema coming from our backend. It tells us what data we have. And we picked a state management library, Redux, Recoil, Jotai, whatever. And that's it, right? But that's not it. Those are really important parts. The way I like to think of it is that our API schema, what data the backend returns, and the libraries that we use to access this data, that's like the foundation of a house. It's really critical, of course, it's the foundation, but we also need walls and a roof and things like that too. And a real state management solution in a front-end application, especially any reasonably complex application, is we got to think about this holistically. We got to think about the entire house. And so whenever I'm going through and I'm designing a state management solution, either if it's for a whole new application, rewriting an old one, or even if it's just adding a new page to an already existing system, there's a handful of questions that I really like to ask myself. And we only have so much time today, so I'm just going to stick to two of the really important ones, or at least that I think are important, and I also think aren't talked about as much as I wish they were. So the first question is, when is state created? If we think about a front-end application, it's not a snapshot in time, right? It exists over time and it changes and reacts to user input, right? And so when is the state coming into being? Understanding that really informs, what kind of a testing strategy do we need for it? What kinds of safeguards do we need for accessing, and just all sorts of things. And it really depends on the answer to this question. And I think there are roughly three categories of state when it comes to this, temporal nature. The first category is state that is created before startup, otherwise known as bootstrap data. And we think about this, we'll take, for example, a social media site. We'll use that as an example through this talk. On a social media site, we load the page. The first thing we do is we see a bunch of posts, right? That is something that exists before, we can even begin interacting. And so this happens, or at least one way it can be done is we can do this as part of bootstrap data in a modern server-side rendering type setup, say with Next.js. And in this world, the idea is that we assemble all of the data needed to do that first render. We call our backend, usually multiple backend API endpoints. We might do some hydration, massaging of data. We assemble it all together, and only then, once we're done doing that, do we start the application and do that first render. And so there's a couple of gotchas to be aware of with this. And, like I mentioned, this data creation and then data consumption, they're pretty decoupled, right? The way that data looks, inside of, for example, in Next.js, inside of that get server-side props function, the way we work with it, the way it looks and everything is usually different than whenever we're reading it from, say, inside of Redux or something like that. So we just need to keep in mind that these are decoupled, and thus we need to actually think about keeping them in sync. Now, it's actually not that complicated to do in practice. Usually TypeScript is a great solution to this, but it is still something that we have to think about, and thus we also have to maintain. Another bit of a gotcha with this is this data goes through a couple steps. It kind of gets funneled along. Like I said, we start off calling multiple endpoints to fetch different, oftentimes unrelated bits of data. We're fetching who is the current user, what is the list of most recent posts, what are the current trending topics, things like that. And we take all the disparate data and we kind of squeeze it together into one ball. And we pass it along through a couple of different places. It goes into our top level component. We pass it off to our libraries to Redux, say, whenever we're initializing our store, only then to sort of break it apart and access it later. And again, this isn't particularly complicated to implement, but it is code. And anytime we implement, we have to write code to do a thing. No matter how simple that code is, it is still code that has to be maintained, and it is still code that can have a bug in it, and thus it comes with a cost. So the next type of data is lazily loaded data, which I kind of think of as deferred bootstrap data. Right, so this is data that isn't present for the initial rendering of the app, but is still necessary in order to even begin to show some bit of UI. And the way I like to think about this is if we lived in a perfect world where servers had infinite memory, database queries always took 0 milliseconds, stuff transferred over the internet also in 0 milliseconds, no lag, none of that. Lazily loaded data is data that would actually be bootstrap data. Right? In our social media example, we on that homepage, on that feed, we would load every single post for the feed for all time, all at once, right? And we just render that at the start. Of course, in practice, we can't do that. That is way too much data, especially if it's not going to be seen. So instead, we'll load a chunk at a time. The user will scroll some, then we'll load a chunk more and a chunk more. So this is really interesting in that conceptually, it really, though, is exactly the same as bootstrap data in that this is data that's needed to even begin showing the UI to the user. But mechanically, they look completely different. As a result, the gotchas are different too. And so in this, components need some extra intelligence, right? In the bootstrap world, component gets the data, it renders the data, it's done. But now components need to know well, what kind of state are we in? It's are we in the process of loading, and thus we need to show, a spinner or a ghost component or something like that. Does this component also need to be the one to kick off the request? Does it need to manage that request? So all of a sudden, these components have to do a lot more work. And also, as lazily loaded stuff isn't run in server-side rendering, kind of by definition. And this has potential SEO implications as well, right? If SEO needs to have that lazily loaded data in order to understand the sites so that you get, or the web crawlers understand that, so that we can get proper search engine optimization. Well, now all of a sudden we have to write special code to handle this SEO case. And again, this code may be simple, but simple code is still code that has to be maintained, that can have bugs and go wrong, right? So there's still a cost to it. And the last bit of data is what I call reactive data. And this isn't data that is needed to show the UI. This is state that is in response to a user interacting with the website. So I think in the social media example, the best case of this is composing a new post, right? We hit a button, it usually pops open an editor, and we have to maintain a whole bunch of state around that, right? We have to maintain, what is the user type? Well, there's no way we can know this in advance, right? The only thing we can do is wait for the user to tell us the bits about it, right? We don't have a time machine after all. And so again, the gotchas look pretty different. This is where we start to get into state synchronization a lot more. And this is where this can become a real challenge, especially with the way modern posts look, which have all kinds of rich content in them, right? We can attach files. And when we attach a file, we have to usually start uploading it to the server in the background. We can @mention people. And so you would type start typing a few letters, and we'll get an auto-completion. And that involves multiple round trips to the server. Same thing if we want to add tags or anything else to it. So we get all of these kind of interactions with the server that have latency, and they can even stack on top of each other. And so we have to write our code in such a way that it can handle all these various different combinations. And so once we get here, that testing surface becomes much, much larger. Because with lazily loaded and with bootstrap data, there's pretty much just one option. I mean, you might have a couple of variants of data, but they don't really interact with each other. Whereas in this role, we have to think, what are all the, not just test, what are the basic things, but what are all the possible combinations that can occur at once? All right, so this gets quite a bit more complicated. But it's really interesting to look back on these types because they all have similarities and differences too. Conceptually speaking, lazily loaded and bootstrap data are the same thing, and reactive data is really different. Mechanically speaking, lazily loaded data and reactive data are really similar, and bootstrap data is different. So it's like they all have similarities and they all have differences. And I think that's why it's really important when we're defining state to really identify what type of data we're working with, which of these three it is. So the next question I like to ask myself is, where is state used? We started with when, and now we're on to where. And another way of putting this is, what is the scope of state? So first, let's talk about locality of data. This is kind of the phrasing I like to use with it. I think we all know the concept of like local data and global data. We use this all the time. I think there's a third type here I call regional. Just put a pin in that though. We're going to talk about local and global first. So local state, this is state that only one component needs to know about. Like it doesn't make sense for the rest of the application to know. For example, in our post editor, as we are typing values in, it doesn't make any sense for the navigation bar or the list of trending topics or anything else to know about the current state of what the user has typed, right? That is really just local, just that one component needs it. On the flip side, we have global data. I think the most common global and the best example of this is who is the current user. And it's possible that value is null if no one is logged in, but that is still data. And this is something that everywhere across the site needs to know about it. The navigation bar needs to know it to show the user avatar with like a logout option. A reply editor needs to know this as well because we usually show that avatar there. Settings page needs to know about this some too. Right, so this is data that really needs to be accessed everywhere. And so when we're designing global data, we kind of have to think about it a little differently because it's no longer coupled. So we have to support all these possible different use cases, right? But there was a third type, and I had to come up with my own term for this. I call this regional data, mostly because I just don't see people talking about this. But maybe there's a better term out there for it. But regional data sits, as the name implies, somewhere in between. This is data that doesn't actually make sense for all of the app, perhaps even doesn't make sense for the majority of the app. But it doesn't make sense for just one component either. And I see this most in the modern world of applications where we're not really a single page app ecosystem anymore. Like this isn't what Next.js and React Server Components and all of those mechanisms are. They're kind of multi-page apps, but they also kind of look like single page apps, right? So we can have some state. For example, that list of posts, that makes a lot of sense on the home page. But that doesn't make any sense if we're viewing the profile for a specific user. It especially doesn't make sense if we're on the settings page, right? So this is state that really is scoped to just the home page, but it's broad enough that it's not just scoped to like a single component. And this is where I actually see most of the issues crop up around state management is what do we do with this regional data? Right, the common answer, especially in the Redux world, which really, really likes global data, is to just have all the possible pieces of data on all pages and just set them to null if we're not on that page. But I never found that a very convincing solution. All right, but I talked about locality of data, right? And I use that word on purpose because if we go back to our definition of state, state is data plus mechanism. And it turns out we actually have the same taxonomy for mechanisms too. And the concept is the same. Local is where the mechanism is only accessible by a single component. Global means anyone can access the mechanism. Regional means only a subset of the code base can access that mechanism. And so for the first question, I didn't really talk much about specific libraries because in truth, all the various libraries out there support those different use cases. But once we start talking about locality, that's where things change a bit. This is where we actually start to see where different libraries are really kind of meant for different types of locality. So let's dive into some examples to really kind of understand more what I'm talking about. We're going to start off with useState and useRef. These are built into React. I think everyone knows them, certainly useState especially. And this is used explicitly for local data. In fact, the thing about useState is I got this whole idea for data plus mechanism from useState itself, because that's what it is. useState returns an array with 2 items in it. That first item is the data. The second item is the mechanism for updating that data, right? So it's like that this dichotomy is embedded there. But it's purely local in nature. So if you think about it, this is return. It lives inside of a component. These aren't global variables. They just exist inside of that one component. There's no way for a completely different component to import that variable or something, right? It's just not how JavaScript works. So it's really just for local data. And then on the opposite end, we have Redux and ZooStand. Both of these embody what's called the Flux architecture, and both of them have the concept of a single global store for all of our data. And it really is. Both the data and the mechanisms are truly global. If we want access to that data, we import the uStore hook from Redux, and all of a sudden we can access every single piece of global data in that one store. And there really is typically just one store. Almost always, in fact. So this is like the epitome of global data. Now, so far with these two options, we have seen a one-to-one relationship between the data and the mechanism. And so it might be tempting to think that they always are one-to-one, but it turns out not always. And so the next 2 libraries I'm going to talk about, we actually finally start to see this break apart, and that is Recoil and Jotai. So these 2 libraries are much newer in the state management world. So if you're not familiar with them, just real quick, what they do is they said, this whole single global store idea that Redux and ZooStand use, maybe that's actually not the best way to do it. So instead of having a single global store, we're going to create just a bunch of basically micro stores, and they call these things atoms. And so a single atom is responsible for basically a single piece of state. So for example, there would be a current user atom, right? And that's all that's there. And there could be a completely separate atom or set of atoms for all of the posts in the home feed, and then yet again a separate set of atoms for the list of trending topics, and so on and so forth. And in practice, there is often quite a bit more than that. And so each of these atoms is only responsible for that one piece of state and nothing else. And so this is where we start to, okay, so let's get back to locality now, right? With that in mind, this is where things get, I think, very interesting. This is why personally I'm a really big fan of these. I've been using Jotai lately, and I'm really enjoying it. Because with this, we can construct our code such that, let's say we have a file with a component in it, and it needs access to some data that's not local to that component. It exists across all components, right? There are use cases for this. Well, we can create an atom to maintain that state, and we can stick it in that same file as the component and then never export it. So what that means is in practice, all of a sudden, we have this atom that can only be accessed by one component, which is to say, we can actually have a local mechanism for accessing this data with Jotai, which is something we can't do with Redux. Now, we still don't get local data because that data, again, is shared across all components, but it is a local mechanism, which is really interesting. This is also the first time we start to see the appearance of anything starting to get close to regional data. Another thing that I think is just very clever with Recoil and Jotai is, we have these atoms, not only do they hold state, they also have, business logic for how we interact with it. We can have, side effects and all sorts of other stuff. We can make network calls related to it. So we can have all of this logic. We have these mechanisms here for working with certain types of state. And if there is, say, a page and no component on that page imports that atom, that code doesn't even show up in the bundle. It's not there at all. So if we have an atom to maintain, say, 2-factor authentication information, right? This exists on the settings page. The homepage never imports it. That code, that's not even in the bundle. It's never even shipped to the client. So we actually have what kind of looks like a regional mechanism. Now, I say this is only a regional-ish mechanism because there's no enforcement of this. There was nothing stopping a component on the homepage from importing that 2FA atom, right? Which is kind of what we really want to have. But still, it kind of gets us there. It's at least closer, right? Which I think makes it really compelling. And of course, these can also be used for global data. You can have, again, a current user atom. Everyone imports it everywhere. It just works. So this kind of begs the question is okay, so we've talked about different stuff. We've seen good examples of local. We've seen good examples of global. These are starting to get into regional, but not really. So the question is, can anything actually even do regional data, especially since, again, it's not really talked about? Turns out, yes. And that is React Context. So React Context itself is used to power all those libraries I just talked about. They sit under the hood of Recoil, Jotai, Redux, ZooStand, and a bunch of others. But the thing about React context that those libraries don't really exercise that I find so compelling is you can have as many React contexts as you want, and you can stick them anywhere in your component tree. And so what that means is for that two-factor authentication data, we could always put that inside of a React context, and we only initialize that context at a component for the settings page, right? That's not used anywhere else, sort of like a page wrapper where we start this up. So when that happens, that means you have to be inside of that component tree in order to access this context. It's just built in. If you try to access that context from outside that component tree, you get an exception. So that means we can now create regional data by scoping it to our component tree, which is really cool. Now, the mechanism is still only regional-ish for the exact same reason as recoil and Jotai, right? There's nothing that stops us from importing it everywhere in the code. In fact, I'm actually going to go out maybe on a limb here. I'll let y'all decide. I don't think it's possible to have a regional mechanism in JavaScript today. And that just comes down to our module mechanisms themselves, like CommonJS and ESM. They don't have this concept of regionality. It's if something is exported, any code anywhere can import it. And there's just nothing we can do about it. Now we can do layers on top of it. I actually like to use linting to prevent this. At Patreon, we had to write a custom lint rule for this. We have a custom lint rule that says who's allowed to import what. And that kind of helps us to manage that. Now, there's another issue, though, with React context. Maybe not exactly an issue, but just something to be aware of, is it's a pretty low-level mechanism. Like, React contexts really weren't meant to be a very featureful state management solution. In fact, really, they were kind of invented to help support these other state management libraries. They're kind of meant to be built on top of. And so I think there's a real opportunity here to start exploring this regional state area. And in fact, I created a library to do exactly that. I just created it and released it as I'm recording this just a few days ago, in fact, and I call it React Strapped. Now, it is very limited and very special purpose. It is meant specifically for accessing regional bootstrap data. But still, it's been really interesting to play around with. So, I encourage folks to take a look at it. Whether you use it or not, I want you to think about like, what is it we're trying to do here? Because honestly, I think this regional state management concept is an area that is ripe for innovation. I'm really hoping that folks can start to invest more in better libraries, tools, patterns, even testing mechanisms, so that we can support that little bear, because it is a critical part of most modern web applications. So I want to end this talk with a little bit of advice to folks who are setting up state management systems. First is a bit of a mantra that we learned from a different platform team elsewhere, unfortunately I forget who, that is make it easy to do the right thing and hard to do the wrong thing. All right, if we can do that, this is how we really steer people onto the happy path, and we tend to get more reliable systems as a result. All right, so what do I mean by that? A good example of making it hard to do the wrong thing is a lint rule. Like when we have a lint rule in place that prevents something, it says, no, you're not allowed to do this, right? That makes it hard to do the wrong thing because there's like added friction to get around it. But it doesn't have anything to do with making it easy to do the right thing. It just says, don't do this. It doesn't say, do this, right? But an example of making it easy to do the right thing is a pattern I'm a big fan of for common bootstrap data. Let's say current user, so I'll create a hook for it. So at Patreon, we have a hook called use current user. It takes no arguments. So if you need to use a current user, you import the hook, you call it, and you got it. It is so brain dead simple to use this thing that there's almost no reason to use anything else. The next bit of advice I have is invest early and don't implement state systems ad hoc. Like I mentioned at the beginning, it seems most folks tend to think like, well, I've got my API schema, I got my library, I'm just gonna show them all of my data and not worry about it. And only later, once the problems arise, do people start to try to add a little more structure. So I encourage you to think about it early on. Think about all the stuff I've talked about in this talk and other questions, and have answers to that, have documentation around that. And finally, the most meta level of this talk, what I really want everyone to take away is set engineers up for success and not failure. That's what a good state management system does. And that's what good code does in general. Because truth be told, all the state management mechanisms I mentioned can be used for all types of state. Like we can use state and use ref for global data, but it's not going to be successful, right? It's not going to work well. We're going to have so many growing pains. So when we're thinking about these systems, think about how can we help our fellow engineers succeed? Because once we do that, that's when we create better systems, more reliable systems, and we can focus on features and making our users happy. And with that, I want to thank you all for listening.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. Next up, we're going to introduce Tony, who's going to be talking to us about authoring HTML in a JavaScript world. Tony is a best-selling Udemy and Pluralsight author, known for his online courses such as JavaScript, Understanding the Weird Parts, in which he focuses on teaching web and computer science fundamentals. He has spent 25 years as a web application developer, database architect, and UX designer, and continues to focus on creating a usable and accessible web. Tony, the stage is yours.
Hi, I'm Tony Alicea. This is Authoring HTML in a JavaScript World. Now, first, a little about me. You may find me teaching on Udemy, Pluralsight, Teachable, and YouTube, and I work with a company called the Smythe Group. Now, if you'd like to connect, feel free to reach out. You can find me and my courses on my website at tonyalicea.dev. Shoot me an email. Find me on YouTube, Twitter. You can go to thesmythegroup.com to find out about how we help dev teams become their best selves and do their best work. But this talk is authoring HTML in a JavaScript world. And all of us, all of you that are listening, you all spend your time in JavaScript, whether we're writing TypeScript, whether we're dealing with databases, whether we're on the server, whether we're writing tests. Our life revolves around JavaScript. It's a JavaScript world. And yet there's three legs of the stool when it comes to foundational web technologies: HTML, CSS, and JavaScript. So in this talk, I'd like to challenge you to change your way of thinking, to change your approach to how you build your React components. What I mean by that is this. Let's say you get a prototype. This is a very simplistic example, but you get a prototype, perhaps from a designer, and now you have to implement it. What's the first thing that goes through your head? What are the first steps in your mind as you imagine implementing the prototype in React? Well, it may be that you start thinking about which will be components, how the component structure will be, what the CSS will be to make the actual website or web app look like the prototype. So really, mentally, we kind of start in the CSS world. How can I make it look like the prototype? And we start in the JS world. How can I make it work? How can I make the actual app do what the prototype says it should do? And then along the way, somewhere along the road, we put in some HTML. It really is a sort of structure, a scaffold, a skeleton on which to hang JavaScript code and CSS. And if we're writing JSX, you might say, well, I'm not writing HTML, but really we are, because they're both being converted into the DOM. And so ultimately to the user, it's the same as if we were writing HTML. So choosing our elements is something that happens along the way. I'd like to challenge you to change your mindset and instead think about HTML first. What would happen if we thought about our HTML first and then started thinking about how to make the application work, and the CSS comes along for the ride as we make it look like the prototype? Again, if we're just looking at the prototype and we're thinking about the HTML, what we're actually thinking about is what is the meaning of each of these pieces of information that we see in the prototype. If we're thinking about HTML, we're thinking about semantics. And the word semantic means having to do with meaning. So the entire point of authoring our HTML, and we're going to introduce that phrase, when we author our HTML, when we behave as HTML authors, meaning we're choosing our HTML elements according to the information and things that are happening on the page, on the screen, then we're dealing with semantics. We're authoring in a semantic way. Now, I'd like to talk about the benefits of authoring our HTML in a semantic way and what that really looks like. For starters, let's talk about learnability. We're all trying to keep up with the latest things happening in the JavaScript world. But HTML is a skill. HTML authoring is a skill, and it's a very learnable skill. Let's go, for example, to a website that many front-end web developers have never visited, the HTML specification. And in that specification, we have what is essentially our dictionary, the meaning of each of the HTML elements. I think every front-end web developer should at least be familiar with section 4 of the HTML specification, where it specifies what all of the elements mean, what they do. For example, the address element, I can click on it, and if I use that element, it represents, again, semantics. It represents the contact information for the nearest article or body element ancestor. So, in other words, if I have contact information for the page or for something that's in an article element, I can use address. That would be the most semantic choice. I would be expressing meaning as opposed to just wrapping it in a div. And we'll talk about that in just a bit. So the idea is that HTML is learnable. You can become familiar with the meanings of each of the elements, and that can help you in your work. Now, beyond that, we can talk about readability and maintainability. That's another major benefit of thinking about your HTML, of authoring your HTML and your components versus thinking about the CSS and JavaScript first. So what do we mean by this? Well, if I don't author my HTML, if I think first about the CSS and JS and just try to make it look like the prototype and work like the prototype, then I probably might end up with something that looks like this. I might have lots of divs and span div, div span, div span, div span. Because I'm really just using the HTML as a way to have if statements and things to return from my functional components and things to hang my CSS classes on. But I'm not thinking about the content. What does the content mean? Another way to think about it is that if I look at the prototype, I can first think about the content without any of the visuals. What are these things? Is it a header? Is it a name value pair with a name and then its actual value as far as like a title, like model, Corolla, year 2010? Is it a list? Is it a list where order matters or it doesn't matter? Is it address information? Is it contact information? And then we begin to semantically mark up our document. It might end up looking something like this. For example, the DL, DT, and DD. Well, if I go to section 4 and I look that up, I can see that DL, DT, DD, they represent association list, name, value pairs. So how can I mark up a name value pair that is a piece of data with its label that isn't a form element? Well, this would be one way. As opposed to span and div, I can do so semantically. Now, when we think about this, when we compare the non-semantic to the semantic, what are the benefits? The benefits are immediately the semantic version is more readable. I can look at the contents and understand what it is. And therefore, a year from now, when someone else on my team or me, when I return to look at these components, well, it's now more maintainable. It's easier for me to understand what they are, what they do, what their intent was. And when you think about coming back to look at your components, oftentimes these pieces of data aren't explicitly written. Often they're variables. So if you have div span with lots of variables, it can be very difficult to understand what you're looking at. On the other hand, if you're well marked up, if you've authored your HTML, the HTML itself is providing information to you about what that content is. Plus, also, if you're in the browser and you're in the browser tools and you open up the elements, now instead of digging through a bunch of div span, you're going to have elements available to you that can help you find your way as you're debugging, editing, etc. All of these are benefits to readability and maintainability of your components. So if I have In the future, a React component, and I'm using my JSX and choosing the elements that will ultimately end up being in the DOM, even just having good semantic elements returning from my React components and within my React components, I'm going to see that benefit. I open the component and I immediately have a better picture of what this thing is and what it does. All right, now, what's another benefit? Another benefit is accessibility. Now, when you think about accessibility, you might think about ARIA, right? But you can add too much ARIA. You can make things worse. The first step of accessibility, and ARIA is important, but the first step is good HTML authoring, allowing the browser or screen readers to use the elements as anticipated, because the people making browsers and screen readers, what are they looking at to decide how things work, how they interpret the HTML? They're looking at the specification, the HTML specification. So if I say that this piece of information, this piece of data, this interactive piece of my web page or web app, if I mark it up properly, if I author my HTML, now the user agent can do its work properly. By user agent, what we mean is a software program that translates content into the format a user wants to consume. See, our HTML is not about building visual web pages. It's about marking up information so that user agents, programs like our browser, like a screen reader, can then decide what to do. If I mark up a piece of text as strong, then maybe a visual browser will make it bold, and a screen reader will say it in a different tone of voice. It's all about how the user wants to consume the information. That's why it's called a user agent. It's working on behalf of the user, and by authoring our HTML, we're working on behalf of the user as well. We're making our React components more accessible. And this goes back to the foundations of HTML. Here's a quote, and I'll just focus on a couple aspects from the HTML specification itself. HTML conveys meaning, not presentation. So you don't have to change the page in order to have different presentations. And that includes presentations through various screen readers. For example, a blind user using a browser using speech synthesis might get different vocal tones depending on how we've marked up our apps, our web pages. So accessibility. Now here's another one. Performance. Do you think about HTML when you think about performance? You're probably thinking about your JavaScript, you're probably thinking about your database, you're probably thinking about network and edge functions, whatever it is that comes to mind. But you can vastly improve the performance of your React applications by authoring your HTML well. How so? Well, every element that you place in your component, every level of elements that you add becomes what ultimately? Becomes a node in the DOM. Becomes a piece of information in the user's device memory. Becomes something that the CSS has to traverse. Because when you do a CSS selector, you're asking it to look through the DOM and find certain nodes. The bigger, the wider, the deeper your DOM, the slower your application will perform. And that's not a new idea. For example, in the Google Lighthouse scoring, there's an idea of avoiding excessive DOM size. Now it says above a certain amount of nodes, 800 nodes, 1400 nodes, you're going to get into performance problems that will be flagged by the Lighthouse score. But that's not to say that all of a sudden, as soon as you reach that number of nodes, now you have bad performance. As you add more nodes to your DOM, your performance decreases. It's the amount of time it takes for the JavaScript to generate templates, or if it's pre-generated on the server, it's larger amounts of information being downloaded. It makes your CSS slower. And the browser engine has to paint all of these things to the screen, has to decide what to do. So as you're scrolling or you're opening and closing an accordion, the more DOM elements you have, the less performant those interactions will be, because the more the browser has to do. I've actually worked with teams who were having a performance issue on some complex dashboard or page in an app, and they were looking at the JavaScript and the database and the network. And in reality, we took a couple of hours to author their HTML. They had divs inside of divs inside of divs, large amounts of nested nodes. And the problem is with something like React, where, well, if I author poorly in a component, and then I put that component in a loop inside a poorly authored component, and I put that component in a loop inside another poorly HTML authored component, my final DOM can be far larger than what it looks to be in my component JSX. So they ended up with so many DOM nodes that was the performance problem. A couple hours of work, and we saw a massive performance increase by authoring properly, reducing the DOM size. Because when you think about the HTML, you tend to write less HTML. And you also tend to already have the placeholders you need for your CSS. For example, if I think about this semantic code, I am immediately starting to also see where the boundaries of components might be. I'm immediately starting to see where my CSS might need to hang, might need to be attached to these DOM nodes in order to match the prototype. But if I'm just thinking about making it look right, not only do I end up with non-semantic HTML, I tend to end up with HTML that looks like this. Nested, 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 because all I'm thinking about is, oh, I need CSS for that, let me add an element. Oh, I need CSS for that, let me add an element. And we end up reducing, negatively impacting the performance of our application simply by not authoring our HTML. Now, there's another benefit. And that benefit is future-proofing. Remember, we said that the idea is that you're telling the user agent what this thing is, what these pieces of information are. And that means if a future user agent consumes the DOM, consumes the results of your JSX, consumes your HTML, then it will be able to determine how to present to its users your information. For example, here's a new user agent, Safari for Vision OS. And when Vision OS and Safari on Vision OS was talked about, in one of the slides, it talked about interactive regions, meaning that you're looking at a web page. How do we know that this is something that I then can focus on, interact with, that I can copy paste, whatever the case is? Well, they look at the HTML, starting with things like buttons and links and menus. So in the future, if I use a p tag, a paragraph, instead of a div, then a future OS like Vision OS could say, well, the p tag is something that I can copy paste. But if it's all divs, we don't really know, do we? So if you invest the time now in your HTML, then you can save time later, and you make your app more future-proof, will last longer as user agents change in the future. So often the question is where to begin. I already have a lot of divs and spans in my React components. Well, some easy places to start putting your mindset into the authoring your HTML place. Think about elements that don't have default CSS, because often folks reach for divs because they don't have default CSS. But there are other elements that don't have default CSS, and you could start there. I want to show you one thing in the HTML specification. We can see that the div element is actually called in the specification the element of last resort when no other element is suitable. But there are many other suitable elements where we often use div. For example, an article, which is a self-contained piece of information. A card might be an article. A section of your document where there's headers, that could be a replacement for a div. The header element, we're often wrapping pieces. Maybe you have a header and a subheader and some icons. So we wrap those in divs. The header element could be perfect for that. And aside for something that isn't directly to do with whatever is on the page, like here's some other links, here's some other activities you can take on this particular app that isn't related to the page I'm looking at in the app. Those all can be direct swap outs for a div. And you can start to look at your content and start to think, well, is this an article? Is this a section? Is this a header? This is a side? And your team can actually have some fun having those conversations, because there may not be a correct answer, a perfect answer, but at least you're thinking about it. And you've decided as a team, you know what, we think this is an aside. And you will immediately see the benefits in maintainability, readability, when you're coming back and editing these components. So again, I challenge you, try a different approach. Instead of CSS first, keep adding HTML elements as I need, make it all work, make it look like a prototype. Consider swapping it. Start by looking at your content, authoring your HTML, and then begin to make it work. Begin to make it look like the prototype. You'll be thinking in a way that will not only be learnable as a developer, become accustomed to what the elements are and available, but also in a way that will help you have more readable, maintainable, accessible, and future-proof React applications. And that's it. So thank you again, and I hope to see you online. Enjoy the conference.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. I'm going to talk to you about another one of our gold sponsors, Cloudflare, where they allow you to build and deploy React applications in a fraction of time. And next up on our program is a discussion room on design systems. These amazing speakers will be there with you, so head on over to Spatial Chat and get in on the conversation. Next up, we're going to introduce you to our next speaker, John, who's going to be talking to us about Use the Platform. John is a senior software engineer at Netflix, working to improve the developer experience for other UI engineers. Previously, he worked at Amazon and Instructure, working on all things software. In his spare time, he's usually in the mountains or playing with his children. Let's head on over to summit-qna and leave some warm congratulations, questions as well, as we welcome John to the stage. John, the stage is yours.
Hi, my name is John. I work at Netflix, and today I'm going to talk about the web platform. So a common refrain we hear as web developers is that we should use the platform. But what is the platform? Who decides what's going to go into it? How do browser implementers decide what they're going to do and what they're not going to do? Can we as UI developers have a say in what that looks like? And the answer is yes, you is the platform. This is something that's actually open to all, and we're going to walk through an experience I had to show you how easy it is to get involved. So if we think about code, code lives on a spectrum, right? We've got our applications we're writing on the far left. We've got things we use like React kind of in the middle. And then we've got the web platform, the DOM, HTML, those kinds of things. Like those kind of, I don't know about you, but they feel to me like something that's just kind of there, right? It's good stuff for the most part. Occasionally I got to work around something weird, but it's just the world we live in. And so if we wanted to change something, we might view it as sort of a graph like this. It could be very intimidating to think about changing things on the upper right side. A lot of expertise needed, a lot of effort, a lot of process. Whereas things on the left side, that's easy, that's comfortable. We do that every day. And then open source libraries, frameworks, that's kind of in the middle somewhere. But this experience I had over the last year has totally changed this perception for me. Right? So about a year ago, I was at a Remix meetup. So Remix, if you're not familiar, it's a full stack framework for React that lets you build just really great web applications that perform really well. And I was doing some work at Netflix to support this internally. And so at the meetup, I was demoing some apps I built around this, right? So I've got a little to-do app I wrote. The app isn't very impressive, but it showcases some Remix features like progressive enhancement and optimistic UIs, and it's using Netflix component libraries and running on Netflix infrastructure. As I was demoing it, embarrassingly, the app was broken. And the app had worked before, so this is something new, something had changed. And what had happened was it actually upgraded to the latest version of Remix about a week prior. So before I get into the bug, I want to talk about how Remix deals with mutations. So typically mutations are always modeled with forms. So this row, for example, is a form that lets you complete or update or delete one of your to-do items. And so there's a couple little widgets here for kind of toggling completion or deleting things. And when I demoed the app, those two widgets were broken. What's interesting is because of progressive enhancement, you could turn off JavaScript and it actually still worked correctly. So it was only broken when the JavaScript turned on. And the reason why is the Remix team had fixed a bug, but in the process kind of introduced a slightly different bug. So the form data submission process they had, prior to this, it would clobber potentially other inputs, right? So if you had a submit button with a name, if you had another input of the same name, the submit button would just override what you had. And so they fixed that to say, no, we're going to append whatever the submit button has at the very end of the form. Now, for most forms, this would never matter. For my form, it actually did because I was relying on the order that things were serialized based on their order in the DOM, right? So I had like a default submit button when you hit enter. The completion icon was actually a submit button. So you notice it has a name, it has a value, and that'll set the right name and value for completion. And the delete button was also a submit button with a name and a value. And those would actually override other values I had later in the form. And so because now they were serialized in a different order, on the server side, it was being handled incorrectly. Now, most people would say, okay, whatever, I'll just tweak my form, that's that, and move on. But I'm not normal, right? And that's why I'm giving this talk today. But I was looking at this and I'm thinking, this regression will not stand. This regression will not stand, man. I did not want to change my form. I didn't want to have to do something just because they were wrong, right? And so instead I went and wrote a big ugly component so that I didn't have to, right? So I've got some hidden input shenanigans. That way I could still have my buttons work the way I wanted. This is kind of gross, but it let me keep my form the way I wanted. But getting back to our spectrum, right? Like I'm operating over in my code here, but like libraries and frameworks, that's a little bit approachable. I've done a little open source. Maybe I could help things along in Remix land. So libraries, right? It's pretty low on that graph. And so the first thing I did is I thought, I should actually file an issue. So the next day I went ahead and opened an issue on the Remix repo and said, hey, this is a bug, be cool to fix that someday. And left it at that. But a couple of weeks went by and I thought, it would actually be cool to fix this bug. Like I want to get back a little bit. It seems like an easy bug. How hard could it be, right? It ended up being a little bit involved, right? So as it turns out, browsers do know how to construct a form data object from a form, but they don't know how to specify the submitter in the right position. So to work around this, I thought, okay, one option would be I could actually implement form data construction myself. So I looked at the spec and kind of copy pasted the text of it and then implemented it, which is like 300 lines of code, which is kind of a bit much. So then the second approach I went with is like, maybe I can do those hidden input shenanigans, but do that in Remix. And that was a lot less code. But again, it's a little janky. I don't know if it's the best approach. But I feel a little better now because actually 6 months ago, Sebastian added basically the same thing to React proper with the form action stuff they added. So not terrible. I'm in good company, but I wasn't altogether, completely happy with these approaches. But I wanted to get the discussion going with the Remix team to see if we could fix it. And while I did this research, I realized, that smart browser people had been looking into this before. They realized there was actually a missing feature in the browser and in the spec as far as, how this could work. Because like I said, browsers know how to submit them and know how to properly put the submit button in there. But when you're constructing a form data set from a form, the form data object didn't know how to do that. There wasn't a way to specify the submitter. And so they kicked around some ideas as far as how that might look, what's the best interface, but nothing really had happened since 2019. And so I thought, okay, that's good to know. Maybe someday I can use that. That'll be cool. But in the meantime, I had another problem with my PR. So I made these changes, but the Remix team was in the midst of refactoring a whole bunch of stuff and kind of graduating this functionality from Remix into React Router, which meant I couldn't make those changes there. They'd have to actually land in React Router at some future date when that was done. So I kind of left it in a holding pattern, and a couple months went by, and finally the changes landed in React Router, and so I was able to make those PRs over there instead of in Remix. But then I had a new problem, right? So React Router does its testing with Jest and JS DOM, and there were some missing features, missing functionality in JS DOM. So if you haven't used JS DOM, it's a really great library, powers Jest, React testing library. It's primarily authored and maintained by Dominic, super smart guy, and I think of him as JS Dom, so now you can too. I gotta say though, working on JS Dom was one of the most positive experiences I've had in open source. So Dominic was super responsive, super kind, super patient with a lot of things I was working on and my questions. And so, yeah, working on JS Dom the repo with JS Dom the maintainer was fantastic, and I highly recommend it if you get a chance. So I got those changes in, and there were a few other things I learned about JS Dom along the way. So JS Dom, the repo, is a really great implementation of a browser in JavaScript. So what that means is it's following the same specifications, it's testing the exact same way, and it's using the same interfaces that browsers use to generate their JavaScript bindings. So that was interesting. And learning about this, I'm getting more and more familiar with specifications and the process of how these things work. And it got me thinking, like, maybe I could help that form data thing along. You know, the browser people recognize the need. Maybe we could get that discussion going again and someday actually use that. But again, like specifications, this is super intimidating, super daunting. How do you even do that? Like, that's at the top right of the graph. I don't know how does this work, right? So let's talk about some of the groups. There's the World Wide Web Consortium. They've been around since the beginning of time. And if we think about things like CSS or ARIA, they're driving those specifications and helping make the web better by building these standards. And there are various ways you can get involved. So I'd suggest following these links, checking out their GitHub. You can go comment on drafts and things like that. Another group is the Web Hypertext Application Technology Working Group. So this group was formed by browser vendors and other interested individuals, kind of an effort to move the web along in a more pragmatic way in touch with what web developers need. And if you think about the core things we use, like the DOM, HTML, these are all work streams driven by this group. And they are also on GitHub. And so each of these specifications is actually a GitHub repo, which is interesting. Additionally, there's another repo to check out called the Web Platform Tests. This is really cool. So the entire web platform is tested through the Web Platform Tests. And what's really great is this is a repo that's shared by all the implementations. So they push and pull in every direction. So, you know, if a new feature lands, it'll have tests here that the browsers then all use as part of their test suite. So I went back to this discussion and I realized it wasn't just a discussion, it was the GitHub issue on the XHR repo. And, you know, this is looking more and more familiar. It's a GitHub repo, and I see they have a contributing guideline and pull requests and issues and things like that. And so I thought, maybe I could open a pull request. I don't know what's involved and how hard it's going to be and might, you know, have a lot of meetings and take a long time, but let me just try. What's the worst that could happen? So I opened a pull request, and there are two things I did in this PR. So I wanted to add submitter to form data. So the first thing is to define the interface. What does that look like? So I went with one of the proposals on that XHR issue that I'd seen before. Looked good, and added that to the interface that browsers use to generate their JavaScript bindings. And then the other part of the PR is to change the text of the specification so that an implementer or a web developer would know exactly how it could work and how it should work consistently across browsers. And then the other thing to do in this PR is to link to another PR for the web platform test. And so I opened one of those and added a whole bunch of tests that look like this to test my new form data functionality that I wanted in a browser. So this is just one example, but you know, it looks very similar to other tests we might write in other testing frameworks in JavaScript. So I opened those PRs and went to bed. And I was shocked the next morning to see an affirmative response from Anna Venkestran, the editor of the XHR spec. Not only responding affirmatively, but also pinging implementers from the three major browsers. And I never in like a million years would have expected this. So it was super cool to see just how engaged and how involved they are and how helpful these individuals are in moving the web along. But so, you know, the thing about that is like, I didn't realize that browsers, by and large, drive the specification, not the other way around. So in order to make a change, you have to get buy-in from the browsers. And that's up here on the upper right as well. That's daunting. And then even if you do get buy-in, how do you get that on their roadmap to change? Like this seems like it's going to take a while. And so my spec PR was kind of languishing for a little while. And, you know, I didn't want to be that person and like ping them and say, hey, can you look at this? What do you think? Should we do it or not? Because they've got day jobs. I've got a day job. This is kind of this is a nights and weekends thing. But I thought maybe I could help the process along. Maybe I could build a POC. And so I did that in JSDOM, and that was pretty straightforward. But I thought, could I actually do this in Chromium or something like that? And I have no idea what I'm doing. I mean, let's be honest here. I'm a UI developer. I don't C++. Yeah, I've done some in the past, but no, I don't. Yeah, please no. But I went and looked at the Chromium docs. I looked at all of these great resources they have, and I found in about 3 commands I could have a working Chromium built locally. And while it took a while for the initial build, what I then discovered is I could do rebuilds in less than a minute. And that gave me the confidence then to start iterating. And so over the course of a weekend, I was able to get it actually implemented in Chromium. And based on this positive experience with how their developer docs work and just how easy it is to get onboarded, I went and looked at Gecko. And in that same weekend, I was able to get it working in Firefox. And again, similar process there, super easy to get going, great developer documentation. So based on that, I thought, cool, let me go post something on the spec PR, added the screenshots and pinged the implementers, and they responded all affirmatively, like, yeah, this is great, let's make this change in the spec. So we got the change made to the spec, but then the next thing is like, how do we actually make the change to the browsers themselves? How do we get involved in that process? And again, it's like, this is something I care a lot about. I mean, browsers are interested in doing it, but I don't want to be annoying. And so I thought maybe I can actually go implement it. So diving deeper into their dev documentation and processes, I found it was actually pretty easy to kind of take those POCs and implement them. And so I got different PRs opened and merged in the course of 1 or 2 weeks. So here's some takeaways I learned in working on all three browsers. So Chromium, here's kind of the quick hits. They use Garrett for code review. The code base is C++. They've got really good dev docs. Just read them closely. All the testing is with web platform tests. The process is a little involved to get a change in, but not too bad. And so from the time that you land a change until it shows up on your kid's Chromebook, you're looking at about 2 months. Firefox, it feels pretty similar. They're using Fabricator. The process is a little lighter weight. And so the actual time from merge to GA on your Linux laptop, it's like 5 weeks or so. And actually my favorite one was Safari. They're on GitHub, so that felt a little more comfortable for me. Just kind of what I'm used to, right? And the process is very lightweight. The only thing I'd call out here is the time to GA. It's kind of an unknown with Apple being a black box and their release cycles and that kind of thing. So you don't really know when it's going to show up on grandma's iPad, but it will come out eventually. So I got those changes in, and man, we're cruising along. This is exciting. I realized though, the other big thing is we got to document this thing because if nobody knows about it or knows how to use it, it's like, what's the point, right? So the documentation, this kind of, feels a little intimidating, but we're cruising. Let's go figure it out. And so MDN, as it turns out, it's also on GitHub. They've got really great tooling and documentation for getting started. So check out the content repo. You can pull down MDN and just run it locally. Another repo to look at is the browser compat data. So that feeds into those compatibility tables on MDN and can I use. So I went ahead and opened a PR for those. And so, yeah, got some stuff on MDN and got my compatibility table going. And it was really fun to watch kind of over the course of a month or two as those columns turned green for the submitter as things landed, went from experimental to actually being launched. Now, while all this was going on, I did discover there was an issue in JSDOM. I had caused some problems, had to fix those. I also needed to go get React Router upgraded to use the latest Jest to JSDOM. So how to do that. But all told, by the time this all got through, we were now at a point where these changes for the submitter were in all the major browsers, the latest versions. And so I was able to go implement a much simpler fix for React Router. What I ended up doing is just use the submitter if it's there. And if not, if it's an older browser, then we still go ahead and append the submitter entry to the end, which is fine for 99.9% of the time. For anyone who cares, I actually have a polyfill so you can make it work correctly in all browsers. But again, there's probably like 2 people in the world that care about that. But yeah, it's very cool. So I guess some takeaways, you might be looking at this like Dr. Malcolm, like kind of shaking your head at me. Just because you can doesn't mean you should, right? But I honestly don't care. This was such a great process. And I was so impressed every step of the way with the people that I worked with, from the library authors and maintainers all the way up through the browser implementers and the spec editors. Everybody was very kind, very very helpful and very welcoming. And the processes that they've created are extremely streamlined and make it very easy for anyone to get involved. So, whether it's like a little bug you want to fix, you have an idea for, improving the MDN docs, like whatever it is, this graph is totally wrong. I know your experience may vary from mine, but just from what I saw over the last year, I would redraw it like this. It's a much flatter graph. That little bump in the middle is not meant to throw shade. It's just, it's more to show how great things are on the right side and what a great job they've done. And so, I know I'm not a normal person. Everybody tells me that, and that's okay. But I'm also unremarkable, right? Like, this is not rocket science that I was doing. This is very well documented stuff, and they've made it very easy to get involved. So if I can do it, you can too. Thanks.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. Next up, we're going to go ahead and welcome Nicola to the stage, who's going to be talking to us about superpowers of browser's web API. Nicola is an experienced JavaScript software engineer with 7 years in the industry, more skilled in front-end development, with a level of experience in working with micro front-end architecture, designing projects as a set of standalone components that include their own interfaces, logic, and storage, developing many applications independently, and composing them all together in the browser with different integration techniques. Nicola, the stage is yours.
Hello, React Summit US. I wish you a warm welcome to today's talk. Today, we're going to talk about something called Web API. But before we do that, we will need to take a small step back and go to some JavaScript basics. If we see this example, and I ask you the question what the order of the logs would be in the console, probably most of you would say 1, 3, 2. And that is correct. But how do we know that? How do we know how setTimeout behaves? As we know, JavaScript is a single thread language, and let's visualize this a bit. There is a call stack. We execute a first function, which is synchronous, and then we log the 1 as a value immediately. But then the second one is asynchronous, and it needs to go somewhere else, not to block that single thread. And it goes to the queue once the timer is finished. In the meantime, call stack continues with executing the functions. Then event loop checks if the call stack is empty and pushes back the callback with the value of 2. But the main question is, where does the setTimeout wait while we continue with the execution of our code? If we Google this function, the first result we get is this one. So there is MDN documentation where we can see some stuff about setTimeout function. And here we can see that it's under a tab Web APIs. If we click that, we can see that basically Web APIs is a collection, list of APIs and interfaces, which we may use right out of the box when developing web applications. Basically, it's a functionality provided by runtime environments, in this case, our browsers. And if we scroll a bit, we can see that there are a lot of APIs, a really, really long list of APIs. And here we can maybe observe that there are some quite commonly known and used APIs like WebRTC, session storage, local storage, file upload API, a DOM API, and so on. But looking through this list, I was wondering, what are some of the exotic and not so commonly used APIs that we may use, which can give us our web application certain superpowers in certain use cases? So basically, we're here to find out that today. And like we established, the answer to this question about set timeout is Web API, which is basically a collection of built-in interfaces that allow developers to interact with our pages and provide some fancy functionality. I'm going to quickly introduce myself. When I was in high school, I always wanted to study psychology. Now I work my dream job at Vega IT, based in Novi Sad, Serbia, where I work as a development lead, which means that I teach people soft skills, how to communicate with the clients, how to deal with stress, how to do presentations like this, why not, and so on. My name is Nikola Mitrovic, and these are my Web APIs highlights for you for today. Okay, now we go to our first example for today. Let's say we have a page like this, and there is nothing there but the background. But once we scroll a little bit down, we can start observing that there is something in the bottom left corner. It's a small astronaut, which, when fully visible, he says, "Hello world." Once we scroll a bit up and astronaut is not fully visible, message goes away. We scroll again a bit down, and again, once the astronaut is fully visible, again he says, "Hello world." So how did we manage to do this? There is an API called Intersection Observer API, which basically figures out if the element is visible on a page or not. If we would build a hook in React for this, we would probably call it useVisible, and that hook would accept two parameters. It would accept the reference of the object that we're trying to observe, and we have a certain configuration options. One of those options is root. If we pass null, then we assume that we're observing the element according to the whole document. Basically, it means that we can have smaller containers with smaller scrollable areas, and we can observe some elements there. But if we pass null, we look according to the whole document. We can have a margin around that root, so we can catch that intersection a little bit earlier if needed. And we have a certain threshold, meaning that if we pass this value, we need 100% of visibility for the element. So we can adjust this accordingly. Then we would have a state called isVisible. And then we instantiate intersection observer object. In the callback, we get entry object, which has a property called isIntersecting. That property holds the information about the visibility of an element, and then we can set that to our state. What's left to be done is just to call observer method on that reference and return that state, and that would be it. The example with the astronaut was nice and cute, but you're probably now wondering what are some real-life use cases where we can use this API. We could lazy load images, right? So we load the initial content for the page, and everything below the fold, what is not needed initially, we can defer and lazily load. And once we scroll to a certain section, then we start downloading images and our other assets. We could create infinite scroll lists. For example, we don't need a library for this. We could have a list out of 10 elements. We could have a separator at the end of that list. And once we scroll back and that separator is visible, then we trigger the next request. We could defer animations, so we don't need to run animations if the certain element is not visible on that page. And by doing so, we can save some computer power. So we don't need to run some JavaScript if element is not visible in the viewport. One thing to always consider when using some of these APIs is browser support. If we look at the major vendors, we can see that this API is fully supported. So great news, we can safely use this in all browsers. Okay, now we go to our another example for today. Now, I'm going to do something with my personal preferences. I'm going to say that first note that my laptop is not on the charger, right? And then if it's not on a battery, I'm going to say if my laptop is inactive for 1 minute, it will turn off, right? Also, I have my phone connected next to me, which has the same setting. And we're gonna have the same application. So note by the URL that we have the same application and the same code running behind these two examples. Now I'm going to restart the timer for the both of applications at the same time, hopefully. Okay, and here I'm going to click this toggle, but for the mobile version, I'm not. You may notice that at the very beginning, I didn't talk much about myself, but now we have a minute to spare, and it's my time to shine. I like to travel, and when I do, Italy is one of my favorite destinations to go to. The architecture, the people, the wine, pasta, it's all amazing for me. So it's inspired by that. Recently, when I get home, I like to prepare food for myself. So I go to some cooking recipes website. My phone is next on a counter next to me, and I'm preparing that food. But after a minute, something happens. And we're just gonna wait for a few seconds. Okay, after 1 minute, my phone turns off. And now with the sticky fingers, I have to unlock my phone again. Note that the timer went to the 0 seconds here, but went to 1 second on my phone. It's simply because my phone turned off, and we have lost the connection with my phone. Once I touched it again, then my phone turned on, but again, we need to unlock it and use the phone again properly. Here it didn't, because we have the most awesome feature, which says basically, hey, I'm cooking, do not turn off my screen. So how did we manage to do this? There is an API called Screen Wake Lock API, which prevents the device from locking, although our personal preferences said something different. And it can only work if the document is visible on our page. If we do this in React, we would make a hook called use wake lock, and it looks something like this. We pass that toggle boolean, which is turned on or off, right? And if it's turned on, then we call request wake lock sentinel function. That function will call on a navigator. We have wake lock object and a request method with the parameter screen, and that function call is a promise. It's a promise because it can fail in certain use cases. For example, if our battery is way too low. And now the situation is a little bit trickier than in the previous example, because we need to put this in a reference. We need to do that because if we put it in a state, then we will lose the previous state, and this function returns a certain value. We need to clear that value, exactly that value in memory afterwards when we release the lock. Otherwise, it won't work. That's why we need to put it in a reference. And then we return if we have the lock or not. And when we release, once we again toggle back off, then we need to call the release method on that very reference, and we need to clear that reference. So those are all necessary steps to be done. Otherwise, the lock will remain in memory. Again, some of the use cases for this: reading an ebook, presenting to an audience, following a recipe, map navigation, or scanning a QR or barcode. Again, if we look browser support for this API, now we can see that the situation again is a little bit different. Chromium-based browsers support this feature, Firefox doesn't, and this sign means that it's in experimental phase for Safari. So they have some work in place, but not fully. One more thing to notice about this API is that there's a certain device support. So some of the devices support this feature, some not. For example, I have an iPhone and whatever I did, I couldn't make this feature working, although I use Chrome. I think this has to do with the fact that the Chrome is just a skin for the iPhone, and it's basically Safari under the hood. It uses WebKit engine to run the code, but that's something we have to deal with when using this API. And moving on to our last example for today. Here we have an example of summit-qna, which translated to English means spaceman. Summit-qna is a little bit futuristic app, few thousand years in the future, where in the backend we're communicating with the NASA's API, which retrieves us the list of all habitable planets. Now we can search through that list and choose where we want to go to the vacation. But in the future as well, we have some offline connectivity issues. If we go offline, and if I tell you that hovering over this Explore button will trigger the request, you would probably expect that request happens in the network, but if we are offline, that network request would fail, of course. But we may notice that there's nothing going on in the network, but in the Applications tab under Background Sync, there is something else going on. If we click, we will see the loader. Basically, our request hasn't gone yet. And here in the background sync, we can see that there is something called a register event. Register sync. Once we go back online, then we have dispatch sync event. Our request went on, and if we wait a bit, once that request is finished, then we will have the third event, which is called sync completed. Now we have the list of our planets, and we can search and decide where we want to go to the vacation. How did we manage to do this? There is an API called Background Sync API, which basically provides a way to defer a task to a service worker, which we can run in the background. If we build this example in React, we had that link. Once we hovered, there is on a navigator inside of a service worker, there is a ready object, which is basically the registration for the background sync. And after that, we need to call sync and register method and pass a tag of a task. We do that because we might have multiple tasks running in the background while we are offline. And inside of our service worker, what's left to be done is just to compare the name of that tag. And once we get that event, then we can continue with our request. Of course, some of the use cases are offline UX. And maybe if we want to send an email, but we went offline in that very moment, we can recover for that and run that task in the background, and which will be continued once we go back online. Again, checking the browser support for this API. Not so well at the moment, but we'll wait for a bit for this because this is quite an awesome feature. In the previous example, if you have wondered how did we manage to pass the data from the service workers to our component, there is an API called Broadcast Channel API, which is basically a channel for the communication between same contexts, which means if we have same windows, tabs, frames, or iframes, which are on the same origin, then we can communicate between those origins. And it goes both ways. In our previous example, in our service worker, we need to connect to a channel. We create a new broadcast channel and connect to it. And we, through the post message, we can send certain information to our component. In our component, we subscribe to that very same channel. And on a message event, we will get, as a parameter, we will get the data that we sent from a service worker. Again, some of the useful use cases is to detect user action from another origin, or if we have multiple tabs open for the same application, if we log out in one, we want to log out user in all tabs. Browser support in this case says all cool, all good. We can safely use this API. Unfortunately, because we don't have too much time, we have to stop here for today, but I'm going to give you some bonus points, and I hopefully inspired you enough to go and search some of these APIs on your own. But here are some more of my highlights. There is a beacon API, which basically is used when you want to send a request, but you don't care about the response, useful for analytics. There is a web speech API, page visibility API, if you want to track the visibility of the whole document and not a certain element. There is a network API, which gives you your network system information. There is a web share API, which can share information, share files between different devices. There is a background fetch API. Basically, if you want to download a huge document, but then you go offline, you can continue with the download once you're back online again. And of course, one of the probably most exciting and new ones are Web Authentication API, which is basically a way for the passwordless experiences. We won't need passwords anymore. In the future, we could just authenticate with our Touch ID, with our face, or with our USB key, or some other devices. So really, really exciting to see how this API will turn out. And at the end, some of the takeaways. We have seen that some of these APIs have no browser support at this very moment. Some of that support is in experimental phase. We have to watch for the device support in some cases, and there is a certain TypeScript support that is lacking. But why should we use this API and adopt this mindset? Because it's standardized code, it's standardized code, it's standardized code. I probably could not stress enough how important this is, especially in today's web development, where we have a new framework, new library each week. This is like a single source of truth. This is standardized code. We can use it in all browsers. So it's really, really important. Most of these APIs are really easy to learn. And by adopting this mindset and using some of the built-in functionality in our browsers and not using the libraries too much, we can increase performance as a side effect. Of course, I'm not saying that we shouldn't use libraries and shouldn't reinvent the wheel in the certain use cases, but in some use cases, we can probably build some features on our own with the help of these APIs. And that brings me to my point that with great power comes great responsibility. So I felt like this is my responsibility to say this to you. I wanted to talk a bit about our planet. If you're having a 404 facial expression, like not found at the very moment, like what does our code has to do with our planet? Well, it kind of does. We build our React application, we run a build. There is an output for that build. We deploy that our HTML, CSS, and JavaScript files to some cloud providers which are distributed across the world. They are in the data centers. Those data centers have a lot of computers, are basically essentially a lot of computers next to each other, and they're all plugged into electricity. In fact, so much that internet is consuming 21% of the all electricity in the whole world, which is really staggering information for me, if you ask me. But luckily for us, there is a very cool application called a website carbon calculator, which can check out the carbon footprint, our website traffic, energy and intensity, and data transfers. So I would highly advise you to use this application and go and check how green you are. This is super important because we have only one planet. This planet is our home. And if we're not kind to it, one day it's going to be too late. So what we can do is all of us can take action, join forces, and in that sense, we can provide a big results all together. Thank you so much for coming today and for hearing me out. If you want slides to recap and to go over them again, this is the QR code. You can scan it. You can write me. This is my email. You can go to my GitHub and revisit all examples that I've built. Thank you so much for coming.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. Now let's go ahead and give a check out to some of our silver sponsors. We have SourceGraph, Reply, Canva Developers, and IMGIX. And next up on stage, we have a duo. So we're going to welcome Dural and Alicia, who are going to be talking to us about how to use Suspense and GraphQL with Apollo to build great user experiences. Dural is a principal software engineer at Apollo GraphQL, maintaining the Apollo TypeScript client, living in beautiful Colorado, USA. He loves the art of software development and finding creative solutions to challenging problems. Next up, we have Alicia, who lives in New York City with her wife, son, and her rambunctious cat. She loves ECMA script, building in open, and making plotter art with two rusty drawing robots. Let's go ahead to summit-qna and leave some congratulations and ask all of your questions as we welcome Dural and Alicia onto the stage. Folks, the stage is yours.
Hi, everyone. So today we'll be talking about how to use Suspense and GraphQL with Apollo Client to build great user experiences. But first, let's quickly introduce ourselves.
So I am Gerald Miller. I'm a principal software engineer at Apollo GraphQL, working as a maintainer on Apollo Client. And you can find me online at Gerald Miller.
And my name is Alessia Belisario. I'm a staff software engineer, also working on Apollo Client, and you can reach me at alesbell. So first, we'll be starting with what this talk is about. And we'll begin with a brief overview of React Suspense concepts. Then we'll look at a real client-rendered application that's using Apollo Client's new Suspense hooks, officially released in August of this year, to see what can be gained from pairing these technologies.
And also importantly, let's talk about what we're not going to talk about today, which is React Server Components and Streaming SSR. While super cool and a lot of great things happening there, just not something we have time to touch on. If you are interested in those, we highly encourage you to check out our experimental package at Apollo Experimental of XJS App Support. Shout out to our co-maintainer Lens, who has done a lot of the legwork in this. Also, we're not going to be talking about implementing Suspense support in a data fetching library, because trust us, it's actually a little more complicated than meets the eye.
Okay, so let's go back to January 2018 when Andrew Clark tweeted this out. Andrew Clark is a member of the core React team, is currently working at Vercel. And this tweet was sent out into the universe January 2018, as I said, more than a month before Dan Abramov would deliver his JSConf Iceland talk titled Beyond React 16, with some of the first public demos of Suspense. And I think this is a good place to start because what Andrew's talking about here is very relevant to Suspense and what we'll be showing you. Andrew said, one reason iOS feels so much nicer than the web, fewer unnecessary loading states. Look what happens when you tap an option in the Settings app in iOS. Instead of transitioning the view immediately and showing a fallback spinner for a split second, it pauses for a moment, prepares the view. When the view is ready, it slides in. And it just feels so much smoother than if you would see a flash of a spinner, right? So this is one of the things that Suspense helps us do, coordinate these transitions in our app for a really, really nice end user experience.
First, let's talk a little bit about the status quo today. So for those of you that have used Apollo Client for any amount of time, you should be familiar with the use query hook. So we're going to start taking a look at just an example that uses use query that should look familiar to all of us here.
So with a hook like use query, you're fetching a list of albums. And the important thing to note here is that the use query hook is going to give you this loading Boolean. And so our albums component that is going to be rendered when we click this button here is going to be responsible for rendering the loading fallback until the data is returned from our network request. And we see that dreaded flash of a spinner here. One thing before we look at some practical examples, dive into a demo, that we wanted to note here is that we're going to be talking a lot about loading states in this talk. But to reduce Suspense to just, this notion that Suspense is just about showing some spinners and a different way of showing your fallback UI in your app would miss the core value prop of Suspense entirely. And so that's another takeaway that we hope you have today, that Suspense gives us these really powerful tools for managing and coordinating transitions in our app beyond just the initial loading experience or the UX on navigation, et cetera. But it's really just these transitions that are so fundamental to how the user is experiencing your app and making those as pleasant, as smooth as possible. So today we're happy to announce
Use Suspense Query. So this is our new hook released in Apollo Client 3.8 that is primarily responsible for adding suspense support in your application. So what is Use Suspense Query? It is essentially a suspenseful use query that fetches some data that's integrated with React 18 Suspense, which includes support for React 18 transitions. So for the remainder of this talk, we're going to explore this API, what Apollo gives you, through the lens of this Spotify clone that we've built. This is fully integrated with React's with Apollo's suspense features, along with React to give you an idea of how working together with this technology works. I want to point out a couple of key things that we're going to be looking at here, which is these different sections. So each of these colored areas represent a different area of our UI that loads some data. So you see we have the sidebar over there. We've got our kind of main route area, which is that playlist. The top right corner, we've got that green user menu. Down at the bottom, we've got the play bar there. So again, each of these areas represent an area of our app that loads some data. So let's actually take a look and see what this looks like through the lens of use query as it is today if I were to load this page fresh.
Yes, and here we can see the starting point of our UI. So with the highlighted areas around each of the 4 boundaries that we see in our app that are each responsible for fetching their own data, we can see this popcorn effect as they all load in and stop rendering their fallback UI and return UI populated with data. So we see the sidebar comes in first, then the play bar at the bottom. The user menu at some point is also able to begin rendering with data, and then finally our route component. And so this is a pretty jarring effect with each component kind of popping in, whenever it's able to begin showing the user some data.
So what we're going to do is we are going to update this application from use query to use suspense query. So let's dive in and write some code together. So again, here's my application. I'm just going to refresh to show you that we're kind of in that same state that we just looked at with that popcorn effect. This is rendered using use query as of this moment. But we're going to start by actually converting one of our components to use suspense query. So just to give you a little bit of an idea of what we're looking at here, here's our main layout. You can see those areas. Again, each of those were colored areas. We've got the sidebar, the user menu, our route component, and our play bar there. But we're gonna dive into user menu first here. So this is fairly typical usage of use query. As you can see, we're calling use query hook down in our user menu component with that loading boolean. And to convert, I'm going to start up here by first just replacing my import from Apollo client for use query to use suspense query. And I'm going to go down to my use query usage. Let's make sure that gets called to use suspense query. We're going to see something immediately, which is that this loading boolean is not actually something that's exported from this hook when you convert over to this. And again, this is because in the suspense world, we're not managing that loading state directly in this component. So what I'm going to do is actually just delete that loading boolean. I'm going to remove that loading state altogether from this component. And with that, let's go to our application and take a look and see what that change did here.
Okay, so we're seeing a black screen at first instead of the fallback UI for the user menu in the top right-hand component in the top right-hand corner there, and that's because we haven't added a suspense boundary yet, so that React knows what fallback UI to show for that component. And so let's add a suspense boundary around the user menu to render that fallback UI.
Awesome. So to do so, I'm going to come into my layout here. And to start, I'm going to import suspense from React. And with that, suspense gives us a component that we can wrap around a bit of our UI. And this takes a single prop called fallback, which is the UI I want to show while the component is loading. So here, I'm going to use the user menu.loading state component as my fallback UI. As this component is suspending. So with that in place, let's go and see what that did to our application here.
Okay, and we saw the green highlighted box and no more blank screen on initial load. So we're now using suspense to render the fallback only for the user menu there. But aside from that, we haven't changed our user experience yet. So we see that suspense is not a magic wand that we can wave at our applications. But before we can look at the composability of our suspense boundaries and the actual power that we get from using suspense, let's add suspense boundaries around our other three components so that we can explore some of these concepts a bit further.
Awesome. So since we're already in the layout here, I'm just going to start here. And we're gonna start by wrapping each of these areas that load some data with our suspense components. So we're going to do our sidebar, our play bar, and then let's also make sure we do the route. And for each of these, let's make sure we're using the right loading state here. I'm going to use sidebar loading state for here, the route loading state for the route, and the play bar loading state for the play bar. And let's go to each of these components as well. We want to update these to be integrated with suspense. So I'm going to come over here to my import. I'm going to replace the import to use query with use suspense query. Go down to the usage here. Make sure I'm using use suspense query. Again, we don't need that loading boolean anymore, so I can delete that. And then my loading state, I can get rid of. Let's do the same thing for play bar. Update use query to use suspense query. Call it. Get rid of the loading boolean, get rid of the loading state. Hopefully you're starting to see a pattern here. And this is something that I want to point out too that's important when we were designing use suspense query. We wanted it to feel familiar to those that have used use query, so that hopefully in the vast majority of use cases, it should be as easy as updating this import and doing this. Of course, obviously you'll have to have a loading state to fall back to, but there we go. So with that update, let's go ahead and go back to our application and see what these changes did.
Nice. Thanks, Gerald. So again, we still haven't fixed the UX problem yet that we had with useQuery. And I promise we're much closer to actually being able to improve this loading experience. But Suspense is giving us a superpower now. Now that all of our components are relying on Suspense to show that loading fallback, we can use this API, this very Reacty composable API that Suspense gives us to group these updates. So let's replace all of these suspense boundaries with a single one around our entire application to see what happens.
Awesome. So this is where we start to see what this API gives us. So what I'm going to do is start out by wrapping my layout container with that suspense boundary. Let's make sure I actually am writing valid React code. Let's start with that. I'm going to delete these other suspense boundaries, suspense. And let's make sure I'm using the right loading state here. So of course, I shouldn't also remove my sidebar to put that back in place. But with that update, let's go and take a look and see what we've got.
Ta-da! So now we have a single update to the screen. And Suspense makes this trivial. We were able to accomplish this just by moving around some suspense boundaries in our layout. So let's take a look now at a different playlist and navigate around our app a bit more.
Awesome. So my daughter would be psyched if we all listen to her playlist together. So I'm going to go and navigate to hers. We'll go over to Ivy Dance here. And well, I wouldn't say this is a great experience. By navigating over, we're seeing that I'm getting my loading fallbacks again. So what might be happening here?
Yeah, so here we're seeing our first trade-off with the granularity of suspense boundaries that we're using. So as Gerald said, by moving the suspense boundary to the edge of our app, all requests to fetch more data that are causing any component in our React tree to suspend are all bubbling up to this outer suspense boundary, causing React to blow away all the UI in every single component in the React tree, suspending the whole app on any variety of interactions in our app. And we know that's not a great UX. We know we want to keep the shell of our app on the screen for an app like our Spotify showcase here. We definitely want to have our sidebar, our play bar at the bottom, and our user menu persisting on the screen as the user navigates around. So let's go ahead and introduce another suspense boundary to fix this problem.
Awesome. So I'm going to go back in here. And because we know the route component is what suspends as I navigate around, I'm going to wrap a suspense boundary back around that route component. Let's make sure we're using the right loading state here. And so now we've got this kind of nested suspense boundary here. But let's go ahead and see what that change did to our application. So I'm going to refresh. We're going to start back at our, in this case, Ivy Dance playlist. And let's just go back to our original React Summit US playlist here.
Nice. So we saw that on the initial load, we had 2 updates to the screen instead of 1. So that was another impact to the end user experience, that adding another granular or more granular suspense boundary had on our UX. But now when we navigate around the app, we're able to keep all of that existing UI on the screen, that persistent UI in the user menu, et cetera. So again, Suspense is going to really force us to think about these trade-offs in our app as we're designing and really being intentional about the placement of these boundaries. But I have one question, Gerald, because we saw that in this case, the playlist query is a little bit slower. And so we have 2 updates on the initial load. But what if the playlist, the request to fetch the data for our playlist route is faster than the other fetches that we're doing to populate the data in our UI?
Yeah, that's a great question. So to answer that, we're going to go back to this our playlist route here. And for those that with the keen eye, you've probably noticed these @synthetics around. These directives just help us artificially slow down parts of our query so that we can demonstrate some of these things. So in this case here, let's remove this synthetic timeout for the playlist because we want this to execute a little bit faster. So let's go back here and see what kind of user experience we get with this change.
Okay, and now we're back to 1 update on initial load. And Gerald, if we click to another playlist, let's confirm that we still have the expected behavior of our inner route component still suspending and being encapsulated by that inner suspense boundary. So it's really nice that now if our route component, our playlist data fetching is fast, in the best case scenario, we're going to have 1 update to the screen on initial load. But if it's a little slower and React essentially can't wait for it, then the worst case scenario is going to give us 2 updates to the screen. And for our app here, that's definitely the right trade-off in terms of the number of suspense boundaries and their placement. But let's remove all the other synthetic timeouts in our app here to get it feeling a little bit faster.
Awesome. Yeah, because obviously it'd be a terrible user experience if we ship this to our customers. Great for a talk, bad for an actual application. So we're going to go back in here to each one of these, and we're going to just delete each of those synthetics directives. And here we're going to see, as we reload this, probably something a little more like we expect in terms of load performance here. But as I load this, if you see that playlist loading in, we can see like it's still taking a little bit too long for my liking here. And that's because just I've taken some time to kind of figure out, like, there's a slow field in here somewhere that's just causing my query to take a long time to finish here. So this wouldn't be a GraphQL talk if we explored some GraphQL concepts to figure out how we can help ourselves here to update this experience. So we've got a new directive that is almost ready in the spec, the GraphQL spec that we can integrate with, that allows us to mark part of our query as some fields that can be loaded in later when they are ready. So we're going to go back to the playlist route here, and no surprise to the keen eye, we've got our tracks field here that has a synthetics timeout as well. But if this were a production application, we would assume that you've done some sleuthing to determine that, hey, it's these tracks that are really taking a long time. So what I'd really like in my user experience is to be able to show some of those playlist details first, and then as the tracks are ready and load in, be able to show those when they are ready. So again, we've got a new directive that we can use that works on fragments. I'm going to include that in here by adding an inline fragment with defer. I'm just going to wrap my tracks there with it. And let's go and see what that does with my application here.
Okay, so we've added 1 additional layer of loading UI here. So in the best case, we're back to 2 loading states. But to illustrate the worst case, let's see what happens if the playlist details takes a little longer.
Awesome. So I'm just going to add our trusty synthetics directive back here. I'll just add a second here just to get an idea. And let's go and refresh so we can see it fresh.
And now we see in the worst case scenario, we'll have 3 updates. If the playlist details takes longer than the rest to load, and then we're deferring a subset of the fields on our playlist query there. And finally, let's talk about one more aspect of our app, which is loading more tracks.
Awesome. So yeah. I'm going to scroll down here, or we'll start that again so we don't have that overlap. I'm sorry. All right. So I'm going to scroll down here because this wouldn't be a playlist unless I could listen to something towards the end as well. And let's take a look and see. And now, again, we've got a not so great user experience. So for those of you that have worked with Apollo Client for any amount of time, you know that anything to do with pagination, typically you use that fetch more API that we export from our hooks to be able to load the next page of data. So no surprise here, we've got a fetch more call as well. But in the world of suspense, fetch more is going to resuspend our component as it's loading. So what can we do to help mitigate this? Because obviously this is not a great user experience as I load down. Seeing my loading fallback for the entire route, not super great. So let's take a look at one more aspect that that React gives us to be able to handle this. As we mentioned in the beginning, React has this idea of transitions that you can use. So Apollo Client has integrated with those, and we're going to use a transition here, which is going to tell React to mark this as a essentially low priority update because we want to keep our existing UI on screen while that component is loading in the background. So to do that, I'm going to import start transition from React. Just to keep this a little bit snappier, I'm going to delete our synthetics here as well. We're going to go down to our fetch more, and I'm going to wrap fetch more in a transition. So to do so, we're going to do start transition here. And this is just takes a callback that I can mark an update in here as a transition, in this case, the fetch more. So let's go back here. I'm going to refresh. And let's take a look and see what happens as I scroll down now.
Much better. That's exactly what we would expect from our infinite scroll paginated query here. So let's recap. We started with use query and having components manage their own loading states in our Spotify showcase here. And then we updated each of them to use suspense query and explored how moving around the suspense boundaries would impact the UX in our app. We then showed how we can defer parts of our UI with the defer directive in GraphQL. And finally, how to use start transition to mark our fetch more pagination request as a transition to tell React to keep our existing UI on the screen while that network request completes in the background. And that's our demo.
So unfortunately, we didn't have all the time in the world to go over all the parts of the suspense story that we released in 3.8. So I highly encourage you to go to our documentation to take a look at use background query and use query, which give you the tools to help avoid request waterfalls, but also utilize suspense.
And looking to the future, we aren't done iterating on our suspense story in Apollo Client. The next minor version, 3.9, is currently in development, where we'll be working on a suspenseful version of our use fragment hook, which we've gotten a lot of great feedback about, and also a lazy version of use background query, another one of our suspense compatible hooks for preloading, prefetching data on some user interaction, which we're really excited about.
If you liked what you saw today and want to learn a little bit more about how this demo was put together, we've got a repo that you can go take a look at, clone and run yourself at our Apollo GraphQL org, the Spotify Showcase repo. So highly encourage you to go take a look. We want to use this as a teaching tool, and we as maintainers are going to use this as a means to kind of stress test new APIs and whatnot. So again, highly encourage you to go take a look at that. That, thanks so much.
Thank you.
Thank you for that amazing talk. Don't forget to address your questions to our speaker on Discord. And last but not least, we're going to go ahead and welcome Taz, who's going to be talking to us about Wait, You're Shipping React Native to the Web. Taz is the founder of Guild and longtime participant in communities around the world. He has over 2 decades of software experience, ranging from video games and robotics AI to consumer application development. He has served as a principal technical management consultant and is a serial startup founder. When he's not behind his computer, he can be found chasing his cat around the house or being chased by cars around a racetrack. Taz, the stage is yours.
Hey everyone, I'm Taz Singh, and over here is Mark Dalgleish, and I had the pleasure of chatting with him down in Australia, where this photo was taken right after he said, "Wait, you're using React Native on the web? Why in the world would you do that?" And so if you don't know Mark, he's the creator of CSS modules, Vanilla Extract, and more recently he's worked on React Native design systems over at Rainbow. Today he's doing awesome work at the Remix team over at Shopify, and this is the answer I gave to him back then. I said, well, Mark, this is why. Guild is the platform for communities, and communities are everywhere. They exist in all shapes and sizes, and we need to build an application that is also everywhere and can exist in whatever shapes and size these communities come in on all of the different platforms our users are on today. And so today when you're building a modern application, you need to cater to both mobile and desktop anyway. So looking at the usage metrics for Guild, 51% of our users are on mobile devices and 49% are on desktop. This makes sense because people are interacting with our platform on the go. They're looking for events to attend and presentations to watch. And all of that happens, primarily on a mobile device. On top of that, we're an early stage startup with a small team. We need every member of our team to be as effective as possible when shipping code. Every change to our code base needs to have the highest impact possible. However, if we were to ship code to every platform, we'd also need to support and test all of them. We need to test against every single web browser, we need to test every single mobile operating system, and it's the same story on desktop as well. We need a bunch of physical devices to test this all on, all from low-end Android devices to Linux boxes to everything out there basically. You can imagine additionally supporting multiple languages, for example, English and Spanish, where the number of items to test and support would start to increase exponentially, and it would just become infeasible for a small team like ours. This is why today we're focusing on the web platform in the English language at the moment, just to keep the support overhead manageable for our small team. And that's because the way I see it working is a bit like this, where this is the web platform that we're building for today. Once we introduce iOS and Android applications, we can see it looking a bit more like this, where maybe there's a common area in the middle. And as we continue to layer on more platforms like macOS, Windows, and Linux native apps, we can see the diagram looking a bit more like this. And for me, this is really where the power of leveraging React comes in handy. Where I see React being the superset of all of these platforms, and React Native can encapsulate the logic and orchestration for all of them to work together. So let's focus on React, shall we? What do I mean by that? Well, let's say you have an app in React that looks like this. It renders some component, right? Maybe you start to pass some data into that component and you get some data out of that component. That's the contract that your application cares about. That underlying component could be doing anything. That underlying component could be using React Native. It could be using a React Native view and rendering to a React Native text element. That underlying component could be using HTML elements, using in a way that's familiar to you if you're using React DOM today on the web. Or it could be using some sort of native view that's entirely platform specific, in this case an iOS native view that's actually dropping down to some sort of iOS native rendering logic itself. Fundamentally, React Native, and in our case Expo, makes it easy to write the common code on the left and then override that with something more platform specific towards the right just by the file naming convention. You can see I'm suffixing it with .web.js and .ios.js to kind of specify one for the web and one for iOS, and it will fall back, of course, to the more generalized .js version for other platforms, such as in this case Android or so on and so forth. For us, we always start with the common approach on the left provided by Expo, and then when we need to provide something more platform specific, we'll then override it with the appropriate file extension as I've described here. Because remember, the contract remains the same. It's just a React component that's passing data in and getting data out. The composability of this model is what really makes all of it possible, and for me, it never feels like I'm giving anything up. It never feels like I'm being let down. It never feels like I'm being run around and deserted. Thankfully, the Expo SDK has most of what you need to make all of these things work. So just looking at a few of their examples from their docs, we can see they have a blur view. They go so far as to list platform compatibility for this right inside their docs itself. So we can see it's supported on the web as well as iOS. But then what do we do for Android, right? Thankfully, a quick Google search just led me to this library, React Native Community Blur, which provides the same functionality for Android. Again, just by naming these files specifically for each platform, we can create an experience that works everywhere with a common API that works across both. Expo has a bunch of other components and APIs that you can leverage when building a cross-platform application. One of them is Expo AV for displaying audio or video. Again, they have a helpful list of platforms that it's all compatible with. Expo GL view if you're rendering OpenGL. This is again compatible across every single platform. On the web, it renders to WebGL, and fundamentally, you can go look at the docs for yourself on the Expo page. They have something for just about everything out there. The lovely thing is that all of these components technically work across any non-Expo React Native application, and they also technically work across any non-Expo web application. However, I haven't actually tried those combinations myself, so I can't speak to my own personal experience from them. I just know that it's all technically possible, so if you want to experiment, go ahead and feel free to let me know how it works out for you. All of this works because components are the building blocks of React Native. We think of components first, and we compose these components in order to make applications. If you want to blur something, you just compose in a blur view instead of thinking about the particular CSS properties to achieve something similar. If you want to display a video, you just compose in the Expo AV library and use their video component right then and there. If you want to display some graphics, you can just do the same thing with the Expo GL component. Fundamentally, React Native is true to React's core model of a component composition. And instead of worrying about platform specificities, we simply compose these components and let those underlying components do all the heavy lifting for us. We just care about that top level contract, and that's really, really what React is all about. Cool. So that's basically how we develop using the underlying React Native component system. And as you can see, it's everything we need, and we don't feel left out because we can always drop down to something more platform specific and compose components in a manner that's true to React. But how do we build an application out of this? Well, I'd recommend checking out a presentation I gave last year called React Native Everywhere. You can find that by heading over to my profile on Guild, just linked there in the top left, and check out the presentations I've given. I go into more detail about how I think about React Native design systems and also navigation within cross-platform React Native as well. But in essence, if I were to start today, what I'd recommend is summit-qna for the design system. We've actually started migrating over to this and we're seeing amazing results, so I'd highly recommend checking it out. It's styling and optimizing compiler and UI kit that unifies React Native and the web. That sounds amazing. I had the pleasure of hanging out with the author, Nate Weinhardt, earlier this year at App.js.conf, where we chatted about summit-qna on camera, which will be up on my Guild profile as well when we get around to releasing that. So check that out for a deeper dive, essentially with Nate. In essence, however, Their optimizing compiler for React Native applications creates straight platform-specific code for your application. This screenshot shows how we take generic React Native code on the left, written, of course, in the Tamagui design system, and on the right, it compiles down straight to the web platform itself. So just looking at the code on the left for a minute, and feel free to pause the video if you want to take a look at it a bit more, it's just using a stack component for layout and a heading component for text. That's the code you write, and that's all you need to think about when you're creating UIs. Just the top level of kind of how it works. It's highly declarative, and you don't need to worry about what's below because of React's component composition model. If I was to zoom into that compiled output, however, it essentially looks like what you'd write if you were writing highly optimized platform-specific code using React DOM and CSS variables for everything. The semantic HTML has compiled down to a div with an h1 tag in React, and the CSS uses all of the appropriate media queries to make it all work, just as you'd expect if you were to handwrite this all from scratch yourself. This works obviously extremely well on the web because you can then use those higher level components to compose your application and let the tooling worry about how to create something better suited for the specificities of that platform. Any serious application should of course be using a design system, and Tamagui is an excellent one. To stitch it all together, I'd recommend checking out React Native URL Router for navigation. It's essentially React Router with all of its state management goodness, plus React Native screens to give it that native kind of swipe from the edge feeling that you're used to when using a native mobile app. As we're currently building for the web right now, we're actually just using React Router directly at the moment. However, we're planning on using React Native URL Router when we do expand to mobile platforms as well. You can kind of think of React Native URL Router as a layer on top of React Router, so they're both incredibly compatible. So what we're doing is really a stepping stone towards that mobile future. And since we're rendering for the web, we need one key feature that you may not need if you're not rendering for the web. And that's server-side rendering, of course. But for React Native, because we're building a consumer application, I mean, of course, we want server-side rendering. It's of great importance for us from an SEO perspective as well as a performance perspective, just to provide that experience immediately when a user lands on our page. But yeah, how do we do this for React Native? Well, I'm sure when I say this, a lot of you think of Next.js, and well, yeah, you'd be right. They have a fantastic server-side rendering pipeline, and they spent a lot of time optimizing it, and it's really state-of-the-art. It's one of the best out there. But I don't quite think this framework is right for us. And the reason for that is, if we were to use Next, we'd have to build on top of their router. And while that in and of itself is fine, it doesn't really provide us a path forward for mobile as well. Sure, we could build out a whole separate navigation stack just for mobile and run that concurrently with a web navigational stack. And we have two entire differently navigational stacks in our application. But that wouldn't really help us unify our code across platforms. And fundamentally, it would just create more work for the team, as well as creating more potential areas of inconsistency because, I mean, it's just fundamentally two different things. And so I don't quite think Next is a fit for us for that reason. Of course, there's also Remix, which has a great server-side rendering engine built directly into it. Right now, I say our stack is most aligned with Remix, as we're currently using React Router, which also powers Remix. However, again, they don't support React Native URL Router, and so moving forward with Remix would mean that we need to do something different there once again. Perhaps it'd be less intrusive than Next because we're currently a bit more compatible with the Remix approach. And technically, they're both fantastic options maybe for you if you have a similar set of concerns. That's why I'm mentioning these, because they are truly fantastic world-class options out there. But for us, it's just the way that we think about this, in that we do want to unify our navigation and have one navigational stack across everything. And fundamentally, both of these aren't really solutions for us. But hey, maybe these are solutions for you. Now, fundamentally, what do we do though? Essentially, essentially, what works for us? Well, thankfully, I had the pleasure of sitting down with Evan Bacon from the Expo team to chat about this. You can see the recording of that following the link on the top left, or just heading to my profile, or just heading on Guild and searching Google as well. Overall, Evan is an amazing dude. He's one of those brilliant minds out there, and he has such unique insights on this space that it was such a blast sitting down and talking to him about the future of navigation and bundling from an every platform perspective within React Native. About 6 months after this conversation, Evan came out with Expo Router. Conceptually, I believe this to be the most future-facing solution that works with the majority of how we build our app. It's quite literally been built with cross-platform navigation in mind, and it was kind of spawned from that conversation I had with Evan, so obviously I feel quite good about the solution. However, it's just not quite there today. They don't have active server-side rendering or other web-specific features such as code splitting just yet. With Expo Router v2, you can render your React Native web apps to static files and serve static files if that works for your app. But for us, we do need active server-side rendering, as we do have dynamic data that we do want to be rendered on the server. Evan mentioned that this is coming, and he envisions the Expo Router project to be about 2/4 of its way to completion based on their current iteration today. So there's 2 more quarters left to really fulfill his vision, and in one of those, active server-side rendering and code splitting and et cetera, will be a part of it. And so, we'll definitely keep an eye on that, and maybe we'll look to migrate when that comes out. I am a little skeptical, however, because they are using React Navigation on the web platform, and I have a feeling that because React Navigation ships UI as well as routing, it would result in a larger bundle. Every project I've ever worked on, I've kind of overridden React Navigation's default UI. So I prefer if those two were maybe decoupled. However, again, the team there is smart, they're brilliant, they're good friends of mine, and I know they're working hard on this stuff. They take it very seriously, and they listen to feedback. And so that's kind of everything you could ever wish for in terms of a technology provider. And so these are all things that they know, and I'm sure they'll execute well on this in time when they hit those other 2 milestones and get it to a 4 out of 4 in terms of completion. So we'll definitely keep an eye on this, and maybe we'll look to move over in the future. But fundamentally, essentially, what do we do today? Well, I guess fundamentally, we'll just have to build it today. We'll just have to build it ourselves. And so rolled up our sleeves, and we built an entire server-side rendering pipeline on top of Cloudflare Workers to power Guild's web experience. It utilizes all of the latest React 18 concurrent rendering in terms of streaming responses over to the user. Cloudflare also informs us of the user's device type, which we then use to server-side render into the breakpoint that person is likely to get. So for example, if it's a mobile device, we'll render into a mobile breakpoint. If it's a desktop device, we'll render into a desktop breakpoint, and so on, directly from the server itself. And this is because React Native uses the window dimensions API and not media queries unless you're using something like Tamagui. But even rendering into a breakpoint on Tamagui, you need something similar to kind of tell you what device type to render into. So it's great that Cloudflare provides all that. And because we built it ourselves, we can actually make that optimization ourselves, because we essentially know the pieces of the framework that we're working with. But if you were to do this on something like Next.js or Remix or something like that doesn't support all of this and doesn't really know how to make that, like essentially glue those bits together, you may not have such a good experience. And so we're able to do so because we know all those pieces together. Additionally, because we're using Relay for our data fetching over GraphQL, we're able to embed all of that initial data over that initial payload to avoid refetching on initial load. So we just embed the Relay store directly into the initial payload. So when you first load the page, everything's just there, no additional data calls, no loading spinners, and that's it. So feel free to give it a go. Load up guild.host yourself and just see what it loads like. No loading spinners, should load immediately, and should work great. And fundamentally, the reason why any of this even works is because it's native. React Native is native. It's not React Mobile. It's not React Web. It's React Native because it's truly able to address the native platform on any platform. So on the web, it's really just like any other web application. Therefore, you can server-side render a React Native web application the same way you can server-side render any other React web application, right? You can use Next, you can use Remix, you can use whatever you want. It's just like rendering any other React application. Because fundamentally, you're just rendering the same thing all over again. All of this got me thinking, though, if React Native is truly native, can I stitch React Native into any application regardless of how it's built? I mean, Facebook's mobile app is technically just React Native stitched into other native views, right? That's kind of how the entire Facebook application works. It's just React Native next to native. If they can do this, if they can do that with this technology, I mean, surely it's possible for any of us to do as well, right? And so for me, I tried doing exactly that. I tried doing that for Guild's embeddable SDK, where we've basically taken all of the building blocks of our UI, created using React Native on the web, and powered by Relay for declarative isolated data dependencies, and taken all of that and provided it as a JavaScript library for folks to natively embed into any page. It's not using iframes because the challenge with iframes is you can't really operate outside the frame, so you can't open a modal with more information, for example. As you can see in this public code sandbox, which you can check out for yourself by heading to the link up there in the very top of the page, the MXCFMH link, the HTML is rendering a list of div tags with IDs. That's just what I specified in the HTML there in code sandbox. At the bottom, we're loading the Guild JavaScript SDK into the page right there and providing it with all of the different elements to render into with the various arguments from our SDK, and the Guild SDK is simply rendering the rest. With this approach, you can take the exact same components that we use to build Guild, and you can natively render that within your experience however which way you want. You can embed our event component directly into your conference's website and do ticketing through Guild. You can embed our presentation component directly into your personal website and have all of the history of all the different presentations you've ever given with a link back to Guild for more on your profile. Fundamentally, you can recreate our entire UI if you wanted to, giving you an easy path forward to deeply and easily integrate into any workflow that you have for your community. And this is what I mean when I say communities are everywhere. They exist in all shapes and sizes, and we have to be there as well. With our React Native embeddable strategy, we can truly exist everywhere. Now, I know what you're thinking. Wait, but this is for the web, right? I mean, this isn't really truly everywhere if it's not really on other platforms as well. I mean, yeah, you'd actually technically be correct. Right now, we are only developing for web platforms. However, this is not my first rodeo embedding React Native on other platforms. And I'm actually not sure if I'm allowed to say this. Let me just message the organizers real quick. One sec, sorry. Hey, am I allowed to say the F word on camera? Sorry, they're just typing back to me right now. No, I'm not allowed to say that on camera. That's a bit awkward. Well, I'm saying it anyway. Flutter. That's right, folks. In the past, I've embedded React Native directly into Flutter. I was consulting for a large Fortune 100 company where one team chose to use Flutter and another team chose to use React Native. However, the business wanted one consumer-facing application. So either the Flutter team had to recreate everything the React Native team was doing, or vice versa, or we could seek to embed one inside the other. And I took that as a challenge. For me, I knew that if we could stitch React Native into Flutter, then I knew that truly anything is possible because the technical capability of embedding React Native into any application would be truly proven. Because, like me, I'm sure in even just saying this, I'm sure a bunch of you are skeptical. Because Flutter renders very differently than React Native. Flutter essentially renders to a canvas, and so we can see that in the top screenshot where it's just kind of rendering to one view. This is basically a hierarchy, a 3D hierarchy of the different views, and you can see in the top screenshot it's a very thin hierarchy because it's basically just a single canvas rendering an equivalent UI across both. React Native renders a full tree of native views, which we can see on the bottom. You can see that there's several views stacked on top of each other in terms of that 3D view hierarchy there. So to be clear here, I'm not criticizing one approach over the other. They're both just different ways of building applications with different benefits. But this is fundamentally how the two render. The both of them render quite differently. And for me, it just fundamentally got me thinking, can we actually embed React Native into Flutter? Can we take our same React Native components and truly put that on any platform, regardless of how it's built? How native is React Native really? Well, it turns out, yeah, we can actually embed native views into Flutter. Under the hood, Flutter basically takes screenshots of that native view rendered on a separate thread and then composites that into the Flutter canvas. This does come with a performance hit inside Flutter, as you're no longer rendering inside Flutter's highly optimized canvas, but this method does technically exist. And it makes sense, because it's not really entirely feasible for Flutter to do everything within their system. Maps, for example, you want to be a native map that the user chooses. You wouldn't want to really recreate a whole maps component inside Flutter. So you want to just bring in that native maps component, and you want that to be stitched inside Flutter. So taking that and combining that with the ability to stitch iOS views, or take iOS views out of React Native and kind of stitch that into any platform, pulling that into Flutter, we were able to embed React Native directly into Flutter itself. In the past, our example of this was able to integrate so deeply that it was actually indecipherable to both the user and the developer. For the developer, they were able to feed props directly into React from Flutter State Management System, and were able to pass information back up through React handlers directly back into Flutter State Management System. It was so native, it was even native to developers. All of this is possible, again, because React Native is native. It respects the platform it's building on top of. I see it more as an orchestration layer that enables you to opt into the JavaScript ecosystem of tools and manage your native application more agnostically. By using React Native, I don't feel like we're losing out on anything that we didn't have before. Quite the opposite. I feel like we're gaining a superpower of opting into the React Native ecosystem to enable all of the things that we're doing. Now, I spent a lot of time talking about the why and how of our process. Let me take a moment to show you what we've built. This is the Guild homepage, built entirely using React Native on the web. Our navigation system transforms around user input and is responsive to different devices. That animation is done using React Native Reanimated. This subtle effect on the hero screen is done using Expo.gl, which is rendered to WebGL on the web platform. Again, it's fully cross-platform compatible. You can kind of see that wave moving in the background. That's all done via Expo.gl. Let's just take a moment to watch it then, shall we? Okay, there we go. This animation is again done using Reanimated. All of these components are actual React Native components. We can interact with them and open a React Native modal here, for example. So that's just a modal in React Native. These avatars down here, when we get up to them, I guess. All these avatars there, they're all created using Midjourney AI, and we actually use Midjourney to create the virtual avatars for each user as well. So it's Midjourney on top of Midjourney, and the animations, of course, done with React Native Reanimated. These presentation cards are using the Satori library, which uses React Native's Yoga layout system running on WebAssembly inside a Cloudflare worker to render an SVG. So even these images, even these image cards are actually rendered using React Native. And then scrolling down a little bit, there we go. This networks animation over here is the only web-specific thing on the entire page. We could have used React Native Skia, but at the time that we built this, the bundle size for that was about 6 megabytes on the web, which was just too large for this. Since then, essentially, William Candillon, if I'm pronouncing his name properly, has reduced it to about 20 kilobytes. So we can actually reuse React Native Skia on there right now. And this, again, is a React Native modal, a native React Native modal. So this entire page is built using React Native on the web platform with one little platform-specific override for that networks and guilds presentation. But again, we can now rewrite that using React Native as well, because William's done such a great job on the Skia project to reduce the bundle size to about 20 kilobytes for that. So fantastic stuff by that team. However, I need to ask you, looking at this, would you have been able to tell that any of that was React Native, or would you just think that all of that was just some other web app built in a more traditional way? So fundamentally, what does this mean? The way we think about it is that we have our UI and we have our API. Both exist as mechanisms of using Guild. Users can go to our UI on our platform and manage their community, or they can register for our API, manage their secrets, figure out the queries they need, perform their mutations, and build a whole UI themselves. And this may be fine if you want a custom experience that you have the resources to support all of that API development, but there's fundamentally a big gap there between using those two modes. There's a big gap between using our first-party UI and using our API. You have to build everything yourself. What if we can bridge that gap with embeddable experiences where you can take any part of our UI and place that where the traffic exists regardless of platform? What if React Summit wanted to use Guild for event registration and put that directly into their platform? Well, they can just take that attend button and put that directly on the React Summit website itself. By taking that experience and placing it where the traffic exists, they're able to leverage our UI and essentially get a fast path towards implementation wherever they need it. So this got me thinking. What if we took embeddable experiences seriously? What if we built our apps in a way that third-party UI was the same as first-party UI? What would that look like? Well, right now, we have all the various parts of our app built inside our design system as individual components that compose together. I'm sure a lot of you do this as well, because fundamentally, that's just how React works. If you're using Storybook, you likely export all of these components already, right? So then, taking a look at those building blocks and exporting those as embeddable experiences, we can just render our UI out of that. And again, this is just how you'd use React right now. But the gap that we found is making that embeddable. We had to write custom logic to essentially contain all of these experiences to work inside other experiences. Let me turn that light off. That's the part that we need to work on improving so that exposing these third-party experiences becomes as easy as mounting a React component. Furthermore, right now we have to aggressively code split our SDK to only load the JavaScript required when you use it. But what if we can leverage island-based hydration to only load the parts that are truly interactive, thus bringing down the web bundle even further? What would that look like in an embeddable world? And how can we make that easy for everyone? So for us at Guild, this is our next frontier. It's critical to our business to support communities everywhere in whatever shape and size they come in on every platform they're on. We need to exist where the traffic exists. And that's what I told Mark back in Australia. I look forward to coming back and telling you more about our journey as we work towards finalizing this and open sourcing our work to make it easy for anyone to use our infrastructure, because all of this has worked so well for us. And I can't wait for that. Until then, thank you, and I hope you enjoyed our journey. See you next time.
Thank you. Amazing talk. Don't forget to address your questions to the speaker on Discord. And that's a wrap. Thank you for all the wonderful speakers and wonderful audience. We enjoyed your questions, your discussions, and I know the speakers also appreciated that a lot.
Definitely. And I want to extend a huge shout out and thanks to the Git Nation team for organizing the conference. There are too many names to thank individually, but they did an incredible amount of work in front of and behind the scenes to make this all possible. So thank you, Git Nation team.
Whoop whoop. And thank you to our sponsors for supporting the React community. We wouldn't be here without your support, so huge thank you.
And everyone, again, your feedback is so important to us. It helps us make the conference better year over year and keep you having a great experience. So please, reactsummit.us/feedback, or just scan the QR code on the slide. We'd love to hear your thoughts, your feedback, anything you have to say.
Yep, couldn't agree more. We are looking forward to hearing it. And surprise, surprise, the React Summit is going to happen next November in the US. So grab your blind bird tickets. Look out for an email from us, and also you can find out more information on our website. Hope to see you again next year.
And again, everyone, thank you so much for being here with us today. This has been a blast. Bye, everyone.
Bye. So great hanging out with you, Josh.
Likewise.
Bye, guys.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
AG Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
AG Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed community edition, which you are free to use in commercial applications, and the Enterprise edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
We are one of the biggest fashion retailers within Europe.
We were looking for a provider or a solution that is helping us to provide the scalability and flexibility that we need, especially during times of peak traffic.
We choose Cloudflare because Cloudflare has many points of presence in Europe.
Cloudflare is a cutting-edge platform that solves many of the problems that we've seen in the past in terms of scalability.
Grid is a high-performance 100% React data grid that easily handles hundreds of thousands of rows. It's available as a free MIT-licensed Community Edition, which you are free to use in commercial applications, and the Enterprise Edition can handle millions of rows when you use our built-in server-side row model, and it even comes with integrated charts. Learn more at aggrid.com.
Get complete control over your content. Focus on code rather than assisting editors all day. Generate TypeScript types from content model and eliminate issues at build time. Use AI or integrate any other service. Deliver standout experiences with content.ai.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to